forse è questo che non va. Okay, there are some technical issues. Well, a special thanks goes to Digilab and its director, Paola Buzzi, for the continuous support, also as a member of our scientific committee. And to Sapienza, that has played a central role in these years. ArcheoFOSS does not belong to a single institution, and hopefully its organization will continue to migrate, both in other parts of Italy and also, hopefully, abroad. But I'm sure that Sapienza will continue to be an important part of it. Many thanks also to Paolo Carafa, Pro-Rector for the Archaeological Heritage at Sapienza University of Rome, for confirming with his presence here and also for the never denied support. The Direzione Generale Educazione, Ricerca e Studi Culturali of the Italian Ministry of Culture has been a strong sponsor. This is an important institutional and financial support, but it also is a matter of pride since officers of the ministry have personally expressed their interest and passion towards our meetings and the prompt publications. Fundamental here is the proactive support action of the ArcheoFOSS Association and its president, Gabriele Gattiglia. Finally, a very special thanks goes to Domizia d'Erasmo. With their tireless work behind the scenes, we would not been here today. So their effort and the effort of many other younger people involved in the actively and originally contributing to this event is the concrete sign that ArcheoFOSS is back again and is looking forward to its future. So I with much pleasure would leave the ground for their greetings to Paolo Carafa, as I said, Pro-Rector for Archaeological Heritage of Sapienza University in Rome, and then to the Director of Digilab, Paolo Buzzi. Thank you.
Thank you, Julian. I will follow your example, trying at least to speak in English. And good morning, everybody. Dear colleagues, ladies and gentlemen, good morning, dear friends. And first of all, let me give you a warm welcome from our rectress, Professor Polimeni. She can't be here today for more than one reason, you can imagine, but she's very happy to welcome you and to have this conference in Sapienza. On my side, I would like to thank my colleagues first for organizing all this and for inviting me. Unfortunately, I can also stay just for a limited time, but and this is a pity, at least for me. Julian has already stressed this. Even at just a first glance, the program is so rich, spanning from field activity to theoretical approaches, picking up a number of very, very relevant issues in practical activities and in many other sides of the scientific approach to knowledge, that is, from gathering data to the communication and enhancement of the cultural heritage. And so free and open source software will be your core business. I would like to say our core business for today and tomorrow, but I think that the perspective is much wider than this. And what is at stake, I think, even just looking at the program and knowing the colleagues involved in this kind of research since many times, are the strategies and procedures of scientific activities in terms of interoperability, data exchange, and especially knowledge sharing. These strategies and procedures are getting more and more innovative, effective, and solid from a scholarly point of view, of course. On the other hand, this situation, this scholarly debate, this, I would like to say, scholarly commitments in getting more and more shared approaches to the creation of a knowledge-based framework has a background effect also on another side, that is the administrative side. The perspective of increasing the efficiency of the knowledge system means at the same time increasing the efficiency also of the administration offices related to preservation, knowledge, and enhancement of cultural heritage. So on different sides, there could be a combined effect in translating the heritage towards the community, which is our, I think, main goal. We can discuss about this, of course, but more or less, I think it could be a shared ideas. And what, broadly speaking, technology, in this specific case, IT tools, can help us in doing is to translate the fragments, the material fragments of any past period into documents for the knowledge of any historical period. This kind of knowledge is the real enhancement of the cultural heritage, not on an economic ground, or not yet on an economic ground, because it's just the knowledge is the only way of creating something that can be effective also in economic terms. But more than this, I think that the strength of the technological approach to the heritage, such as the one we are promoting, you are promoting, and just introducing with these few words, is the is to identify an added value of any piece of the cultural heritage, that is the possibility of sharing this knowledge. So we are not just aiming, I think, at representing, reproducing, preserving single artifacts, monuments, landscape, which is the main aid we have at the first step by the technological approach, but is the possibility to translate this document into histories and processes that can be told, that can be narrated. And this is the beginning of a different chain operatoire, but it will lead us to a shared knowledge for everyone. So thank you, everybody. I wish you a good and effective work. And thank you once again for inviting me.
Buongiorno and good morning to all the attendees of ArcheoFOSS 2022, both in presence. Ah, perché non mi vedono? Ah, perché sono fuori da... Non che questo sia grave.
Lascialo dire al pubblico.
Here I am. So good morning to all the attendees of ArcheoFOSS 2022, both in presence and online. The Interdepartmental Research Center DigiLab of Sapienza University of Rome, which I have the pleasure to direct, is happy and honored to welcoming you all. When the organizers proposed me to host, in a way, this event, I was enthusiastic because it is perfectly in line with the aims and goals of DigiLab, that is promoting interdisciplinary scientific research in the broad spectrum field of heritage and cultural production, the management of complex instruments and laboratories in the sector of digital humanities for culture, and the communication and enhancement of cultural heritage, and the sharing of knowledge, as our pro-rector has just said very wisely. Strategical in this respect is the fact that more than 100 researchers belonging to 14 departments of very different nature are affiliated to the center. Moreover, many of the projects promoted under the umbrella of DigiLab go in this interdisciplinary direction, having digital humanities at the core. This is therefore the perfect habitat for such a stimulating meeting. Since there is nothing worse than welcoming addresses that are too long and therefore boring, above all when a conference is so rich in content like the one we are going to listen to attend to, I will stress just a couple of aspects. Never like this time the ArcheoFOSS conference is so international. When I saw the program, beyond the scientific content, which is really impressive, I was also impressed by the number of countries that are represented, from UK to Slovenia, Switzerland, and USA, from Germany to France, Spain, and Brazil, from New Zealand to Belgium and Austria, of course, Italy. A tangible sign of the progressive growing of the ArcheoFOSS community and of the urgency of the themes dealt with within it. The other aspect, in part already stressed by Julian, that I would like to emphasize is the extremely rational program composed of thematic panels, from the more theoretical and methodological to the more specific ones, which are always followed by a discussion and often opened by an introduction to the panel. In my opinion, this makes the difference from a single parade of papers, which are not destined to leave a long-lasting memory, and the real scientific dialogue. So the program of ArcheoFOSS 2022 is a real dialogue. You may object that this observation, to this observation that the proceedings are the real legacy of the conference. But this is true only in part, again, in my opinion. A lively discussion during a conference is invaluable and often the occasion for creating new networks and collaboration. Having said that, I wish you a good conference, a stimulated discussion, and a long life to the ArcheoFOSS community. Thank you.
And so perfect timing, we can get started. So I'll give the floor to the panelists of the first panel that's going to take place. Just try to solve an issue with the microphone, probably but I'm not sure about. Yes, okay. Probably let's use this one, the middle one. Okay.
Quindi devo spegnere questo? Parlate su questo. Parliamo su questo. Non si
Okay. Thank you so much, and welcome to the panel about archaeological stratigraphy. Every formalization tool is a building block to create interpretation, to create science. And the stratigraphic tool is by far the most accurate way to put together space-time, scientific reasoning, and historical theory. For that reason, the proposal of a panel about archaeological stratigraphy is a way to focus on one of the most important tools we have in order to create island of knowledge within a sea of uncertainty and unknown. So for that reason, archaeological stratigraphy for us in this panel is a way to investigate the raw archaeological record. We will have different speech about different ways to interact with archaeological stratigraphy. Aspects about the chronology, the creation of the chronology and archiving the archaeological stratigraphy, the analysis and synthesis through different tools like quantitative methods using the software are. And other tools that we will see along the way about especially the arithmetics tool. I give the floor to Stefano for initial considerations.
Yes, thank you, Emmanuel. And can just confirm what you are saying by introducing the session. And if I can create a link to what Paola Buzzi was just saying, this is a reminder that the idea of having this session was born out of a discussion of a previous ArcheoFOSS conference, when we realized that many people were working on their own tools, and there was an opportunity to come together and discuss different approaches or converging approaches, and possibly with the aim of creating new ways to share our procedures, new ways to share our tools, and ultimately to come out with something that is not limited to the presentation during the conference, but that can last longer. Most of the presentations in our panel will be in presence, but of course we're going to also to have one presentation online, and the discussion that will follow the session will be open to everyone, both in presence and online. I want to stress this. I think for all sessions that will follow, so feel free to ask questions when the time is right, and to collect questions along the way as you see links, doubts, problems, and opportunities along the way during the 6 papers that we will listen to. So without further delay, I would like to ask Brian Moody to come here, if Emmanuel can. And mi devi far vedere. Io ho parlato con la mascherina. Ah, già vero.
Prova di nuovo con il link.
So Brian Moody is the presenting author of a team composed by 4 people, with a paper about automating chronology constructions and archiving fairly along the way. Please, Brian.
Buongiorno, thank you for having me here today. So my name is Bryony Moody. I'm from the University of Sheffield. Full disclosure, I'm not an archaeologist, I'm a statistician. So I look forward to lots of fruitful discussions while I'm here from the experts. But what I've been working on for the past 4 years for my PhD is how to automate chronology construction and how to hopefully improve the archiving process as a kind of side effect of the work that we've been doing. So I'll start by talking a little bit about the part of the kind of chronology process that we're working on. So on a really basic simplified level, I know, but this is how we've been trying to view the process of chronology construction. In blue, you have revising the stratigraphic relationships during post-excavation. In yellow, all the boxes of obtaining absolute scientific data and evidence. So we focus on radiocarbon dating in particular. And then in red is the Bayesian inference side of things, which is the bit I really love, which is, you know, where we get our relative data and evidence from the stratigraphy, and then the absolute scientific data and evidence, and get the best date estimates possible, which it's been well established for years, this process, but it's quite time consuming and it's quite difficult to work on more than one chronology if there's uncertainty in the stratigraphy. So as a bit of background, prior to my PhD, Dai and Book, so my supervisor, Caitlin Book, are one of them, and Tom Dai, our collaborator, they proposed that to automate that process, we should, instead of using paper diagrams or diagrams made in Excel, for example, to manage stratigraphic data, what if we use mathematical graphs? And they're made up of nodes and edges, just like with a Harris matrix. You've got your nodes representing the context and the edges representing relationships. They have slightly different rules. It's a bit stricter in the sense that edges can only represent one single relationship. And this is really important for the automating bit later on. So an example here of how we try to get around this is this kind of equals between two contexts in a Harris matrix. We know we need to represent that somehow. So we just say that because in time they are the same, we want to combine that into one context. So obviously there's lots of nuances that do need kind of converting over, but for time, this is just one that I've shown. So we use a specific type of mathematical graph called directed acyclic graph. Because it's directed, it just means we can represent the above-below relationships in a way that the computer can interpret. And acyclic just means that you can't have any cycles, so you can't say that something is older than itself. So these are really easily interpreted by computers. We program in Python. We started trying it in R, but they don't have dedicated algorithms and visualization packages for representing mathematical graphs that were fast enough. So we moved over to Python. But there's loads of algorithms available for analyzing them. So this is not by any means an exhaustive list of the existing software, but this is just kind of some of the software that we've come across. So there's a lot of people, we were told in the UK, have tried the Harris Matrix Composer, but because of the cost, they tend not to use it all the time. And on the kind of Bayesian inference side of things, there's lots of established software. So OxCal, I think, is the kind of industry standard, and BCal. But the problem is that it's quite time consuming to put one model into that. So we're hoping to automate the process of revising the stratigraphic relationships and then building that chronological model. And hopefully, I'm going to show some screenshots in a minute. Hopefully it'll be clear what I mean by that. So I'd say the two pieces of software that are closest to what we do are OxCal and BCal. I know there's a lot of information on this diagram. I won't go through all of it for time, but there's lots of things that our software doesn't do. I will put my hands up. It's only prototype software, and but anything that's in OxCal and BCal could be programmed in if we had infinite time and funding. So there is the potential to do this. It's just we've not had time yet. And I'm not a computer programmer. I'm a statistician, so I've had to learn all of the software side of things as well, which has been fun, but it has taken time. What we mainly do is we incorporate the stratigraphy and radiocarbon date, so that's our relative and absolute dating evidence. We can account for things like residuality and intrusiveness, and then the grouping of phases. At the moment, we just group on one level from the front end GUI side of things, but the algorithm does have the potential for infinite kind of levels of grouping for quite complex sites. But the main thing that we hope, we've called it Polychron as a working name. We don't know if that will kind of stay on, but the main thing that we're hoping Polychron will allow us to do is build multiple models for a project, and then along the way, it automatically archives any data that the user puts in. So if they want to adjust their stratigraphic information, the software asks for reasoning for that. When they save multiple different stratigraphic sequences, it archives that all automatically in CSV format, so plain text format. So we're hoping that will go towards kind of interoperability and reusability, because any software can read in plain text format, and it takes away, I've been told a lot over the past 4 years that archaeologists are really short on time and money, and so anything that kind of does it for them without them having to dedicate that time, we hoped would be useful. So that's what we've been doing. And then it provides a graphical user interface for adjusting this relative data and evidence, so the user clicks with the mouse and plays around with it. So I'm going to quickly go through a workflow demonstration. As I say, it is prototype software, so it is in its infancy. But on the left here is a stratigraphic graph. So this is once you've loaded in the following data. You've got your stratigraphic relationships, your radiocarbon dates, grouping for context, and the relationships between those groups. So those relationships are just above below at this point. The user can say what type of group relationships later on. And we appreciate that this is not as intuitive as a Harris matrix. We're hoping that if I get finished in time on the Statsy stuff, which will allow me to be awarded a PhD, we're hoping that we can put in some kind of visualization options into here that kind of converts this to look like a Harris matrix for the user, but then it still has the underlying graph for the algorithm to interpret. Once the user's done this, I can't show the drop-down box because it wouldn't let me screenshot when I was using the drop-down box, but you click on Tools and you render your chronological graph. And it asks you if you think any of them are residual or intrusive. I said no for this purpose because I'm still working on that little bit, making it look a bit neater. But then you have these boxes that represent groups. And so the user can move those boxes around to say if they want them to be abutting, overlapping, or to have a gap between them, which seems a bit overkill for the three-phase groups that you've got here. But for some of the sites that we're looking at where they've got kind of 9 or 10 groups, it's just a lot quicker than the user manually inputting all the different relationships. So once they confirm the groups, it shows what the computer's interpreted this as. So here is overlap and gap. And as long as you're happy that the computer's interpreted your information correctly, you render the graph. So this is, again, we're not sure how useful this specific graph is going to be, especially from a visualization perspective, but it's just to show the user how it's rendered it and if they think it's rendered correctly. So if you want to remove anything, as I've said before, it asks for reasoning, and all of this information is then archived. So if I was trying to remove a context, it's asking me why. And then it says that you've already loaded your chronological graph. So this is now going to present a new chronological graph. Do you want to consider multiple models, or are you sure you definitely want to overwrite this and only consider this model? So it's reminding the user that they can consider multiple models. You just save it in the file menu and you can consider 2, that's not a problem. After that, you run the algorithm to run the underlying kind of Bayesian inference engine and to get your date estimates. So once this happens, it takes you onto this data results page, which then the user just right-clicks onto any of the context and they can obtain, it adds it to this context list in the middle at the bottom. And then they can render the date ranges in the middle top box, or they can render the posterior density plots. And again, these need a little bit of work and neatening up. So we're hoping to make these so that they can expand and you can save them in a nice kind of format that can go straight into reports if you wanted them to. But at the moment, we're just focusing on getting it to work. And you can also get the time elapsed between any 2 events, because after speaking to archaeologists, they said that's what they were interested in. So we popped that in. So the reason why we focus mainly on just getting functionality at the moment is because we want to be able to do a few things from a kind of graph theoretic and statistical point of view. So at the start with the stratigraphic graphs, it means we can check for cycles, we can remove any redundant relationships that don't tell us anything more about the ordering of the dates. And we're looking into algorithms that investigate the importance of a particular context. So say if you've not actually sent out your dates for samples yet, you've got a limited budget, which ones are going to be the best ones to send off that are going to give you the most information? we're looking into algorithms that highlight which nodes influence the other nodes the most. And then with the chronological graph, you can remove edges quite easily for residuality and intrusiveness, and automatically convert this expert knowledge to the algorithm without the user having to input it into something like OXCAL or BCAL. And we're hoping that by considering multiple models, we can quantify the suitability of given models using the statistical metrics. And that's what I'm working on at the moment. And we're hoping to have results on that within a year, because that's when my PhD finishes. So we've kind of got to have the results by then. So summarizing, because when you build chronological models, it's time consuming. We're hoping that by using graph theory, we can automate at least parts of that process and allow us to consider multiple models and also highlight important nodes in a stratigraphic sequence. Thank you. So yeah, let me know if you have any feedback. I would appreciate that, ideas or questions, and that is my email if you need it. Thank you.
Thank you, Bryony, also for sticking to the timetable. Our second presentation is going to be online, so I need some little help from Julian. And we have Joe Rowe, who is going to present about stratigraphic data in R. So we have just heard about working with stratigraphy data in Python, and I think we're going to see lots of these two languages being used also in other sessions. So please, Joe.
Hello, can you hear me okay?
Yes, perfectly.
Great, thank you. Yeah, okay, so thanks for the introduction. Yeah, my name's Joe Rowe. I'm currently at the University of Bern in Switzerland. Unfortunately, I couldn't be there in person today for various reasons, but I was really happy to see a session on stratigraphy organized this year at ArcheoFOSS. I'm kind of a long-term listener, first-time speaker here, so I think it's really nice to see. So today I want to give a brief outline of the capabilities of the statistical programming language R for handling archaeological stratigraphic data. I assume R is familiar to most or all of us. And I'm going to focus I'm going to kind of try and explain R's capabilities in general, but focus on these two packages that I've been developing for some years now on and off, Stratigrapher and C14. They're both kind of in a middle stage of development, so usable, but there's certainly a lot more features I want to implement one day. So R, I think, is in general very well equipped for handling stratigraphic data. Obviously, like most languages, it can handle plain text files well. So in terms of reading data, if you have your stratigraphic information in something that can be exported to plain text, then you're good to go, really. I do realize that's a big if that will probably be brought up in some of the later presentations. So yeah, reading a simple CSV, very straightforward. In terms of more complex formats, like this LST format that was used by ArcEd and Stratify, some sort of legacy software, it's not so difficult to, just reshape that a bit and import it as a table, as a data frame in R, and the stratigrapher package has a helpful function for that, and that framework can easily be extended to, I think, most plain text-based formats. But as we just heard, it's generally accepted that the most natural formalism for stratigraphy is a graph. More specifically, as Diane Buck persuasively argued, a DAG. Thanks for explaining that so I don't have to. So there's a lot of functionality for graph data, network analysis, and visualization in R. Many different packages. It would be impossible to go over all of them. But at the core, there are several options, but the most popular core package is iGraph. So iGraph is, in the first place, is a very large library of functions for representing graphs, analyzing and visualizing them. So, for example, we can find functions for checking the validity of a stratigraphic sequence, i.e. checking whether it's a DAG, also for removing redundancy with a bit of extra work. Another advantage is that it's the R package is a wrapper for a C library, so it is very fast. All the actual computation is being done in C++. And it's also pretty interoperable because along with the R package, you have Python packages, you have various other wrappers for the C library. So at least conceptually, the way you do things can be transferred between them. So some examples of what we can do with iGraph, and here I'll start to use just some helper functions that I have in Stratigrapher. So Stratigraph helps us construct a graph, and in the same way and make sure that it's a valid stratigraphic graph as discussed by Diane Book. We can use, as we saw before, we can use iGraph to plot it in a kind of default way, but it's very easy to customize this to produce, for example, the more familiar Harris matrix style visualization of the graph. That's just an application of a certain layout algorithm and style of connecting the boxes. We can also do more analytic-y things like checking for validity, checking whether it's a DAG, things like that. So this is another convenience function in Stratigrapher that simply wraps a more basic function in iGraph to tell you whether there are cycles or not, with the idea that you would then diagnose why these cycles are there. So far so good. We can load data into R. We can use these generic core packages to do network analysis kind of stuff. But then, what is really the point of having a package with just a few wrappers for another package? What I would say is that iGraph, like all sort of domain-specific languages in R, are very good as long as you stay within the fenced area that they're attentive for, but they frequently have this problem that when you try to go out of that framework, when you try to extract the data into another form, you look beneath the curtain and you see the structure of an iGraph object here, and it's just a complete mess. And you would have to spend, waste a lot of time figuring out, okay, which numbers represent the edges, which numbers represent the nodes, and transforming it into a function that you can use for another type of analysis, or to mix it with another type of data that is not amenable to be represented as a graph. And that, of course, is something that we kind of almost always want to do with stratigraphic data. I think the use cases for just analyzing stratigraphic data on its own is quite limited, and often what we're interested in is combining it with other types of data. So most classically with other chronological data to do Bayesian modeling or something similar. And there, I think you reach a more challenging aspect of R, and this has been my focus in developing Stratigrapher and some related packages more recently. And in order to try and solve this problem, I've turned to a thing called the tidyverse, probably familiar to anyone who's working in R. But this is, fundamentally, it's just a set of conventions that make a set of conventions for structuring these domain-specific languages in a way that they have similarities, that you can combine them without too much trouble. So, for example, this is why in the Stratigraph package we choose not a native iGraph representation, but a representation of the graph from the package tidygraph, which says, okay, a graph is fundamentally a combination of two tables, and these tables can be represented according to the tidyverse principles. It's also why we use ggraph for the visualization here. That works very well, works with ggplot. And in general, by having this tidy representation, by obeying those conventions, I think it makes it much easier to take your stratigraphic data and combine it with other types of data. So for example, I've also been in parallel developing a kind of sister package for the representation of radiocarbon data in a tidy way. I think this is kind of a natural pairing. And so you see, I don't have to go into details here, but it's again pretty straightforward to stick to a rectangular table format for radiocarbon, including for calibrated dates. And since you have tables for radiocarbon and you have tables for stratigraphy, it becomes much, much easier to mix them and to apply analyses that use both. So, for example, in terms of doing a Bayesian calibration, there's a rough workflow using stratigrapher and C14 at the moment where you can take your stratigraphic information. This is a slightly complicated code, but kind of the rough sequence is we extract some stratigraphic information, in this case contained within the table. We use a function of stratigrapher, which is basically a thin implementation of the CQL, so chronological query language used by Oxcal, to take elements of our stratigraphic and radiocarbon data and within R build the model and output that as a valid SQL. We can then take that SQL and pass it to Oxcal or anything else that supports SQL. For this, you can use the package Oxcar, I can recommend, by Martin Hintz and others in the Isaaciel group. It is simply a case of exporting the script to Oxcal and then reading it back into R for working with. Here, I have not actually run that code because it's super slow, but you can trust me that it does work. So that's the brief rundown. Like I say, the two packages I've been developing to try and make things easier in this area, they're both open source. Development is hosted on GitHub, so please do try them out. File an issue or a pull request if you find any problems. The one non-open source aspect of what I present today is Oxcal. It's well known that that's closed source, so I do think it would be nice to kind of eliminate that dependency, but that would rely on being able to implement something like the automated Bayesian algorithm from a graph that Diane Buck suggested and that Brian has been working on. So yeah, I'll be keeping a close eye on that project to see if I can incorporate some of those results. The slides, the source code for these slides are also on GitHub at this page, if you want to see that again. Otherwise, thank you very much for your attention, and I'm happy to answer any questions.
Thank you, Joe, for the interesting presentation and for sticking again to the time and for sharing even your slides with us. Okay, now we have Enzo Cocca, who is one of the first presentations we have that are going to present new developments in well-known tools that, in the case of PyArchinit, are a long-standing pillar of the ArcheoFOSS conference. So, Enzo, please.
Hello, everybody. I'm Enzo Cocca. I'm an archaeologist, Python developer, and a GIS specialist at CNR ESPC. And I'm the developer of one of the developer of PyArchinit. The aim of this talk, I want to present the new workflow to generate a Iris matrix from PyArchinit to extended matrix tool, and so how these two different software can interact. But what is PyArchinit? So PyArchinit is an GeoManager open source for archaeological excavation in different contexts. It was born as plugin for QGIS. It managed two different spatial DBMS, PostgreSQL PostGIS and SQLite Spatial Library. What is extended matrix tool? Is an add-on for Blender. The extended matrix is a formal language with which to keep track of different documentation analytical workflows like virtual reconstruction processes. It organizes the 3D archaeological record so that the 3D modeling steps are smoother, transparent, and scientifically complete. How works this workflow? So the tools we used to produce an array matrix from PyArchinit, we need obviously the plugin PyArchinit in QGIS minimum version 3.22, the graphics software that transform our data, collected data in PyArchinit in a dot file, and XML parser that we have I wrote to transform a dot file in GraphML, and I know the Yet software, but Yet software I know is not open source, but we need to unfunction that it has inside the swimline, but it's freeware. So the first things we do is we create an SU form. The field mandatory for create an SU form in PyArchinit is the site, area, the unit type, and SU obviously. The unit type you can choose. You can choose also the unit type for AM, also the classical unit type SU or USM or WUSM. Here you can see the reference from extended matrix palette 1.2, but there is the new one palette for the new extended matrix tools 1.3, but generally is the same. Changed some things in the color. The encode you used for archaeological stratigraphic unit relationship we use for classical stratigraphic relationship: covers by, fills filled by, cutted by. But for virtual stratigraphic unit we use this symbol, the arrow right, arrow left. And for validator node for virtual stratigraphic unit, we use the double arrow right, double arrow left. So when after we created the first SU form, it's possible to insert the stratigraphic relationship in the table widget here. We can add the row from the button plus and minus, and activating the option insert or update inversion relationship, this one. In case the SU form exists and the relationship not exists, a new inverse relationship will be created in the table widget. In case the form exists and the relationship too, the inverse relationship will be updated. In case the SU form not exists and the relationship not exists too, a new SU form will be created with the inverse relationship in the new table widget, like this one. So I can create the SU form SU1 unit type SU. I put a new relationship cut by 1000 example. A new form, a new widget appear where I can choose which unit type I want use it, like this one, and I can create automatically a new form, 1000 SU 1000 unit type SU, and insert the inverse relationship in the table widget. Like that is more simple. It's very fast to create the form and fill the data. The second step is creating the periodization. We have a special form in Bayesian to create a periodization where, where here we put the period, relative period and phase one, period 1, phase 1, period 2, phase 1, period 2, phase 2, etc. And we write the date in literal. And in SU form, we can put our periodization here. After this, when we finish to insert our relationship, we can create the graph FML. We can start to create the graph FML for extended matrix tool. So just push the update and a new table widget appear, and automatically it filled the data in the database for each form. After to do this, if we want to check if our relationship are correct, we have a function that print for report. The first report verify if the inverse relationship exists. This one could be fixed automatically with the button fix if there is some error. The second report verify if the stratigraphic paradox exists in a relationship to the stratigraphic definition. The third report verify if the period and type unit are correct, and the fourth report count the form created automatically. Now we are ready to converting the dot file, to create a dot file and converting in GraphML. So from toolbox, we push this button where a new widget appear, setting matrix. Just we need to push this. This one is the setting default, but we need just push this one, this button to create the graph ML, and it created. After this, it created the GraphML dot, the dot file, and now we can start to convert the dot file in GraphML thanks to this parser. The first write in Python. The first one collect the data from dot file, and second one convert this dot file in GraphML. In case we created our periodization where the first period correspond to the last epoch tag, we write in this widget true. If not, we keep empty and click OK. The GraphML is created, and when we open the GraphML with YED, we see this. We have put the some node in some row in a template. This node, this row are the epoch that we have created in Bayesian. So, example, contemporary, medieval, Republic, Roman Republic, etc. Each node are in the self period. We need just now remove from the talk the name of period because are the node loose, and start the swim lane from the layout, swim lane hierarchy. The result is our matrix in a template. In each row we have our SU properly. Here we can see some detail. We have the title of the matrix. We have the SU in each row. Each row has the name of the epoch, and we have also the new type for extended matrix for virtual reconstruction. This one is the last, the final result. So this we can export in a JPEG for our documentation, and the GraphML we can put inside to the extended matrix and associated to the 3D our information. This one is some example from an excavation Socotra. The next step, I'm not finished now, but very soon will be ready. I want to add to my parser the multi-area for excavation. So at the moment we can manage just one area at a time, but in the future so will be possible to manage more areas. So each column is an area of excavation, and we can grouping the structure for each area and period. So thank you for your attention. Here you can see our link for to download the Bayesian and extended matrix tool.
Thank you, Enzo. Very interesting presentation with a lot of code that was written to make it possible the exchange from different tools. Now I give the floor to Stefano Costa, who will talk us about the arithmetrics data package, the last version with new feature for the creation of stratigraphy data package.
Finally remove the mask. Thank you, Emmanuel, and thank you all for being here today. This presentation is a kind of update again on something that was presented a few years ago at a previous ArcheoFOSS conference, and it's about a very small Python tool that has this very long name and very short acronym, HMDP. I'll give a very brief overview of what was presented in 2019. It's a proposal for a data standard about stratigraphy data, and that is very much based on the work by Tom Dye, Caitlin Book, that was already mentioned before, with the addition of a crucial part, especially crucial for digital archiving, that is a metadata descriptor in a JSON format that is again not completely created from scratch, but based on the frictionless data standard and standard end tools. So basically, when we create such a data file, we have at most 7 CSV files that contain the actual data divided in separate tables, and then one JSON file that is called data package.json, and that contains all the information about relationships between these tables and metadata with information about who created the file and possibly other information that is still to be standardized in a way. But we can imagine things like licenses, author names, and so on. So this was already presented. It's published in Archaeological Calculatori together with the proceedings of ArcheoFOSS 2019. The HMDP tool is a command line program, so it's, well, let's say it's much easier to develop. It presents different problems than developing graphical interfaces, and this is especially important when the time available for developing such tools is very short. But of course, it creates a barrier for those who are not keen to work from the command line. This tool works with the existing arithmetic data package files, and so this means that it's compatible with what was developed for the HM2 by Tom Dye. The HMDP program can check for consistency of the data, so consistency both on a technical level and on a stratigraphic level. And the final result of this tool is to create a dot file, a graph viz dot file, that then can be transformed into images, into graphs, into something else for further processing. So if we run a check on a data package pointing the program to the JSON file, the program will happily report that the data package descriptor is valid, if it is valid, and that there are 7 data package sources, and there are 0 errors, which is very good. And running the matrix command will just create the graph.viz file, which is a simple text file that we can open. It's quite easy to edit by hand, and many years ago I started working on the first version, the first iteration, I would say, of this kind of tool, just by writing graph.viz files by hand. Then graph.viz can convert this kind of text file into a visualization. We have already seen that graph.viz is a crucial part of many workflows because it is possibly the only one or the most advanced tool for dealing with graphs. It's an open source tool. It's been developed for decades now, so it's very stable and it's reliable, and it's not very easy, again, to use for the casual archaeologists who maybe just interested in drawing their arithmetics. But we're looking at the arithmetic from another perspective here. The long-term issues that I identified after the 2019 paper was, first of all, the need to distinguish more between the data format and the tools that process the data format. So the choice of naming was not very fortunate, perhaps. The creation of data in this format is not straightforward. There are no graphical tools so far. Until this morning, we hadn't seen any tool that was capable of creating data with graphical interfaces. And the conversion of data from other formats like the bond stratigraphic package and other more established tools is not straightforward again. So today, I'm just presenting my work on the second of these issues, so the creation of data. And the new command of the HMDP tool is the Init command. And my thought when I started creating this tool was exactly something similar to Git init. So something that doesn't do the work for you, doesn't create your data, doesn't write software for you, but lays out the skeleton of what keeps the data in shape. So the command again works from the command line, and it can handle two different use cases. The first one that is already available and almost complete working is to create an empty data package that you can then start filling with data. And the second one is to add a data package descriptor, a metadata file, to a set of CSV files that already exist. I'm still working on this part, but possibly it will be ready in time for the proceedings. Because the file structure is strictly based on the proposal by Tom Dye, there are more or less 4 different possibilities for creating a data package based on how much information we are going to add to our work and to our later modeling of the stratigraphy. So the most basic possible set of data is based just on 2 tables, context and observations. So a list of contexts of stratigraphic contexts of stratigraphic units and a list of observations about their stratigraphic relationships. This is possibly a bit disorienting for many archaeologists who are used to think about their work with stratigraphy as something very complex, but as previous work has already demonstrated very well, since the work by Hirmela Herzog in the early 90s, this is the, let's say, the core data model that works for all stratigraphy data. A first step in adding complexity is to add inferences about sameness or contemporaneity of context. So the problem that Brian Mooney was showing about differences in the arithmetics, the traditional arithmetics, who allows us to say that 2 contexts are equal without merging them together, and instead the need to treat them as effectively one object in the processing of direct acyclic graphs. A second step toward complexity is to add periods and phases that can be used for the same kind of purpose that Enzo had shown with Pyrkinit. And finally, and something that goes well beyond the current capabilities of the HMDP tool, but again, the tool is agnostic to what can be done with the format. It just formats and allows to add metadata, is to add also the events and the event order that carry information about absolute dating be it radiocarbon, thermoluminescence, optical luminescence, coins, inscriptions, and so on. So this is just the link. The software is always the same URL as in the previous years. My main hope with this short update was to keep the discussion alive about having different tools that can work on a common data format and possibly see if this data format can then be proposed for a wider audience of archaeologists and of other people who work with archaeological stratigraphy, and without losing track of what we want to do with the archaeological research process. I think one crucial part of this this kind of tools is that we are moving beyond the idea of the Harris matrix as something that is created and then looked at to seek answers, but we have some stratigraphy data that we can choose to manipulate, not to change and arrange as we wish, but manipulate in different ways, to analyze in different ways, to obtain various visualizations, various results based on what we are looking, what are our research questions, and have the result as something that is part of the interpretation. We have heard Paolo Carafa mention the importance of open science. We're going to have an entire panel about open science, but the fact that all these tools are based on open source components that talk to each other or can talk to each other, and that we can formalize our research and analytical process with these tools and then ensure reproducibility of our process is perhaps the most important part of this approach, and possibly, I mean, the core question of this entire session. So thank you, Emmanuel.
Thank you so much, Stefano, for the very interesting approach and the fact that you stressed the opportunity to connect. And thank you to stay in exactly in the times. So I'm going to ask to Alessio Paonessa to come here for its presentation about linking stratigraphy, context, and interpretation, a starting proposal. Thank you.
Thank you, Emmanuel, for the introduction, and thank you to all the organization to invite me to speak today. And yes, today I will try to collect some thoughts about the stratigraphy context interpretation and connect them to a landscape graph. I'm just now in initial step of my research, so it's more, yeah, I said, a collection of thoughts. And how I got to the first example I will show you at the end of the presentation. So, how we define a landscape? I just propose now two possible definitions. The first one is from the UNESCO, and define the cultural landscapes, and the second one is for archaeological landscapes. Both interact with culture. So what we're seeking in landscape is how human interact with a territory and the natural processes. And we have, in my opinion, just to know a problem, we don't have a clear way to show how we think landscape in archaeology and how we try to get to the results when we give the interpretation for landscape. I thought that the extended matrix, how the extended matrix interacted with the Harris matrix and extended it, could be also useful for a new idea of landscape and how to connect landscape, archaeological landscape, to a graph. So we all know that what a graph is in discrete mathematics is a set of points collected and as nodes and then connected with edges. Is a really powerful tool, as we have seen already, and these edges and points and nodes can have different meanings. This type of graph can also be used in a very flexible way to become a knowledge graph. They are now a really popular topic for search engines, for example. But how we think about stratigraphy and how to connect the stratigraphy then to our interpretation, it has changed in time. And we can see that at the beginning, the stratigraphy was just a collection of layers, and inside the stratigraphy, then there was the information about every event happened in the past, and collected inside the ground. So single events with traces were not the focus at the beginning of our journey inside the stratigraphy. For example, for Lambolia, as you know, strata, so layers, were more important than single events. So Harris matrix shifted us to a focus on the stratigraphical unit. And as you know, it is the simplest trace of human activity in the archaeological record. Why is this important? Because it gave us flexibility. Now we can move to different units and connect them with a simple relation before after. It was then possible to order them in a documentation system displayed as a graph, and this was the first time we can see it. So how we can then think to extend it? So I think you all know the extended matrix. What is important about extended matrix and stratigraphy? The most important thing is that the standard stratigraphic representation, it's only a documentation system. It's mainly a documentation system. We don't have interpretation inside the Harris matrix. We have only the relative chronology, and every node represents a different trace inside the stratigraphy. The stratigraphic virtual unit in the extended matrix extends this perspective and inserts inside the graph the interpretation, because what we are seeing in a 3D reconstruction is not only what we have digged and then documented, but it's also what we are thinking it was in the past, and we cannot see directly in the stratigraphy or in the monument. So we can say that has switched to more general knowledge graph, instead only a documentational graph, if I can say so. And the arrays rules are not strictly followed, because now we can add with the edges other information to the graph. So I will go quickly. As we know, graphs are many implementations in archaeology as network graphs, house graphs, and what gave me really the idea to try to manage the landscape graph, it was the landscape graph in ecology. In ecology, we can see landscape is connected to a graph through animals, their movements, how they interact with a landscape, and with statistical analysis about it, for example, with proximity analysis. So they do not collect only what they see in the landscape, but they try to interpret it and to analyze it in other ways. So what was exactly my idea about the landscape graph in archaeology? I think that just to now we collect every information about the landscape in different ways. So if we have a survey, we collect the data in the survey and in a separate database. Then we collect other data in the GIS, for example. We connect them in a geographic system. What I think is that there is no explicit connection then to interpretation. So what we think about the landscape and we publish after the analysis and the data collection. So I would like to try to connect what we see in the landscape, so the data in the landscape, with a new graph. This new graph will it's like an highlighting of the different data and a connection with some data more connected to physical observation like stratigraphy, and extrapolate them, try to give some key feature like description, chronology, and functional interpretation, and allocate them inside a graph. So I will go very quickly to the final, to the initial example. We will have a landscape unit, a virtual landscape unit, negative landscape unit. You can see the connection with the arithmetic theory and the extended matrix theory. And this is the first example I will give you. It's from my doctoral thesis. I just tried to connect how the city next to the Torrente Nervia, the river, on the right part of the screen is connected to the Cabo Hill at the end of the plain. So I just connected the node, as you can see in the image, and I just gave them simple names where the city, the necropolis, and the road outside it are connected to initial interpretation and the visualization of the data. So here I'm showing that, for example, the road is missing to the connection, and we have to build it and to imagine it to connect directly the hill at the Roya. There is also a possible sea connection with an arbor, and those arbors are on the rivers. So Ner and Roy are the names of the rivers. We are not certain about the structure, if there was structure, there was no structure, there were only natural arbors. So I just added another node with interactive points, and then I added another information saying, okay, we should imagine something more than what we can see. And thank you for your attention. My mail is here, and I hope if you have questions, I'm here.
Thank you, Alessio, for presenting this interesting and stimulating approach to landscape stratigraphy. Now I invite Emmanuel to present about EMDB, yet another database for the stratigraphic record.
Okay. Thank you so much. I hope all the technical are okay. So, okay, yet another DB for the stratigraphic record. We are a team of different researchers aiming to try to answer to a question: why another database? Because there are plenty of databases out there for stratigraphic records. We made this consideration: creating and maintaining by yourself and without IT skills, information technology skills, a database for the archaeological record is not an easy task. It's not, let's say, for all of us, more if we are thinking about archaeologists. So there are a lot of online databases, but what if we can make it easier to do? Existing solutions have a lot of strengths, so you can work in a collaborative way online. There is a very robust technology that you can work with, making online shared databases. And more than that, you have an immediate online accessibility. So it's the paradise for data. But there are also weaknesses. It needs many information technology skills. If you don't have an organization, and you are, let's say, as a professional or researcher that is working by him or herself on the topic, maybe you don't have the skill to set up a server, to make a database, and to customize your tools. And if only a technician can make it accessible and take care of the database, you can also lose the capability of maintain and to save it, backup it somewhere. So we are thinking that online databases are the best solution. But in some cases, you really need something to start, something that can be very easy for you. We were looking for a simple solution, usable offline. Yes, maybe somewhere that you don't have online accessibility, usable with very limited information technology expertise, and in order to visualize stratigraphic data within a 3D environment, in Blender 3D, for instance. Blender comes with native SQLite support, so we can make it very easy. And we thought about an inclusive workflow, so that can be inclusive from a technological point of view, but also in order to combine different databases that are already there. You just import them in this system. The extended matrix database hypothesis is based on LibreOffice base and an SQLite template. Very easy, like the Microsoft Access approach that a lot of archaeologists used over the last decades. The results, now in the extended matrix 1.3 development channel, is a form for the USM with the creation of a template in SQLite 3 for the Italian masonry stratigraphic unit sheet, and an MDB for the USV for the virtual stratigraphic units to formalize reconstruction hypothesis, and the 3D visualization side inside Blender. So we made an add-on in Blender in order to just with a click import SQLite database with all your stratigraphic data and play with it inside a 3D environment, like a sort of 3D GIS. All the software is on GitHub, is open, reusable, and both the templates and the software. We made it in SQLite 3, like a DB, just to make this data structure, and we are sharing the empty DB, so you can use it by yourself or modify it by yourself. The file structure is 2 files. One is the LibreOffice ODB file with an ingestion form where you can ingest or visualize or print your and on the other side the EM tools, extended matrix tools on Blender, where you can join together the information we have on a matrix of areas, plus all the information we have inside archaeological DB, with all the information, with the photos, the areas, who is in charge of the excavation, all the information that is inside an archaeological sheet. Okay, in Harris matrix, extended Harris matrix approach, we have just the name, the epoch, and the chronological relationships, and the description of all the nodes. But we lack all information. So we have to put them inside. We tried also to import from a MySQL database, another project of the University of Milan, try to put inside our system this work using the LibreOffice base, and we made it. So it's just a test on reusing online databases that are already there. And here I want to ask to Christina, that is already online. I don't know if we can provide the floor, or it's possible.
I'm here.
Okay,
Thank
great.
you very much, Emmanuel.
Okay.
Yeah, I'll tell you about the slides. Thank you. Thank you very much, Emmanuel, for giving me the word. Another of the strong aims of this proposal is to be inclusive. So next, please. Thank you. The study of the historical and archaeological record is made up from different disciplines that require diverse information and approaches from different perspectives. The idea is to build a workflow that allows different disciplines to cooperate and integrate to create the most accurate representation of the past in order to record and study it. And everything that we're proposing in this conference is connecting all of them through the use of a graphic node formalization. Next, please. For now, we have focused on the area of virtual reconstructions of archaeological sites. The recording of these models through the use of virtual stratigraphic units, or USVs, is quite novel and even still in development. And therefore, we have tried to gather the most important information of these units into a table, creating a guide database that it would help to record it using LibreOffice. It also combines and adapts previously created methods for recording USVs, such as the reconstructive units presented by the University of Alicante in 2015, or the graphic scale of historical and archaeological evidence, and also the GraphML presented for the extended matrix. However, as you can see on this slide, it is not very user-friendly and not clear to read. So next slide, please. We have pushed to the need of the creation of a template or a form that would simplify the process and be more attractive to use in archaeological projects, maintaining the main objectives of being usable offline, low IT requirements or skills, and easy to transition to the 3D environment. This form starts with very simple information, such as the number of the units, the type, in this case, USV, the site and the site area, and the initial of the person recording it, and the date. Then it goes to collect a description of the reconstructed element, categorizing into types and subtypes and the years that it records, the periods, and the phase. The next section focuses on placing the recorded element within the extended matrix, asking for the virtual activity, its related nodes from the matrix, and all the supporting documentation used to back up the creation of this element and the liability of the documentation using the already named graphic scale of historical archaeological evidence. And lastly, the template records the reconstruction hypotheses, the alternative hypotheses, if there's any that needs to be noted, and an image of the recorded element to ease the understanding of the context flow. Next, please. As you can see, it is quite straightforward, and it aims to simplify both the creation of the reconstruction through easing and organizing ideas, but also to record these USVs. And these are some examples of how they would look like once they are filled in. Next, please. Now, moving to the next point of this presentation, we have to talk about how this information will be visualized. We have recorded our site in a database thanks to all the forms that we've explained, but we need to be able to visualize it and read it in a simple manner. The last aim of this database proposal was to be able to visualize stratigraphic data within 3D environments. And for that, we opted for Blender 3D through the EM tools. This phase is still a work in process with great potential, thanks to the work done by Emmanuel Demetrescu and Filippo Salas. And I would do my best to explain it today as clear as possible, the general concept of our work. Next. Just as a very quick summary reminder, the EM tool's main objective is to link the Harris matrix or extended matrix GraphML file externally created with the 3D model that it presents in the Blender environment. This file is imported through the first panel that you can see on top of the plugin, right on top of the red square shown on screen. And once the file is read by the tool, the stratigraphic units recorded in the GraphML will show under the USV and US manager with their associated description, as you can see on the slide. It is much more complex than this, the tool, but of course, these are the areas that I wanted just to point out and refresh in order to explain what we would like to comment on this presentation. So the new idea that it comes with the new EM database is to insert a new panel into this EM tools that would allow it to import diverse databases of different nature into Blender. The panel will be placed, as you can see, on the marked red area. Next, please. The tool will then be able to read the imported database file and identify the stratigraphic units recorded in the database of all kinds, masonry, virtual, etc., and match them with the units present in the GraphML, previously uploaded into the EM tools. The ones that are presented in both the database and the GraphML will be colored in the little diamond shape on the left of each unit, right where it shows the red square of this slide. But the ones that are present in the GraphML but not in the database will have the diamond empty. The intention is to help the user cross-check the files easily and identify if there's any missing information. Nevertheless, the key point is there in the next slide. Once the program has matched the database file with the corresponding unit, it will be possible to click on any unit display under the USB manager or even the proxy, and it will expand a secondary panel that contains the different fields recorded in the database form. This would allow us to identify and easily read information for specific parts of the model without having to go back and see it in a separate database. You can see it inside the red square of the slide, and it's easy to access. I want to remark that it's still a work in process, and we hope it makes easy to read large databases in a more attractive and interactive and reusable through linking it to its 3D visualizations. And next. Now I want to go back to Emmanuel to finish up some future goals. Thank you very much.
Thank you, Cristina. Basically, we are here also to ask to the community a feedback about where to go with this project. Because in the end, we started with a tool to ingest easily stratigraphic data for within the extended matrix umbrella in order to be able to visualize in 3D our reconstructions, our workflows, but plus information about relevant information about the stratigraphy. So all the information we are not able to store inside a matrix. But in the end, it can be also an agnostic tool to visualize all kind of data table in 3D. Or it can be an EMDB, so an EM thing, another workflow for the extended matrix ecosystem, or both of them. So to visualize all kind of data table within Blender and integrate different data sets, survey, conservation, building, archaeology, excavation data, under the EM umbrella. So to arrive to a data cross-fertilization and stress also on the data provenance and scientific processes annotation. But somehow it's we have to decide it. We maintain the name EMDB or to make a tool just for 3D GIS visualization, a more open with different purposes, let's say, multi-purpose system. In this case, maybe we can ask help for the community, maybe working on a tool with different actors, making a sort of 3D GIS for Blender, an open source solution to visualize stratigraphy in 3D. So we are open to it. We have already all the user interface done, and so we can revert the thing. Stratigraphy first and extended matrix after. So thank you so much. The floor. Thank you.
Okay, thank you, Emmanuel, and Christina as well. And we have finished slightly before our schedule, which is a great thing, both because we have some time for fruitful discussion, and I just need to ask anyone who is not attending online but who wants to ask questions or to put forward their comments to come here at the table, just so anyone can hear them. And there's a question. Okay.
Okay, Keith May wrote, have any of or all of the presenters been working with archival legacy stratigraphic data? How easy is to find, access, and work on data from different archaeological sources or sites? Okay, it's a more general approach. So we can ask to the participants to, if one of them wants to share his or her experience maybe on this topic, like a starting point for our discussion.
Well, one thing that you've been showing, Emmanuel, is that even with data that come already in a digital form, made with open source tools like the MySQL database, it can be done. So data can be processed and, let's say, preserved by moving them to a more current, maintained format, but it takes work. In my limited experience, the kind of work that is required to digitize data that was recorded on paper is not too different from, in terms of effort, from the kind of work that is required to extract data that was saved, for example, in an old Access database, perhaps with, say, choices made without thinking about durability of or archivability of software. But if there's anyone, especially who has been, let's say, translating old digital data to work with new tools, please come forward.
maybe I can give my experience about my PhD thesis, where I worked with old data, new data. Some data were designed with arithmetics in mind, some data not, and it's easier, as Stefano said, to try to in my opinion, also to try to extrapolate data directly from the archives and then to store it, analyze them in another way, to manage them and try to just to put them in another system where all the data are then connected. There is no standard, I think, about it. There is no process, no written process. Every data is different, so then and every question is different. In my opinion, it's a matter of questions. What questions want to ask to the data? Then we can think how to model our data to answer these questions. So I think it's a really wide topic, and it's also difficult to give a unique answer.
Thank you, Alessio. And perhaps another point in the question made by Keith is about finding data. And we all know that the UK has this incredible resource that is the Archaeology Data Service, where incredible amounts of data can be easily found, perhaps not always so uniform, but again, easily findable. The same cannot be said for other countries, notably for Italy, where I speak for direct experience as someone who works in a superintendenza. Even for ourselves is sometimes difficult to find and work with data from old excavations or not so old excavations. So we have seen many new developments in digital archiving from the Ministry of Culture about preventive archaeology, about, let's say, more the landscape side of archaeological research and management. Very little has been done in the past few years about excavation data in terms of standardizing, in terms of archiving. So we still need to do something about that, and I think we're here today to approach that. I have a question for Joe Rowe. I don't know if you wanted to add something. No. Okay. I have a question for Joe Rowe, and it's about the typical, let's say, process that is common with R, and especially using R Studio, of R Markdown notebooks. And I wanted to ask you if you have been doing work with this kind of approach, because as someone who uses Python more often than R, but I try to look at both sides quite often, I see that notebooks, either R notebooks or Jupyter notebooks, are a crucial part of the open science approach. So I wanted to see if you see any potential for your packages within this kind of approach.
Hi, can you hear me now? Yeah, so I think I agree. Notebooks are a really cool feature of R. So the websites of the packages that I put up, for example, are notebooks, mixtures of Markdown and R code. The slides that I presented today are also a mixture of Markdown and R code combined with a slightly newer tool called Quarto, which is really cool because it brings in Python, so you can mix Python and R in the same document. And yeah, so in terms of stratigrapher, I think is a really good question, and it touches on a dichotomy we've seen here between command line tools and GUI tools. I prefer the command line. That's how I like to work. But I see, these literate programming documents as the way you get that command line work out there in a graphical and accessible format. So yeah, absolutely want to try and emphasize that in the future development.
I just wanted to thank you for this most interesting panel that gave many food for thought, both on the theoretical aspects and practical ones. On the theory, I wouldn't agree, at least not at 100%, with Paonessa when he says that Harris matrix is a documentation system and not an interpretation one, because at least I agree with you at 50% probably, because there is much interpretation also in drawing the diagram and also in recording the relationship between the units. On the technical ground, well, I've grown up with a kind of religious belief in GraphViz, something that could solve any kind of problem working with graphs, and the dot file. It's an excellent, let's say, interchangeable format for. It's not very effective as a storing format, of course, but as a representation format, that's great. So I'm very happy to know that GraphViz is still alive. But I don't know if any of you has any experience with, for example, web technologies, because I'm a little bit concerned about the portings or hacks of GraphViz into the web in JavaScript and similar, because there seem to be all defunct or at least not maintained anymore. Softwares or packages like Viz.js or also Dagger and etc. seems to be all discontinued. That there is the perfect bridge from graphics to the web and similar things, just to not only visualize graphs but also analyze them, because as we all know, graphics has important tools also for checking consistency between data, everything that's needed in also for clustering them, etc. Everything that's needed into archaeological domain. So my question is if you have any news about portings or web tools that can be equivalent to GraphViz, D3 based or not.
Okay, thank you, Julian. I think it's a very good question about how to formalize in the end the stratigraphic record and the matrix Harris representation. Maybe I will make a question in the answer, because yes, there are tools different from GraphViz to visualize and working with graph databases, because we are talking about graph databases in the end. And I suppose that we need as a community to shift from a table approach to the world, let's say in records and columns, to a different ways to organize the information with the connection, the interconnection of information. So shifting from a table way of looking to the reality to a graph-based view representation. So graph theory is something that is very relevant when we are working with stratigraphic data and temporal relationships. For that reason, we have now online JSON format that is an interchangeable format that maybe is more suitable for our purpose. But we have not, unfortunately, we have with your work a very first approach to JSON and stratigraphy that I think that is the most important step now to do and to strengthen it, because we really need to formalize the stratigraphy in a JSON file. In the end, I believe it, because all the tools online working with nodes and representation of graph are based on JSON. So we have a lot of tools, and the swimline formalization, that is actually a sort of box where the spatial localization of the node is relevant. Is not just a liquid GraphDB with all the nodes that can be everywhere, but is a spatialized visualization. Let's say if I say Germany, all of us know that it's in the middle of Europe, and you can associate a place with a concept. In the graph database, we have the Eris matrix that is exactly the same thing, a sort of map, where what is upper is newer and so on. And we need this kind of approach. And unfortunately, online, there are only a few tools that are able to do exactly what archaeologists need. And it is very important to stress it. And JSON is one format that actually is relevant for this direction. So it would be great to have a JSON for all for stratigraphy. I think that is a very important starting point to have a standard in the end.
Do we have any other comments or questions? I want to make a half comment, half question. That is, I think we've heard about two different approaches, basically, to the storage of stratigraphy data. One that is text-based, so the work that I presented myself, the work presented by Moody Tali, and the work presented by Joe Rowe, and then a database approach. So my first question is for Moody, if you could very briefly explain if your polychrony tool works with the same plain text files, also for storing the different information that is added with a graphical interface, or it's using some other way to store data. Yeah.
Thanks. So at the moment, everything that's read in, we can read in text files, plain text files, and dot files from DI's HM software. And then at the moment, everything's stored as plain text files, apart from the kind of the save file for the actual application itself, which is then loaded back into Python. But I do use JSON for the GUI to be able to allow the user to right click on the nodes and access that data from a specific node. It has to be converted to JSON anyway, so it wouldn't be a case that it wouldn't be possible to also archive that information. So it's really interesting hearing that actually that's a format that people are interested in, because that's helpful in terms of what needs to be archived from the software. But again, from graphs, it's really easy to convert to JSON format.
I saw other people in the online stream. Okay.
Okay, we are here and we have some minutes more, so just to make the best of it. In our presentation, we asked for a specific task. So, is it relevant to have 3D GIS for stratigraphy now? Is it relevant for the community? Can be a project by itself, or let's say it's something that should be customized for each project. So there is no need for a multi-purpose tool, let's say, but maybe each one will find his or her path to drive to arrive to represent and to work with the stratigraphic record online. These are an open question for us to decide what we have to do with the project.
I can't give answers to these very important questions, but I think the key point you should be looking at is not just that of what the tool will be doing, but also of how the data will be stored. As we've heard, this is very important, not just in terms of preservation, but also in terms of interoperability. So we see that with the extended metrics, with the Blender beam, Blender is capable of doing a lot and possibly most of what an archaeologist needs from a GIS package. But we also see that GIS tools are evolving and are capable of managing many kinds of three-dimensional data. So if possible, I think the best solution would be to find a way to continue and make use of all the experience you have with Blender in the Blender environment, but also making sure that someone else can come up with a different tool, perhaps from the GIS side of the question, and work on the same data, possibly with different strengths and different weaknesses. This is all, let's say, haunted by being constrained to a desktop environment anyway. So let's not forget it. What you said about online databases is very important, and I think Julian was right in stressing the question of how and how much we can move our workflows to online tools. And I think both approaches, let's say that of strong desktop GIS or Blender, keep us very strongly tied to a desktop environment.
Well, following the program, if there are no other questions or comments, so we can take a break and have the first coffee break, and then we'll meet following strictly the program topic. Okay, we'll meet at 11:45 with the new panel about PyArchinit. Okay, the first communication will be online, but we'll have some coffee now, and then we'll meet here. Thank you.
Hi, I was just wondering.
hello.
Hi, nice to meet you. I was wondering, is there a conference in
There is an Rome connection. Does it work?
No, I don't have either or.
Okay. No, we don't have one of the.
Oh, okay. I just thought maybe there's like
There is a Sapient.
yeah, like passwords, and like I saw that there was a connection. I was just wondering if there was like a password for.
Yes, that's it, because they're private. But are you sure you don't have that Rome also with die?
No, we don't. We have our own.
Yes,
I don't know about it. Like I asked Fabian.
Okay, probably you can investigate it further because it works like any institution at its own and it participates to this broader European.
No, I know. I used to. I studied at the Free University and
So,
I had it there, but I just
probably you're part of that also as die.
try. I doubt it.
Yes,
Anyways,
but
thanks.
no, I can't help you.
That's all good. Thanks.
Sorry. Pausa che ti dico. Sì, non mi male. Una sentire come tipo ma qual è la C'è una cosa che mi controllo che hai una cosa che mi però comunque era due assi io non so però quello è bello. Questa è la direzione di Giulia. Ti viene a fare un caffè? Guarda, capito. fine si è risollevato.
10 slide veloci.
Adesso abbiamo un paio.
No, noi sono nel pomeriggio. Almeno te lo do subito.
Sento?
Sì, gli altri ancora non ti danno le loro presentazioni.
Forse li lanciano direttamente loro da remoto.
No, c'è solo uno in presenza, online, gli altri sono in presenza.
Cioè Mandolesi, i primi
I
due, credo.
primi due sono in online.
Mandolesi e Montagnetti online.
Sì, e Ciuccarelli e Donovan.
Ok, Martinez si devono sbrigare a darmi adesso. Tu sei a primo pomeriggio?
Alle 4, alle 5. Siamo arrivati finalmente, forse si mette online, quindi...
Sì, per il modo invece che non ti ho chiesto, ma Giorgio mi chiede ancora funziona.
Sì. Aprilo così sì. Se problemi, puoi l'immagine.
Prego.
Posso?
Sì. Sta chiaro questo?
Sì. Ok.
Giusto per coordinarci. Sì. La presentazione comunque deve essere fatta in inglese, ci fai
come volete, casomai in oppure sì, noi sapete l'arroganza così. Esatto. Il PDF va bene?
Perfetto. Io mi sono fatta anche a 90.
Sì.
Rimango sull'inglese.
Giulia.
Camicia, canottiera.
Dicevi per Roma? Grazie. Per l'articolo per Roma, dici per
Sì.
No, sono buona. Io ve lo posso consegnare perché ho fatto le integrazioni che ho richiesto, quindi ci sono. Anche perché a forza di fare le cose così.
Antinori.
Salve professore.
Letali.
Sì, sì, no, purtroppo la mia pennetta stamattina mi ha abbandonato. Licenzia la versione PDF.
Vabbè, posso prendere quella PDF?
Sì, lascio leggero.
Che ordine?
Sono l'ultimo, mi sembra che siamo a mezzogiorno 4 e 5. Sono io.
Ecco, se vuoi fare dove prendo?
Sì, scusami, presentazione ArcheoFOSS.
Allora, Eduroam? Ok. Hai accesso a qualche Eduroam? No. Allora, sì, io non granché bene. Davanti alla finestra. Se no te la prendi come una vacanza.
Sì, era come...
Allora, le prime due sono online.
Ciao Giulia, scusa, non ci siamo ancora salutati.
Come stai?
Bene, tu?
Bene. Allora, ci si incrocia sempre così come nomi della bibliografia. Va bene, se prendo, no? Poi siete in stessi.
Siamo in quarti.
Online 3, 4. Direi che Possiamo cominciare. Appena c'è. Okay, let's start the second panel of this morning, which is dedicated to GIS open source solutions for archaeological context and in between universities, public administration, societies, research centers. The Init case. Well, the papers of these panels will be coordinated by Enzo Coca and Gianluca Martinez and will be in Italian. So this is the only panel of the conference that will be entirely in Italian. So of course, questions can be both in Italian or in English whatsoever. We'll try to keep questions in different languages. So the floor is to Enzo Coca and Gianluca Martinez, and we'll meet again during the discussion.
Salve, benvenuti a tutti in questo secondo incontro nel panel 2, GIS Open Source Solution for Archaeological Context in Between University, Public Administration, Societies, Research Center by Init Case. Questo intervento, come diceva Julian, sarà in questo panel, l'unico panel che sarà in italiano. In questo panel vogliamo presentare dei casi studio svolti con Init, questo software open source che gestisce scavi archeologici e non solo, in vari contesti che sono quelli sia universitari, della pubblica amministrazione e della ricerca scientifica dell'università. Passo la parola a Gianluca Martinez che inizierà a presentare il primo intervento.
Ok.
Voi sentite?
Ti sentiamo bene, Luca.
Ok, grazie.
Puoi lanciare la presentazione, se l'hai, metterlo a pieno schermo e condividere.
Ok, mi sembra che vediate tutto. Okay, I will try to speak in English. It's not my language, but I try my best. Okay, I will speak also in Italian from the part where I have no words, literally, to explain properly what I have in my mind. Okay, Init at Poggio Gramignano Villa, a workflow between society and university through Init and Blender. In this presentation, there are 4 elements, okay? A place, an excavation of University of Arizona since 17th in Lugnano in Teverina, Umbria, Italy, is a Roman villa. The next actor is the University of Arizona that contact us to realize a 3D model. But in the context of the villa was used PyArchinit for a little piece of the stratigraphy, not since 70s, because PyArchinit didn't exist. This was a little problem. Then there is another actor, a society. This is ad arte. The society was a part that must realize the 3D model with all the problem of timing, billing, and other problems. PyArchinit is the bridge in this case between university and our society. But PyArchinit have a big problem. Can do some 3D reconstruction using extended matrix of Emanuel Demetrescu, because Enzo Coque realized through a MIC procedure the bridge between PyArchinit and extended matrix. But we have no data inside the PyArchinit of this context. So I have many problems. Okay, now I try to explain what I have in my mind to realize a new part of PyArchinit. If Enzo is agreed, yes. Okay, let's go. The purpose of this presentation is to find an appropriate way to speed up the first phase of processing a 3D model starting from the data collected within PyArchinit. I just said we have no many data inside the DB. Also, for the 3D model, the data in 3D model, we have only this, the hill, where is the context of the excavation, structure from motion of a little part of the context, because it's all covered. Is not more visible all the excavation. Okay, so we start from here. Then the customer asked me many things. I want a villa. I want a Roman villa of the 1st century. He had many things in his mind, but I have many difficulty to understand what he wanted. In organizing such a work, it is clear that there are two protagonists, the customer and whoever does the work, me. And 3 different needs, okay, just a little bit in contrast. To maintaining scientific rigor, the customer, to finish the job in a short time. I have no many time to do this. Who does the work? Me. To transfer the customer's ideas within the 3D model in a precise way. The excavation began in the 70s, did not have the possibility of being filed in only one way from the beginning. PyArchinit was used only since 2018 and only for a little part of the site. This is a big trouble for our society in understanding what the customer needs as a final product. How many times will be required for work and the proper price of this kind of work? I think this is the first time we talk about price in a speech in ArcheoFOSS. I want this panel because we are a commercial society that use strongly open source. I think commercial society as mine can do a new way of financing with money open source and other project in this presentation in these days. So we started a huge exchange of email and call through Zoom to evaluate the whole work. First email 2021 June 1, work delivery 2022 September 19. This is a big time for a society. This is a real problem. What is the matter? Why all this time to realize a simple 3D model? Okay, this is our problem, and we must find a solution. The biggest problem for us was how to allow the customer to tell us everything he has in mind. He had many things: fantasies, movies, comics, real model, reconstruction. Data. Very well all the data, and translated in a scientifically valid and artistically appreciable 3D model. Okay, we started from here. This is my problem. I have nothing more than this. Only many words. From this reason comes the idea of extending PyArchinit so that it can contain preliminary information aimed at virtual reconstruction, either if it was not possible to build the database from scratch, or we have not metrics available to use extended matrix. This can speed up the job to obtain faster the result. What kind of information should PyArchinit handle and how? There are two kinds of information. These are only example, not all information types. Raw and fictions, structure for motion, plant, sections, books, aerial views, pictures and videos. But there are also comics. We use some images from comics, scale model, ideas and sketching, geographical information, landscape, or geological information. Any kind of information will be recorded inside PyArchinit and geotagged. So I think, as Emmanuel was talking before, we need a more liquid way of recording data for 2D reconstruction. So I think we need to realize a new sheet, but I don't know if the sheet row and columns is good, is a good idea. I need to think about it with you and Enzo Coca and Emmanuel Demetrexel to realize a new part of PyArchinit that can go to extended matrix next. This, we hope, will speed up the workflow through PyArchinit. Just now in Italian, io spero di riuscire con Enzo, ma soprattutto con Emanuele, a portare avanti il lavoro che, non l'ho detto all'inizio, scusatemi, col professor Soren dell'Università dell'Arizona, con David Pickel, sempre dell'Università dell'Arizona, Roberto Montagnetti, che fa parte di Adarte, ma da sempre lavora con l'Università dell'Arizona, di mettere da parte questi mesi di lavoro insieme, dove da un lato avevamo una università che era la prima volta che si metteva a fare un lavoro per la realizzazione di un modello 3D, dall'altro c'eravamo noi abituati ad avere sempre tutto realizzato con PyArchinit, quindi ad avere a portata di mano tutti i dati all'interno di un database già geotaggati. In questo caso noi ci siamo trovati con dei dati ibridi e dovevamo correre, non avevamo il tempo di creare all'interno di PyArchinit, per esempio, le unità stratigrafiche reali, le unità stratigrafiche virtuali per l'extended matrix, le piante di fase, ma avevamo bisogno di ottenere un modello scientificamente valido, ovviamente tutto migliorabile, però anche artisticamente corretto. E per questo nel flusso di lavoro, oltre a usare semplicemente Blender, abbiamo usato in maniera estesa Blender GIS, quindi abbiamo portato i dati in maniera georeferenziata all'interno di Blender. È per questo che credo che sia importante prendere PyArchinit, aggiungergli in qualche modo, ma ripeto, in questo momento non so qual è il metodo migliore da usare.
Scusami Luca, ti chiedo un attimo di stringere perché il tempo
Perfetto, finito. Benissimo. Quindi il metodo migliore per riuscire ad arrivare a una soluzione il più efficace possibile, quindi si apre il dibattito, cerchiamo nuovi modi e grazie a tutti. Finito.
Thank you, Luca. And the next paper is Donofrio Ciuccarelli. Where is the title? The Human Context of the Roman Theatre and Ex Filanda in Fano.
Sì, buongiorno, mi
Grazie,
sentite?
Donofria. Sì.
Ok, allora procedo con la presentazione.
Condividi lo schermo, per favore.
Sì. Vedete?
Sì, ti vediamo.
Ok, allora, buongiorno a tutti. Io oggi con me ci doveva essere anche la dottoressa Raffaella Ciuccarelli della soprintendenza che per motivi istituzionali dovuti all'emergenza nelle Marche degli ultimi giorni non è potuta essere con noi, ma cercherò insomma di parlare anche al posto suo. Vi presenterò brevemente l'indagine archeologica condotta nel contesto urbano del teatro romano e nell'area dell'ex Filanda, Bosone a Fano, nella provincia di Pesaro Urbino, nel nord delle Marche in Italia. E agli inizi del 2021 l'amministrazione comunale ha avviato un primo intervento di indagine archeologica stratigrafica all'interno dell'area dell'ex Filanda Bosone, che vedete evidenziata. E ci troviamo nel centro storico di Fano, nel luogo in cui qualche anno fa erano stati scoperti casualmente i resti del teatro romano. E l'amministrazione comunale ha avviato proprio questa indagine con l'intento di valorizzare quest'area della Filanda da poco acquisita, ma anche di mettere in connessione proprio questi resti del teatro con un'area archeologica annessa, che vediamo campita in verde nella slide, che è l'area archeologica del complesso conservato sotto il complesso di Sant'Agostino, che conserva i resti del tempio criptoportico del cosiddetto Tempio della Fortuna. La progettazione quindi dell'intervento è stata commissionata dall'amministrazione comunale, la direzione scientifica è stata svolta dalla Soprintendenza Archeologia, Belle Arti e Paesaggio per le province di Ancona e Pesaro Urbino e nel dettaglio dalla dottoressa Maria Raffaella Ciuccarelli appunto per la parte archeologica e dall'architetto Simona Guida per quella architettonica, mentre l'esecuzione dell'indagine sul campo è stata condotta da una società privata ad arte SRL di Rimini, di cui sono socia. Quindi diciamo che in questo caso c'è stata sinergia e collaborazione tra una società privata, un ente pubblico quale l'amministrazione comunale e un altro ente pubblico che è la soprintendenza che svolge come sempre la direzione scientifica. Dicevo poc'anzi che ci troviamo proprio nell'area forense dell'antica colonia Iulia Fenestris e precisamente tra i resti del teatro romano a sud-ovest e il complesso tempio criptoportico a nord-est. E proprio in quest'area quindi è stata condotta questa indagine stratigrafica mediante l'esecuzione di 3 sondaggi archeostratigrafici. Nella figura vedete saggio H, I ed L, che hanno consentito di indagare una sequenza stratigrafica molto complessa e articolata estesa tra la fine della prima età, prima età imperiale, quindi la fine del I secolo a.C., e l'età moderna, e quindi tra il periodo di costruzione del complesso del Tempio, del cosiddetto della Fortuna, e la parte, insomma, è la costruzione di un maglificio che prima di una fabbrica tessile per la produzione di seta, poi trasformata in maglificio nel secondo dopoguerra. E contestualmente a queste operazioni di scavo, quindi, abbiamo utilizzato proprio per la gestione del dato archeologico il software open source PyArchinit, l'applicativo PyArchinit su piattaforma GIS. E tramite questa gestione dei dati, quindi, abbiamo inserito all'interno di tabelle alfanumeriche e geometriche tutti i dati provenienti dallo scavo archeologico. E quindi abbiamo avuto in tempo reale l'elaborazione dei dati di scavo direttamente in loco, con la creazione quindi di schede di sito, di schede di unità stratigrafica e unità stratigrafica muraria, quelle di reperti, di strutture, di campioni e quelle di periodo e di fase. E nel dettaglio, nella scheda US, sotto la sezione sistemi di controllo, abbiamo avuto la possibilità di fare in maniera automatica e senza estremo dispendio di energie la verifica dei rapporti stratigrafici e la creazione dei codici di periodo. E direi che un'altra funzione che abbiamo utilizzato, a mio avviso molto risolutiva, è stata la generazione automatica del diagramma stratigrafico con il dettaglio delle fasi cronologiche. Una volta completato quindi l'inserimento di tutti i dati all'interno del database in PyArchinit, è stato possibile esportare tramite delle funzioni dedicate le planimetrie delle singole unità stratigrafiche, e qui nella tavola 5 vedete infatti la planimetria del sondaggio 5 con una delle strutture del criptoportico, e anche le planimetrie di periodo e di fase. In questa tavola infatti vediamo il periodo 2, quindi la fase imperiale, con tutte le strutture del criptoportico e le US relative ad esso, con tanto di quote altimetriche disponibili. Oltre quindi all'esportazione delle planimetrie, abbiamo esportato anche le schede di unità stratigrafica e di unità stratigrafica muraria in file PDF e sul formato di quelle ministeriali fornite dall'ICCD. Oltre ad altre schede come per esempio quelle di reperto, tutte interconnesse tra di loro. E quindi una volta completato tutto questo lavoro di scavo stratigrafico e relativa documentazione, abbiamo consegnato alla sovrintendenza di riferimento un pacchetto informativo di layers territoriali, tutti georiferiti, georeferiti in Gauss-Boaga Est con sistema di riferimento in EPSG 3004, tutti facilmente interfacciabili con gli altri sistemi informativi territoriali. A livello locale, infatti, a livello nostro societario, abbiamo la possibilità di avere in un'unica piattaforma tutte le informazioni relative sia alle ricognizioni di superficie, sia alle indagini archeologiche vere e proprie, e naturalmente con la possibilità di fare delle interrogazioni trasversali e in maniera molto versatile. Ma questa potenzialità comunque è auspicabile anche a livello macroscopico all'interno delle soprintendenze, in quanto il pacchetto di dati fornito dalla società direttamente alla soprintendenza è riversabile facilmente all'interno delle banche dati gestiti dalla Soprintendenza per la gestione e la catalogazione dei dati archeologici. Infatti, per quanto riguarda la Regione Marche, noi abbiamo il SIRPAC, che è il Sistema Informativo Regionale del Patrimonio Culturale, e il SIGEC Web, che è la piattaforma online che utilizza la Soprintendenza, che sono alla base della Carta Archeologica delle Marche. Quindi tutta la gestione e l'archiviazione dei dati archeologici regionali confluiscono in questa piattaforma, e così anche i nostri layer possono facilmente essere riversati in tale piattaforma. Oppure mi viene da pensare a livello un po' più a livello regionale o nazionale al sistema Raptor, che è quello utilizzato da alcune soprintendenze, soprattutto nel nord Italia, per la tutela e la gestione dei dati archeologici, oppure all'ArcheoDB che da qualche tempo utilizza la Regione Marche. Penso anche alle ultime linee guida dettate dal Ministero per l'Archeologia Preventiva in Italia, quindi la disponibilità di questi layer della società direttamente nel sistema, nel template generato dall'ICA per l'elaborazione del Geoportale Nazionale dell'Archeologia. Un ultimo aspetto importante da tenere in considerazione è proprio la possibilità di riversare i nostri layer, quindi il pacchetto di informazioni geoterritoriali, corredati quindi dai record archeologici, per la tutela, la gestione e la pianificazione territoriale e urbanistica. In questo periodo noi come società ci stiamo occupando della redazione della carta di potenzialità archeologica del comune di Fano, e quindi proprio l'utilizzo del nostro database per l'elaborazione della carta di potenzialità sarà molto più snello. Allo stesso modo, quindi, potrebbe essere utilizzato per l'aggiornamento dei piani regolatori generali da parte dei comuni, e per l'elaborazione dei geoportali nazionali disponibili in rete. E questi naturalmente non sono che spunti, però il nostro è un lavoro che è iniziato da qualche anno e che portiamo avanti con insomma, estrema fiducia. Io vi ringrazio per l'attenzione, ho finito la mia presentazione e resto a disposizione più tardi per eventuali domande.
Grazie Annalisa.
Grazie a voi.
Thank you Annalisa for this interesting presentation. So the next presentation is Gianluca Martinez. The title of presentation is Bayerkinit Potential and Limits in University and Research Context, Sansisto Case Study and Laboratory of Medieval Archaeology of the University of Pisa.
Grazie. Cambio. Okay. Allora, questo. Un attimo faccio partire le presentazioni. Perfetto. Ok. Quindi, come abbiamo detto, il titolo della presentazione è Bayerkinit Potential and Limits in University and Research Context, perché diciamo, l'obiettivo di questo intervento è quello di illustrare qual è stata la nostra esperienza come gruppo di studio, di scavo dell'Università di Pisa con il plugin di Bayerkinit. Allora, il sito... Ah, non... Ah, ok. Ok.
Questo? Ok, adesso ci siamo. Ok, riprendiamo. Allora, quindi lo scavo di San Sisto, portato avanti appunto dal laboratorio di archeologia medievale dell'Università di Pisa, aveva come obiettivo principale quello di indagare le fasi tardo-antiche e altomedievali dell'area, di mettere in luce il chiostro e il cimitero connesso alla chiesa, ma anche di sperimentare tecnologie e metodologie di rilevamento e di informatizzazione, quindi di registrazione del dato archeologico. Tra questi sicuramente uno dei più apprezzati, uno dei strumenti più apprezzati è stato PyArchinit, che si va a inserire come parte finale di un workflow che parte dalla fotogrammetria e la vettorializzazione delle schede US in ambiente GIS, per poi andare a riversare tutto nel database del plugin. Diciamo, per quanto riguarda il workflow di vettorializzazione, si parte dal rilievo fotogrammetrico delle unità stratigrafiche, di ogni singola unità stratigrafica, da cui poi diciamo, vengono estratti il DEM e l'ortofoto. Sempre all'interno di Metashape si procede a disegnare il contorno dell'unità stratigrafica, che va poi ad essere esportata come shapefile poligonale e va a essere inserita all'interno del database di PyArchinit, come potete vedere qui, diciamo, dove abbiamo diverse unità stratigrafiche positive, negative, resti murari o osteologici. Grazie a strumenti, grazie a, diciamo, ai campi del layer di disegno di PyArchinit, quali tipo US o Stratigraphic Index, è possibile definire le caratteristiche dell'US, diciamo, immediatamente, e tramite la visualizzazione con regole di QGIS è possibile caratterizzare il disegno archeologico lì diciamo, sul momento. L'intero processo richiede all'incirca 10-15 minuti, partendo dalla fotogrammetria e arrivando fino alla vettorializzazione delle US, e viene svolto direttamente sullo scavo. Il DEM poi viene utilizzato per registrare le quote all'interno del layer quote di PyArchinit, e l'ortofoto va a costituire la documentazione grafica dell'unità stratigrafica. Sempre sullo scavo si procede poi con diciamo, l'informatizzazione delle schede US, grazie ai ragazzi che scavano con noi, in modo tale da avere comunque una documentazione aggiornata direttamente sullo scavo. Un altro punto di forza del sistema è appunto quello di poter avere un database online su Postgres al quale ci connettiamo, e soprattutto riusciamo a connettere più di un utente, così da avere più di, diciamo, di una persona che si occupa dell'informatizzazione e dell'aggiornamento dei rilievi. Un primo problema, diciamo, che si è presentato in fase di editing è stato quello della redazione delle piante di fase, perché ci è stato chiesto di caratterizzare diciamo, i contorni non originari delle OS con una linea tratteggiata, solo che essendo un layer poligonale non permette di avere più di un tratteggio, diciamo, per singola OS. Quindi quello che abbiamo fatto è stato ricalcare, diciamo, il limite non originario dell'unità stratigrafica all'interno del layer lineare US negative, sempre di PyArchinit, nominandolo con lo stesso numero di US diciamo, del layer poligonale, così che da poterli recuperare insieme tramite query, e così caratterizzando, diciamo, il tratteggio in bianco e sovrapponendolo all'unità stratigrafica siamo riusciti a ottenere, diciamo, quello che ci era stato chiesto, ovvero di caratterizzare diciamo, la parte non originale dell'US. Per quanto riguarda invece l'inventario dei materiali, quindi la schedatura dei reperti, sempre sul sito procediamo, sempre, diciamo, in scavo, procediamo con il lavaggio, la siglatura e diciamo, l'informatizzazione dei reperti. Premessa fondamentale va fatta che sullo scavo abbiamo una quantità di materiali, si parla più di 500 cassette, fino a diciamo, ancora in scavo, e una varietà di materiali che vanno dal VIII secolo avanti Cristo fino alla ceramica moderna. In questo modo abbiamo potuto sperimentare, diciamo, fino in fondo le potenzialità e i limiti dell'inventario materiali di PyArchiNet. Per quanto riguarda, diciamo, la schedatura classica del tipo reperto, classe materiale, quindi diciamo la definizione del reperto, la tabella inventario materiali permette di registrare qualsiasi tipo di materiale. Un piccolo problema invece è stato cercare di registrare dei campi più specifici per le analisi ceramiche, quali ad esempio la tecnologia di produzione o la definizione della decorazione. Per fare questo abbiamo preso la struttura di un vecchio database che avevamo su Access, in particolare come vedete nel riquadro rosso in basso, abbiamo preso i campi di tecnologia produttiva e di decorazione, e attraverso l'utilizzo della table widget della scheda PyArchiNet unita al thesaurus aperto che sempre PyArchiNet permette di avere, siamo riusciti ad adattare, diciamo, questi campi per i nostri scopi. Diciamo adesso in concomitanza con la chiusura dello scavo da ottobre, in attesa del rinnovo della concessione, partirà la seconda parte del progetto di San Sisto, che vede il recupero di tutta la documentazione prodotta, diciamo la ripulitura dei dati per creare una documentazione definitiva, disambigua, che ci permetta di poi riutilizzare questi dati per nuove interpretazioni o per rivedere quelle vecchie, e poi punto saliente che spero di portare avanti sarà quello del mescolare non solo i dati, quindi incrociarli, metterli in relazione tra di loro, ma anche di mescolare i diversi strumenti informatici che, come abbiamo visto, diciamo, nel corso della conferenza, sono a disposizione dell'archeologia, in particolare partendo dal tools di esportazione del matrix come Extended Matrix che ci ha fatto vedere Enzo stamattina, poi passando in Blender per la modellazione delle unità stratigrafiche, comunque delle unità murarie. Cercheremo di creare un GIS 3D che sia visualizzabile, interrogabile, ma analizzabile. Quindi diciamo, l'obiettivo futuro è creare un GIS che permetta di fare analisi 3D, anche magari sfruttando le potenzialità dei software BIM che in questo ci vengono incontro. Io ho finito, vi ringrazio.
Mi sentite? Sì. Grazie Gianluca. Allora passiamo con molto interessante questo intervento. Passiamo con il secondo, il prossimo intervento, che è di Marco Moderato e Vasco La Salvia. Il titolo è PyArchiNet at Castelseprio, Progressive Adaptation of an Integrated Managing System for Archaeological Field Data.
Salve, buongiorno a tutti. Mi trovo un po' in imbarazzo, essendo io veramente l'ultima persona a poter parlare di informatica applicata all'archeologia, ma solo brevemente, introduzione, a modo di introduzione al nostro intervento. Castelseprio, che è un sito UNESCO che fa parte del sistema dell'Italia Longobarda, è un posto molto bello, ma anche un sito molto complicato. Il nostro intervento è anche un tentativo, diciamo, iniziale per cercare di costruire in qualche modo la possibilità di mettere a sistema non solo quello che stiamo facendo noi nella nostra zona di indagine, ma per cercare di, come dire, fornire un orizzonte complessivo a tutti quanti lavorano a Castelseprio. Da qualche anno è iniziato un nuovo progetto di ricerca a Castelseprio, un progetto interuniversitario guidato dal professor Brogiolo, che vede insieme l'Università Cattolica del Sacro Cuore, l'Università di Padova e l'Università di Chieti. Ma Castelseprio è un luogo in cui gli scavi sono iniziati nell'immediato dopoguerra. Diciamo più o meno dall'immediato dopoguerra a oggi abbiamo una enorme massa di dati totalmente incoerente da vari punti di vista. Dunque il nostro tentativo è anche quello di iniziare una strategia che possa in qualche modo servire anche da esempio per cercare finalmente di costituire un sistema che possa mettere insieme i dati di un sito così importante per la storia dell'archeologia tardo-antica e medievale in Italia. Insomma, quindi diciamo, sappiate perdonarci se siamo ancora all'inizio dell'opera. Grazie e do la parola al dottor Moderato.
Si sente? Sì, perfetto. Mi ricollego proprio a quello che diceva il professor La Salvia. Questo nostro intervento di oggi è la volontà anche un po' di illustrare qual è stato l'approccio nel voler introdurre PyArchinit come strumento di management dei dati da scavo all'interno del contesto appunto seprese. Un brevissimo background: io seguo il progetto di PyArchinit dal 2009, poco dopo mi sono incominciato a interessare proprio di GIS e di gestione dei dati di scavo dopo l'ArcheoFOSS del 2008 e diciamo è la prima volta dal 2008 che riesco a essere dall'altra parte finalmente per motivi di tempo assolutamente, e quindi mi fa molto piacere essere qui con voi oggi. Uno dei problemi appunto, pur seguendo PyArchinit da tanto tempo nel suo utilizzo, è che mi sono sempre trovato a doverlo introdurre nel flusso di lavoro a scavi già iniziati, quindi dovendo poi adattare anche il flusso di lavoro stesso, riadattarlo a una documentazione che fosse prevalentemente digitale. Con l'occasione invece della ripresa degli scavi a Castelsiepo, in particolare a Casapiccoli, che è il contesto che col professor La Salvia abbiamo cominciato a indagare dal 2021, questo problema, questo blocco è venuto meno e quindi abbiamo avuto la possibilità di ripartire da zero letteralmente e di impostare il nostro flusso di lavoro sull'utilizzo del plugin. Come vedete l'area di scavo è posta proprio poco a sud della chiesa di San Paolo ed è una grande area edificata con dei possenti muri che suggeriscono anche la presenza di piani superiori e che è stata indagata già in passato da Alberto Piccoli fine degli anni 70 e negli anni 80 e che però non ha diciamo, avuto la fortuna di interessi e di studi che hanno avuto altre aree di Castelseprio, fino almeno agli anni 2000, quando la Cucini Tizzoni, riguardando anche materiali venuti alla luce negli scavi, ha individuato una produzione metallurgica delle attività di lavorazione dei metalli proprio connesse a quest'area. Lo scopo quindi diciamo, della nostra indagine stratigrafica era quella di comprendere meglio le fasi forse un po' appiattite, anzi possiamo dire diciamo, al secondo anno di scavo sicuramente appiattite dal Piccoli della struttura dell'edificio e anche cercare di mettere in relazione questa area questa fase di lavorazione di metalli con un contesto archeologico e stratigrafico ben preciso. Nell'introdurre però, quando appunto ci siamo trovati nella possibilità di partire da zero, nell'introdurre l'utilizzo di PyArchinit come centro, come fulcro della nostra documentazione stratigrafica, ci siamo posti degli obiettivi che fossero sia di ricerca che di formazione. Di ricerca, chiaramente, la possibilità di esplorare e sperimentare sul campo uno strumento che credo debba essere parte sempre integrante, soprattutto degli scavi universitari, dove devono essere insomma, dei laboratori progressivi di sperimentazione e due obiettivi di formazione che fossero la formazione degli studenti, come sempre avviene negli scavi, nei cantieri formativi dell'università, ma anche che questa formazione consegnasse agli studenti uno strumento, scusate il gioco di parole, che fosse eticamente ed economicamente sostenibile per la loro vita professionale. Nel piano operativo per sviluppare questi 3 obiettivi, abbiamo pensato a una transizione graduale di inserimento da una documentazione tradizionale, puramente cartacea, ecco, del contesto stratigrafico, a una digitale incardinata su PyArchiNet, transizione graduale che doveva rispecchiare 4 cardini, 4 punti principali, quindi appunto il passaggio dal cartaceo al digitale, la possibilità di iniziare da zero, quindi di impostare il flusso di lavoro con questi obiettivi, e passare nel giro di 3 anni, anche dal punto di vista della gestione del dato e delle strutture di gestione del dato, a un'infrastruttura progressivamente più complessa. E chiaramente passare da una documentazione puramente locale a una remota. Questa è stata una sfida anche per me, per il sottoscritto, perché questi 4 cardini che imponevo nella transizione erano gli stessi che io, in quanto gestore alla fine della piramide, dagli studenti in su, del dato informatico, dovevo in qualche modo gestire e regolare. Il primo anno ha visto come elementi principali una formazione preliminare degli studenti che hanno partecipato allo scavo, molto sintetica sull'utilizzo del plugin. Premetto che io stesso avevo seguito un corso organizzato da Arte sul plugin, che è stato assolutamente necessario poi per organizzare bene il lavoro sul campo e a posteriori. I dati di scavo del primo anno sono stati salvati su un file master, su un database master in locale sul mio computer, e il plugin si appoggiava a un database Spazialite, appunto, che era quello su cui convergevano poi tutti i dati. Gli studenti erano tenuti a compilare sia la scheda cartacea di unità stratigrafica, di tabelle materiali e così via, sia quella digitale su PyArchiNet, e le schede digitali erano compilate sulle loro macchine, su cui loro disponevano di una copia pulita del database, che poi importavo manualmente sulla copia master principale. In questo gli studenti erano suddivisi in piccoli team ai quali veniva assegnato uno specifico lavoro, ovvero la compilazione delle unità stratigrafiche, la compilazione delle tabelle materiali e il disegno delle piante. Il primo anno ha visto coinvolti 6 studenti, tutti di laurea magistrale con diverse esperienze di scavo. Questo credo sia importante specificarlo, perché la comprensione del funzionamento del plugin e della compilazione avviene anche in base a una buona conoscenza delle pratiche stratigrafiche e metodologiche di scavo tout court, che chiaramente sono necessarie già alla comprensione della documentazione anche cartacea. Nel primo anno abbiamo compilato quasi un'ottantina di unità stratigrafiche, almeno una cinquantina di campi di tabelle materiali divise per tipo di materiale, e disegnato oltre 1000 forme vettoriali, con poi chiaramente la consegna della documentazione alla sovrintendenza secondo le regole di concessione ministeriale, alle quali ovviamente, scavandolo in concessione, siamo tenuti a obbedire. Vi do anche un dato temporale: lo scavo è durato un po' meno di 2 settimane, a metà di luglio, in cui il lavoro veniva svolto, di documentazione, veniva svolto sia in cantiere che in post scavo durante appunto il tempo del cantiere. Oltre a questo è stata necessaria un'ulteriore settimana di lavorazione di post scavo vero e proprio a ottobre o novembre, adesso non ricordo esattamente, però una sola settimana. Questo ha consentito di poi consegnare alla sovrintendenza il pacchetto completo di documenti richiesti, quindi il geopackage e tutta la documentazione allegata, davvero devo dire in poco tempo rispetto a esperienze precedenti. E contemporaneamente siamo anche riusciti a gestire tramite i layer del plugin, in particolare quello dedicato di solito alla caratterizzazione, la documentazione dell'altra unità di ricerca che lavora insieme alla nostra concessione, che utilizza in questo caso un sistema di documentazione diverso, basato su fogli CAD, per cui però noi, importando diciamo, le forme da CAD in DXF e poi all'interno dei geopackage di QGIS, siamo riusciti a unire alla nostra e in qualche modo a uniformare poi la consegna della documentazione. Il secondo anno vede la transizione dal locale al remoto. Diciamo, il primo compito che mi sono posto era quello di realizzare da solo, quindi senza un'assistenza tecnica esterna, perché volevo vedere quanto effettivamente fosse anche questo sostenibile da una singola persona, un server per ospitare il database in PostgreSQL a cui appoggiare il plugin. Il server è stato realizzato utilizzando un vecchio computer desktop che avevo a casa, che non usavo da diverso tempo, quindi installando Ubuntu Server e tutto quello che serviva. E chiaramente la documentazione quindi è passata direttamente da macchina locale a server remoto. Gli studenti anche per il secondo anno erano tenuti a compilare sia le schede cartacee che quelle digitali, e possibilmente di compilare quelle schede digitali direttamente dallo scavo, dalla zona dello scavo dove avevamo la scrivania e il laboratorio, quando possibile. Quando possibile lo spiegherò fra poco perché diciamo questa specifica. Inoltre sul server sono stati caricati solo dati vettoriali, quindi insomma le piante di scavo, non dati raster, quindi non abbiamo caricato le ortofoto e cose del genere, quelle stavano esclusivamente sui nostri computer. Se il secondo anno ha visto coinvolti 5 studenti, di cui 2 diversi dall'anno precedente, per cui c'è stato anche una sorta di nuova iniezione di formazione all'interno del gruppo, più uno studente invece più avanzato che era già esperto nell'uso del GIS, e altri 3 studenti che non erano presenti sul cantiere ma che hanno partecipato in forme diverse via remoto alla documentazione. Siamo arrivati a compilare anche quest'anno un centinaio di schede OS, altrettante quasi tabelle materiali, e ovviamente a raddoppiare le forme vettoriali completate. La documentazione chiaramente è ancora in corso. La prospettiva del terzo anno è quella di provare a sviluppare ancora di più l'utilizzo della documentazione da remoto e lavorare insieme agli studenti anche alla parte di integrazione interpretativa, quindi a costruire strutture e fasi all'interno del plugin e a usare il time management nella compilazione delle piante di fase. E diciamo una prospettiva a cui ci piacerebbe arrivare è anche una sperimentazione sul campo di strumenti diversi per la documentazione, per esempio tablet e cellulari con QField installato, quindi con la possibilità di compilare, almeno per la parte chiaramente alfanumerica testuale, le schede direttamente su supporto informatico. Una piccola analisi diciamo di forze e debolezze, opportunità e minacce di questa prima sperimentazione. Vado in dettaglio. Chiaramente sui punti di forza non può non comparire la facilità di gestione del dato su un'unica piattaforma che l'utilizzo di PyArchinit ha consentito. Questa chiaramente dividendo, o meglio operando in multiutente, abbiamo dimezzato almeno in parte i tempi di lavorazione. Nella sperimentazione che abbiamo fatto, devo dire, abbiamo riscontrato una maggiore produttività e facilità di gestione dividendo i compiti per diciamo aree del database, quindi con un gruppo che si occupava esclusivamente delle schede stratigrafiche e con un altro che si occupava della tabella materiali, piuttosto quando questi gruppi dovevano lavorare o sovrapporsi su un singolo ambiente di lavoro, quindi sulle schede stratigrafiche o sulle tabelle materiali, perché questo poi poteva generare dei problemi nella scrittura e lettura dei vari dati all'interno delle schede. Sicuramente uno dei punti di forza dal mio punto di vista, quindi diciamo del gestore alla cima della piramide dei dati, è stato che questa transizione graduale ha permesso di scaricare anche un po' del peso della gestione del dato rispetto a partire ex novo direttamente, per esempio, con un server con tutta la parte in remoto. E oltre alla facilità di revisione dei dati, va sottolineato anche che diciamo, il server remoto è stato montato con un costo quasi zero, nel senso che era una macchina che avevo già a casa, ma comunque bastava anche una macchina di potenza sicuramente inferiore per gestire almeno la nostra mole di dati. E chiaramente questo ha un impatto se devo pensare a degli studenti che si affacciano al mondo dell'impresa, dove comunque ci sono delle spese per la strumentazione e così via, che lo rende sostenibile effettivamente. Dal punto di vista diciamo, delle debolezze, dei problemi, ogni tanto diciamo, il flusso di lavoro all'interno del plugin non è sempre chiaro, a volte è antintuitivo. Ammetto che se non avessi fatto il corso in precedenza sarebbe stato molto più difficile poi spiegare ai miei studenti qual era diciamo, l'iter giusto per operare. E le schede, chiaramente, questo è un problema un po' più soggettivo, nel senso che a seconda dello schermo in cui ci troviamo di fronte, il campo visivo della scheda può essere labirintico, molto schiacciato e di difficile navigazione. E poi alcuni problemi tecnici più specifici, per esempio nella transizione da SQLite a PostgreSQL, alcuni formati dei campi non sono identici tra i due database, quindi per esempio PostgreSQL ha dei limiti di caratteri su alcuni campi che SQLite non ha, e questo ci ha portato ad alcuni problemi nell'importazione delle tabelle dei dati da una parte o dall'altra, che però insomma sono stati tutto sommato facilmente risolvibili. Chiaramente le opportunità sono quelle di passare a una documentazione pienamente digitale, non tanto perché il cartaceo non ci piaccia, anzi tendiamo comunque a fare una copia in cartaceo di sicurezza, ma più quello che ci interessa è la facilità di lavorazione, di multiutenza, di gestibilità dei formati, che sicuramente ci dà un vantaggio in termini di tempo e di produttività. Abbiamo sperimentato sul campo che la connessione telefonica, la connessione da cellulare, è più che sufficiente per la maggior parte dei compiti di compilazione, ed è uno dei motivi per cui non abbiamo caricato i raster sul database, ma abbiamo preferito tenerli sulle singole macchine. E rispetto chiaramente agli inizi di quando ho iniziato a usare il plugin, mi sembra di notare, ma credo che sia insomma un dato di fatto, che gli update sono sempre più frequenti e rendono sempre più diciamo, liscia operativa la capacità di operare del plugin stesso. Una diciamo, delle cose interessanti che sarebbe possibile sviluppare è delle interfacce utente grafiche designate per i telefoni o per i tablet, che permettono quindi la compilazione di quelle parti, almeno del database, che sono semplicemente alfanumeriche e che possono chiaramente essere più utili durante il lavoro sul campo. E lo dico perché diciamo dei due problemi che invece rappresentano una minaccia all'utilizzo del plugin. Uno è chiaramente quello del campo, dell'assenza di segnale. Come vedete Castelsepe, non so se si nota, la zona proprio boscosa al centro è quella in cui operiamo noi, quindi c'è una tacca di cellulare, due tacche se uno si sposta nelle aree più aperte, e l'altra è che chiaramente operando in una zona dove non c'è disponibilità di attacco di elettricità, o magari non abbiamo disponibilità di generatori e cose del genere, lavorare su PC diventa estremamente complicato per la durata delle batterie sul campo. Questo è un problema chiaramente che non è solo di PyArchinet, è un problema generico della documentazione digitale, che si può chiaramente risolvere con blocchi di batterie e così via, però è da tenere presente nel flusso di lavoro e soprattutto nell'organizzazione pre-cantiere, quando si vuole utilizzare uno strumento del genere direttamente sul campo. Chiaramente tablet e telefoni hanno batterie sviluppate per durare durante una giornata, e quindi forse la compilazione, almeno di quelle parti di database che è possibile, sono le schede US, le schede materiali, possono passare attraverso questo sistema. Probabilmente l'anno prossimo appunto proveremo con QField dei tablet direttamente sul campo e vediamo un po' come funziona. Detto questo, io direi che ho finito e vi ringrazio dell'attenzione, siamo a disposizione per qualche domanda.
Grazie tantissimo, molto interessante anche questo intervento. Passiamo con l'ultimo intervento di Marco Ramazzotti, Francesco Genchi e Guidi Antinori. Parlerà Guido. MASPAG e PyArchinet, the newborn collaboration of Sapienza and Adarte in the Sultanate of Oman.
Perfetto. Okay. So thank you. I really want to express my thanks to the committee for accepting our proposal, which will be in a way similar to the others, but also different because our is a very newborn collaboration between Adarte and thus the developer of PyArchinit plugin and Sapienza expedition, archaeological expedition to Oman. We already have some early results because we start to work last year together, and we hope we will keep on working together, enhancing the possibility and also exploring the possibilities of our cooperation. And I really want to stress also a very interesting speech of Marco Moderato about the importance of the experimentation aspects of academic and universities on the field. So we really want to stress out that concept in the next years. So first foremost, I will introduce the protagonist of this cooperation. From one side, we have the MASPAG, which stands for Sapienza's Archaeological Expedition to Gulf and Arabic Peninsula. It's an almost new archaeological project. Is new in Sapienza, established in 2009 within the Great Excavation Founding Project, but it stands on the long-lasting activities, archaeological activities of Italian in the Sultanate of Oman, in particular in the, let's say, in Professor Tosi heritage, quote unquote. So the project aims to explore the different aspects of the communities, ancient communities that inhabited this portion of landscape, and especially with an interesting focus on mobility and the relationship between kinship and human exploitation on a kind of harsh environment. So it's really interesting, and is also my PhD thesis project. So I'm working on these subjects. The other protagonist is, of course, the PyArchinit plugin, which now at this moment of the conference doesn't need to be presented anymore, and especially Adarte as a company in a broader sense, because it is within Adarte, with Adarte, that Sapienza established a direct cooperation. Because I, as a PhD student, I applied for funding a small research project last year, and this year we're waiting for the result of this year proposals. And within this framework of funding, I knew Enzo from excavation in Oman. I was learning about PyArchinit and its potential. So I reached out to the company, and we developed a program, a cooperational program that relies on both formation, my personal formation, and the development of a new, let's say, of a new aspect, of a new possibilities for PyArchinit, which is related mostly with the documentation of landscape, because both Enzo and Luca Mandolesi that presented earlier told us that they were thinking about developing let's say, the tables for the documentation of the landscape for surveys and broader archaeological exploration, but didn't have the possibilities both on a funding economic level and both on a literally timing, because as Luca told us earlier, Adarte is a company, so it has some other aspiration and other necessities related to these kind of issues. So with this funding that I get from Sapienza, we developed this cooperation, and we start working on the application of landscape analysis within the PyArchinit framework. So very briefly, I will showcases our activities in the Sultanate of Oman. Last year, we worked on 3 different areas. First, the necropolis, Iron Age necropolis in the northern of Oman, which is excavated since 2013 by Francesco Genchi, which is one of the coordinator of our MASPAC project. And it's very interesting project, and a very incredible context, archaeological context, both on both the materials. It's defined as a hoard, so it's not a small collection. It's a hoard of precious materials, ceramics, and very complex relationship and stratigraphy in the context. This year we also went to a site called Shupur in the oasis of Dank, which its landscape is analyzed and explored by many years by University of Temple, but the mound itself, it's archaeologically unexplored and completely ready to be picked. And we will start doing that next year. This year we only made some surveys, drone picturing to have to start planning next year's operation. And we worked for a month in a archaeological survey in an completely inedited region area of central Oman. And it is in this framework that with Enzo, we developed a first structure for the analysis and the documentation of the landscape. So here is the area. The workflow started with anomaly detection in the landscape based on Google Earth imagery, and then we went on the field to make ground truthing of these anomalies, and we applied Q-field from the area, and which really helped us and was a very important part of our workflow, which make it everything easier, because the team it's the 2 person you see on the screen. We have also other 2 persons. One is Marco Ramazzotti, the other coordinator of the project, and Alessandro Di Ludovico, but we were only 4, so we didn't have a lot of manpower to do the job. So Q-field was very important, and it was very a fundamental step in our workflow. Most importantly, on the QGIS, Enzo developed a structure, a very broad structure that was able to document all the aspects and all the layers of the archaeological landscape, starting from the survey area, the field, the collection field, the topographic unit, and the archaeological features spread in the landscape. And with the tablet, with the Q-field, we documented everything. We selected, insert all the data, and this gave us the opportunity to have already some early results embodied by the atlas, because it was very important to us, the communication and the collaboration with the local authorities. It is very important. And with this atlas, we were able to give at the very end of our fieldwork, already all the documentation we had. Very well done. It's a model directly extrapolated from QGIS. And what I put here in the yellow rectangle, it's a very important aspect of our relationship with the local authorities, which is the preliminary archaeological risk evaluation. Very preliminary, based on land use, fieldwork, modern fieldwork, working, etc., etc. And it was very important because in the example, as you see, the northern part of this topographical unit, you see the square, the yellow square. These are housing that are being built, but were literally built where we were on the site. So we communicated to the authorities. We were able to speak with the Department of Housing, exposing the issue. So let's talk about archaeological risk and how to work together, because it's important to build houses. It's important not to erase everything, but we're talking with them. And it's a very important part of our approach and also workflow with the local authorities. And of course, we also had already inside the database all the information, all the archaeological features, and then we are now processing with spatial analysis and all the set of geoprocessing tools within QGIS. And we did all of these in just 3 weeks, more or less, and 3-4 people on the field, and all thanks to QField application. It was very important and very fundamental. So coming back to Shukur, so the perspective of this cooperation with Adarte is the implementation of the PyArchinit software plugin for the documentation for this excavation of the Shukur mound, let's call it, or archaeological site. And as I told you, we did some drone flyby, from which we were able to extract a 3D model in Metashape, and we start planning the future activities. And within this work, we have a very high potential because the site is completely inedited; it's never been excavated, and so starting a new site from the beginning using PyArchinit is a very important possibilities that we want to try to grab. And within this, it's also important to keep the formation of the students and all the participants, and mine as well, because, for example, the course that Professor Moderato took for PyArchinit, I'm going to take it starting from next week, actually. And so we have both the aspect of archaeological fieldwork that we try to merge together within this collaboration within PyArchinit. From one side, as I told, the beginning of the fieldwork in Shukur, it's very important to keep to have the possibilities to start fresh with the documentation, but at the same time also implementing the landscape documentation. And we're waiting for the approval of this research project within Sapienza to transfer the structure developed on QGIS for our survey within the framework of PyArchinit, to have just one platform, a really broad platform in which we can try to apply the PyArchinit methodology. Because one thing I understand from now is that PyArchinit is not just a plugin, but it's really a methodology related to information decomposition, analysis, and really differentiating description and interpretation, which is something we should discuss about it. But PyArchinit offer a very nice possibility to do that. And so we hope that this newborn collaboration will give us this new platform for both stratigraphic and landscape documentation. So thank you for your attention and for having me.
Grazie Guido, thank you Guido for this presentation, and if somebody has questions. Yeah, Moderato, sì. Please. Anche in italiano, se va benissimo.
Io ho una domanda per Guido, perché Castelcepro, diciamo, è uno dei contesti in cui stiamo lavorando, l'altro è l'India, quindi abbiamo, diciamo, credo dei problemi in comune, che sono quelli di lavorare al di fuori delle nostre reti geodetiche, delle nostre reti di connessione. Quindi nel vostro lavoro con QField avete usato tutta, diciamo, una base di dati in locale sul tablet e vi muovevate con quella, o eravate connessi e riuscivate a gestire la connessione e il lavoro online?
No, un elemento diciamo importante è stato che noi siamo sempre stati in locale, ancora non abbiamo sviluppato l'aspetto appunto Postgres online, che sarà proprio nei prossimi step della collaborazione, e questo ha aiutato perché avevamo un tablet e un computer. La mattina documentavamo le cose, tornavamo a casa, in realtà con un click si aggiorna il progetto QGIS e poi eravamo a casa. Il progetto QGIS in sé era nel cloud, però non è proprio la stessa cosa, insomma, ovviamente. Però no, l'abbiamo sempre lavorato in locale per adesso. Grazie.
Hai una domanda?
Yeah, I have a question. It's not about PyArchinate, but I wanted to ask this about Metashape. I saw it mentioned at least in two different presentations, and since there are now open source tools that work very well, I mean, I have some experience with WebODM, but there are also others. I wanted to ask if there are specific aspects that I mean were difficult to work with, or it's just a kind of established tool that is difficult to abandon. Thank
you. I'll try to answer this question in English. Well, it's true that it's an established tools and it's very, very user friendly. There are just 5 buttons you have to push to produce a point cloud. But I know also WebODM works basically the same way. I haven't tried it yet. I'm thinking to try different tools. We know there are many different tools, many open source tools. The reason I keep using Metashape till now is that for me it was easy to draw the polyline, the polygon, and then import it, because I export it in shapefile for the QGIS, and also in DXF if I have to draw some plants in AutoCAD. So it's implemented for the communication with other software. And I don't know if WebODM does it or not. That's why.
Just a consideration on what Marco said about the necessity still today to export and to have a hard copy also on paper-based formats, etc. But I'd rather say that probably I'm getting old. We need also, using these kind of tools, to have the possibility of having dumps in clean text-based format, CSVs and whatsoever, because of course we need to store for long-term preservation paper, but also we need to store for long-term preservation data independently from the platform they're using to be created. So that'd be a good point for lots of archaeological data, also to have a kind of hard digital copy in a plain format, which is platform independent. So I don't know if probably PyArchinate has an exportation tool that makes a text-based copy of everything with metadata whatsoever. So that'd be most interesting.
Yes, PyArchinate can export the single table in Excel, can export in PDF and each form, and in as an tool and function to transform a PDF in Word directly. So yeah, can export a text copy.
Yeah, probably CSV would be pure text.
Pure
More
text.
reliable. Yes, for the future generations.
Oh, yeah.
PDF you have to parse.
Yeah, there are not now, but it's possible. It's possible because it's yeah.
Molto brevemente, la questione sollevata dal collega credo che sia una questione fondamentale. Ho visto anche negli interventi di stamattina che molti dei lavori che sono stati presentati giustamente hanno come dire, utilizzato una revisione di dati precedenti, cioè diciamo gli archeologi prima di noi ci hanno lasciato la possibilità di intervenire sul dato grezzo proprio perché hanno trovato un sistema di conservazione del dato che consentisse alle generazioni future di rileggere diciamo gli scavi effettuati prima diciamo del nostro intervento scientifico sui depositi archeologici. Insomma, non voglio recitare il vecchio Barker che diceva appunto che the archaeological excavation sono irrepetible experiments, esperimenti irripetibili. Però dobbiamo tenere anche noi conto di questo fatto, cioè non vorrei che giustamente l'insistenza sull'elaborazione del dato, che è altrettanto importante, lasciasse da parte, appunto come diceva il collega, cioè il fatto che anche noi dobbiamo pensare non solo alla preservazione alla conservazione del paesaggio e dell'eredità culturale in sé come oggetto, ma anche delle nostre riflessioni scientifiche e dei nostri dati, perché altrimenti chi viene dopo di noi non avrà la stessa facilità che ho avuto io, per esempio, a rileggere il diario di Scavo di Piccoli. Per cui ho capito che c'era una buca che purtroppo ci siamo dovuti scavare, che copriva 3/4 dell'ambiente. Però questo credo che sia il problema, cioè non solo il sistema attraverso il quale diciamo il mezzo informatico ci consente di esportare poi il dato, ma come effettivamente riuscire ad avere un programma di conservazione che effettivamente consenta al futuro di rileggere le nostre riflessioni.
Posso aggiungere una cosa?
Sì.
Aggiungo una cosa semplicissima. Adesso, per esempio, dopo il DPCM del 14 febbraio, abbiamo l'ICA, l'Istituto Centrale del Catalogo, che ci sta facendo usare un geopackage e QGIS per poter creare questo grande database di carta archeologica a livello nazionale. Quindi, tra virgolette, usare QGIS per noi ci si è rivelato un'ottima idea, perché più o meno si sta andando tutti lì. Io credo che più che il supporto, questo lo dimostra la carta stessa, il problema è il backup. Il problema è stabilire un modo per backuppare bene. Le centrali nucleari sono disegnate su papiro, perché ad oggi noi sappiamo che è il papiro la cosa che regge di più nel tempo come backup. E anche fare la copia, tra virgolette, su carta non mi garantisce che domani la potrò rileggere. Quindi forse dovremmo stabilire soprattutto dei protocolli anche di backup, quindi come faccio a backuppare, come faccio a portare, perché io posso portare fuori anche il formato testo, poi dopo dove lo conservo? Lo stampo, e poi dove lo conservo quello stampato? Dopo quanto si rovina? Abbiamo un sacco di CD ormai nella soprintendenza, Stefano credo che lo sappia, che incominciano a essere illeggibili, eppure abbiamo backuppato. Ecco, magari io me lo segno, prossimo anno di ArcheoFOSS, Archinite come backup e come riuscirà a mantenere nel futuro i dati. Ovviamente dico Archinite, ma deve riguardare tutti noi. Grazie.
Ma da questo punto di vista, secondo me, diciamo, se cambiamo la parola, cioè passiamo da backup a archivio, che intanto è una parola italiana. Ok, ho iniziato a parlare in italiano perché ho seguito voi. Comunque, Se parliamo di archivio digitale, abbiamo una base solidissima di interi settori disciplinari che lavorano. E anche questo soprattutto nel mondo accademico. Abbiamo delle tradizioni ormai consolidate di repository aperti per la ricerca scientifica, di cui i dati archeologici fanno parte a pieno titolo, e quindi secondo me è quella la direzione in cui andare. Fino ad oggi qual è stato il problema? Il problema è stato di, diciamo, un termine improprio, proprietà intellettuale, cioè come fare a mettere subito al sicuro quei dati in un repository che ha un suo metodo di archiviazione sicuro, garantito e diciamo al di fuori delle nostre difficoltà tecniche, superando un po' quella ottica, no, molto tradizionalista di, come dire, chiusura dei dati fino al momento in cui questi dati non c'è stata l'edizio princeps completa, eccetera. Perché di fatto, insomma, non è la prima volta che ne parliamo ad ArcheoFOSS, però diciamo, non abbiamo, non per colpa dei presenti, ma non abbiamo fatto grandi passi avanti. Stamattina menzionavo l'Archaeology Data Service, sono 20 anni che diciamo come sono bravi quelli dell'Archaeology Data Service, e a parte il repository mappa, che comunque è usato da insomma, un insieme ristretto di archeologi, dobbiamo ammetterlo, non ci sono altri casi analoghi. Però diciamo, l'approccio per dormire tranquilli credo sia quello. Ecco.
Vorrei aggiungere una mia considerazione. Diciamo che più che pensare a come backuppare, secondo me, diciamo backuppare, archiviare, secondo me quello che salverà il dato sarà la proliferazione. Secondo me far proliferare i dati, condividerli, far sì che più persone ce l'abbiano, li può salvare da qualsiasi evento disastroso. Mi viene in mente nel Medioevo c'erano i papiri e le pergamene conservate nei monasteri, poi non venivano copiate, la gente se le dimenticava e queste si perdevano. Invece secondo me, più che pensare a strumenti, hardware, bisognerebbe fare in modo che i dati vengano ricopiati, che proliferino, insomma. Secondo me questo è.
Aggiungo anche a Stefano Costa, gli vorrei tanto chiedere, peccato non essere lì oggi, mi dispiace tanto. Io per esempio ho tutto il mio server di 10 anni con i dati dentro, ma non lo posso consegnare alla soprintendenza. Cioè, adesso per esempio in Emilia Romagna c'è l'ArcheoDB, ho chiesto con una mail come faccio a mandarvelo, te adesso aspetta perché ancora non siamo organizzati. Perché io non posso consegnare in formati aperti i dati?
Volevo portare un'esperienza di un progetto, segnalarlo. Il progetto Archeo fatto dal Ministero della Cultura insieme a CNR e una serie di partner italiani era legato alla valorizzazione di aree archeologiche italiane, ma in particolare una cosa su cui ci siamo battuti molto, insomma, come CNR, come laboratorio degli SPC, è stata quella di trovare una quadra ragionevole, possibile, scusate, forse vado di inglese, something that doable, let's say, in order to store all the data of the project, because it was the possibility, the occasion to have universities and the CNR plus the ministry that in the end owns the data of the archaeological record itself. So the idea was to publish everything. So everything on a platform that is intended exactly for this, that is Zenodo. Zenodo was made by another community and focused on very big data sets that they don't have to be lost, okay? Because it's very precious data paid with public funds, and they are from the CERN, so studies in physics. and okay, log a lot of data. And they have this big server that is under the ground, okay, is in Europe, and they have, by the European community, a lot of money every year in order to improve this data set, this drive space. Okay, the idea was, for all the partners, the take action was, please publish everything. You will get a DOI, a digital object identifier. It will be a publication for you and your group. So we made, me and Alberto Bucciero made a sort of guidelines to publish all this archaeological data there. And at least it was more or less a success. We are slightly happy about it. And where it was not possible to publish, there is an embargo solution. So you can say, okay, let's say that I publish everything and I put 50 years, for instance, for the data to be set free. It means that I will not, I will don't be on the earth maybe, but the data will be, and someone will use it. So why for Luca, why not to publish everything in Zenodo with the embargo? No more than that, with a descriptor, and so that you know that after you there will be the data. Just a suggestion.
E non si può, tutto lì.
Vuoi rispondere, Luca?
Data are not mine.
Era un consiglio che voleva darti.
No, ma non posso pubblicarlo, cioè deve essere il ministero a farlo.
Certo.
Noi aziende scaviamo come longa mano del ministero, quindi ho un sacco di dati belli collezionati tutto, ma non posso, cioè mi si viene detto meglio usare la carta. Questo è un problema che va oltre ovviamente il mezzo e l'ArcheoFOSS. Sarebbe bello magari avere, che ne so, l'ICA, avere il ministero. Cioè, abbiamo un problema pratico, legale, ecco. Non posso metterli io. Stefano lo sa meglio di me, ecco.
Sì, no, lo so benissimo e non ho risposte, ma senza togliere tempo a Julian, che ha probabilmente qualcosa di più sostanzioso, vorrei dire una cosa. Oggi abbiamo un DPCM, abbiamo delle linee guida che servono a costruire il geoportale nazionale dell'archeologia. Questo lavoro, secondo me, un pochino è anche merito nostro, cioè di merito di ArcheoFOSS, che da 15 anni, anche di più, si batte per spiegare che questo modo di lavorare, questo modo di condividere i dati è fruttuoso e valido per tutti. Oggi c'è una chiara distinzione, viene detto pubblichiamo dei dati territoriali e il dettaglio lo lasciamo negli archivi delle singole soprintendenze. Domani, secondo me, possiamo andare anche oltre, però per adesso abbiamo già questo primo passaggio che comunque segue un principio, che poi è il principio anche sancito dalla legge, di cui non ricordo il numero, sulla scienza aperta della fine dell'anno scorso, e quindi, come dire, la direzione non può essere che quella. Come tante cose ci vorrà un po' di tempo.
Okay, thank you so much for everybody. I take Julian, if you want to close the panel.
Thank you for this interesting panel. Probably we have some material for a next year panel about sustainability and open access of data. Of course, it's not the argument of this year. Dividing technical issues from political issues, legal issues, etc., because we shouldn't bring everything together in the same room. So many things can be said on that, of course. But before we go to eat something, we are all invited nearby to have the coffee break. I'd ask please Valentina Bonora to come to the desk, and she wants to introduce to us all a very interesting activity that they are planning to be in 2023 in Florence. So The floor is yours. Take your time.
Thank you so much. Okay, I'm an architect, and yeah. Okay, sorry.
Hai già condiviso?
Forse sì.
Ok,
Allora, così. Okay. Okay, so sorry, I'm an architect, and I'm working in a civil and environmental engineering department. So I'm definitively the wrong person to be here. But this morning was really interesting for me, and I think that in the borders we can meet really interesting persons. So it's really a pleasure to be here, to invite all of you to participate in a conference that we are going to organize at University of Florence. Maybe some of you still know, already know SIPA, or better, SIPA Heritage and Documentation. It is an international no-profit organization that aspire to technology transfer from measurement sciences into heritage recording, documentation, and preservation disciplines. So in the past, SIPA stood for Comité International de Photogrammétrie Architecturelle. It is one of the oldest international scientific committee of ICOMOS, and it was founded in 1968 jointly between ICOMOS and ISPRS, that stands for International Society for Photogrammetry and Remote Sensing. And besides other activity of SIPA, every 2 years, SIPA organizes an international symposiums, and the next one will be next year in Florence, and in June. And Professor Grazia Tucci has been appointed as a director symposium. She's a professor in geomatics at University of Florence, and if you don't know Grazia personally, you may heard from her about the real scale reproduction of Michelangelo's David that was exhibited in the center of the Italian pavilion in Expo 2020 in Dubai. And many other persons are, like me, are involved in the local organizing committee, both from university and other research institution. And the title we choose for the 29th SIPA Symposium is Documenting, Understanding and Preserving Cultural Heritage, Humanities and Digital Technologies for Shaping the Future. So it is my pleasure to invite all of you to have a look to the website of the conference, where you will find the topics on which the conference will focus, and on which I'm sure many of you have interesting things to say. So our aim is to carry on the long tradition of SIPA, of course, by welcoming experiences and exploring with new technologies, but also trying to assess their limits, let's say, in a critical way. In other words, we hope to continue to put new stones to build the bridge between users and special data providers in the field of cultural heritage. So let's take note of the dates, and if you're interested in any more information, feel free to ask me, and all the organizing committee will be really happy to welcome all of you in Florence next year in June. So thank you very much.
So we'll have a break now, and we will continue at 3 p.m. o'clock. Okay, thank you very much, everybody. Non lo posso fare.
Grande caos. Sì.
Tu c'è PowerPoint di Coseo?
Poteva essere un panel, solo che si mischiano un po' con troppe cose diverse. Il discorso sull'archiviazione, guarda, qui c'è il P1, qui c'è il P1 e noi siamo P2, P02, che pomeriggio quello mattina 2.
Sì.
No? Leggibile. Leggono un po'. Vabbè, tanto poi le commento. Ah, non si vedono proprio i nomi, eh? Non si vedono i campi. Troppo piccoli. Così però sì, questo sì. Vabbè, tu sei pure ciecato senza occhiali però. Ah, è solo da vicino. Ah, questa si legge, queste belle frecce. Ok? Troppo? Sì, però è l'esempio. Devo questa? Sì, vabbè, ma sono solo immagini. Solo per alla fine è solo come slide, ma come contenuti no. Ci stava una questa. Ah. Non molto. Let's wait for the because I don't know whether
I can't log in. Where's my colleague? He's gone.
Got your password?
No, I don't think so. I think it's probably something with. I think it's the shift. Let's try.
The keyboard layout.
Yes.
Okay.
Yeah.
And maybe you've kept logo?
Yeah. It's looking better. No, I can't log in. You have to log in. Like you have it too, right? So.
This is yours.
Okay.
The personnel attending your panels. I mean, there are some. Thomas is not here, of course, etc. But
Okay, we have and so far I didn't find Federica and Nadia. I don't know if you saw them. I think they were.
yes. Was
Okay, but you already saw him, so.
Yes.
Okay, we just have to get the presentation. Okay, that's.
So, good afternoon, everybody. I hope you all had a quite good lunch and maybe a glass of wine, and now you're strengthened for the second part of this day, for the afternoon. Thomas, my co-host for today, which unfortunately cannot participate in person, and I both work for the German Archaeological Institute in Berlin. Thomas is the lead developer of IDA Field, our system for documenting archaeological fieldwork, and I'm responsible for all research data management. So we both are highly involved in the management of field data at the German Archaeological Institute. As we have already seen this morning, a lot is going on with regards to the use and development of software for documenting fieldwork. Many of the changes are not simply a transfer of analog workflows to the digital, but fundamentally affect the way we work and force us to question and rethink the methodology we use. That is why Thomas and I are glad that we had the opportunity to organize this particular panel in the ArcheoFOSS, to which I am happy to welcome you today, with the title Practice and Paradigms of Open Source Technologies for Archaeological Field Data. We now will have 5 presentations covering a very wide range of topics. As in the previous panels, the discussion will be held afterwards, after the last presentation. As we have a full program today and time is accordingly short, I will ask all presenters to stick to their 50 minutes. That worked quite well, or surprisingly well today. I'm really surprised. And with this said, I would now hand over directly to our first presenter, Angela Bosco, which will present or give a talk to virtual RTI application on 3D model for documentation of ancient graffiti, a purpose of methodology for a complex archaeological site. Just wait a second. I have to first. No.
Select the preview down. Which select this, click on this,
Okay.
and then share.
Thank you very much for introducing, and good evening, everyone. Today I'm presenting also in behalf of my colleagues, Leonora Minucci, PhD of University of Naples Orientale, and Daniele De Luca, a computer graphic expert from Consortium Cineca, that attending from remote now. The project that we present today concern the creation of a virtual dome for RTI acquisition, and have 2 main aims: to make it possible, or at least simplified, acquisition, the RTI acquisition in a difficult environmental context, and to reuse high-resolution 3-dimensional survey acquired for other purpose, and also with intention to reply the analysis along the time. Really, in a nutshell, what is RTI? Reflectance Transformation Imaging, as defined by the non-profit organization Cultural Heritage Imaging, developers of the software and the related methodology, is a computational photographic methods that capture a subject surface shape and color, and enables the interactive relighting of the subject from any direction in a software viewer, revealing details not visible with the naked eye. So a very powerful tool for archaeological purpose, and archaeology and in general cultural heritage like it because it's a 2.5D methodology, so it's the shape of a 3D model, but it's more easy to manage. It's a not invasive methodology. Use software totally open source, and requires common equipment, just a camera, photographic equipment, and a tripod, and a spotlight, and have is usable in several environmental conditions. I mean, it's usable in the lab, but also on field. So, in brief, really in brief, how does it works? The HRTI, highlighted based RTI, by using one or two reflective targets, it usually is a dark colored sphere in each frame of the same position within the image frame, is able to calculate the position of the light directly from the reflection of the sphere recorded in each photograph. So it is important that the subject is illuminated in the round by several grazing light positions that illuminated angles being between 15 and 65 degrees above the surface of the subject. So the camera will maintain a fixed framing while the light source will be moved on the precise angle, as we can see in the draw. Through the use of an RTI dome in which each position of the light is provided by a different illumination source, it is possible to have acquisition of a great detail and precision. The so-called light dome is equipped with a top hole for housing the camera and LEDs that allow the object to be illuminated from different points, equidistant and synchronized with the camera shot. This technique is specifically suitable for the acquisition of small objects, so is used generally in laboratory. Our research group, the group of the CISA, the Interdepartmental Center of Archaeological Service, to overcome the some lighting problems and lighting issues, tested the use of this dome in field as part of a research, an archaeological research conducted by Dr. Dauria in the two domes of the regio of the first regio of Pompeii. And there were many advantages to use this technique on in situ due to the stability and the speed of this instrumentation, but the reduced acquisition capacity was limiting, and as well another limit is the technical complexity to adapting an instrument that was not designed to stand up in vertically, or in this case. In September 2019, we had the occasion to collaborate in a big project of documentation to scan and documentation of the entire site of the catacombs. It's an international project that involves us, like University of Naples Orientale and the Zamani project, a South African research group, coordinated by Global Digital Heritage, a no-profit organization, American no-profit organization. So we have the possibility to test various many techniques in a complex, a very complex archaeological site. It's a very suggestive place for visitors, but a very difficult place for surveyors. So the main obstacle in this situation is the poor lighting and also the lack of sufficient power connection to bring external light source, and then the very small spaces which complicate acquisition process and condition to positioning equipment, and last but not least, also the static issue, the stability of the ground surface, as you can see in the photos. So also the floor was excavated by the burial, by the Hans burial. So we tested in this place acquisition, which a classic HRTI methodology on some Arcosolium burial that are the burial characterized by this shape with a big arch painted, and that was characterized by the presence of graffiti, a very big presence of graffiti. But unfortunately, it was not possible to respect the ideal angles of light emission due to the shape of the burial, which the arch, that is a physical obstacle, does create the obstacle to the illumination of the back wall that was the object of interest. And as you can see in the reflected sphere in the target, you can see that the top of the sphere doesn't have the return of a spot of light, no? And so other complication is also for the narrow space, and which in several times caused a vibration of the camera. So photo frame, blurred frames, and problem in the post-production. The results were therefore not satisfactory. And but as I can see, the catacombs project was a big project of three-dimensional acquisition. So we have a lot of three-dimensional model, three-dimensional surveys. At high resolution, very high resolutions. So we try. So was born the idea to build a virtual dome that could operate as the RTI in reality. The virtual dome, thanks to the precious contribution of Daniele, was built in a Blender environment, and the dome was recreated which characteristic as faithful as possible to a real dome, so that it could be compared with a work with real dome, but at the same time with the intention to overcome the limitation of this real tool. So the phases are the importing of the 3D model file into Blender software, then creating the structure of the virtual dome, which three concentric level of lights equidistant from each other. The type of lights is a point type, such as a small bulb and or a LED, to be more faithful to the reality. And the large diameter level present 24 lights, the intermediate 18 lights, and the top level 12 lights, also for replicate an existing dome. Then was created the positioning the shiner reflective sphere, and another advantages of this method is the possibility of positioning this sphere in any place of the scene without have an obstacle, create an obstacle with the subject, and positioning the camera settings of the render setup. The render setup was a typical setup of a photo camera, so we chose the resolution, the focal length, for example, but we have also changed some value that normally we have to change. For example, we set to 0 the light bounces. So in this way, we the intent is to avoid the color glare and optimize the shadows. That was the basis of the system. So then running the ad hoc Python script for simulating the progressive illumination of the object. So first turn everything off and then turn on one at a time and make one frame, and then rendering with the name of the specific light that illuminated, and so turn it off and repeat for all the others. The dome is totally scalable according to the model, so to the subject, and this is a great advantages of this solution. And for example, in this test, you can see you can see the survey of a wall that was about 19 meters high. So working on the 3D model made it easy to remove the obstacle, such as the famous arch of the Archeosolium. So for the correct lighting of the wall, and the activation of a virtual capture process on the wall of the Archeosolium was carried out by activating rendering cycles engine for real shadow, for a real shadow, and producing images at a resolution of about 3814 per 2160 pixels, then exported in JPEG format and processed in the RTI builder software by applying both the registration technique RTI and the PTM polynomial texture mapping to have the possibility to use different rendering that the software make possible to apply to the final result. So the comparison with the results of the in situ acquisition and the virtual acquisition clearly show the improvement in the readability of the information on the wall, even with the application of a filter that I said, this particular rendering that is possible to apply in the software. For example, in this case, we applied the specular enhancement, also show that we have a significant improvement of the results. In conclusion, I hope I'm terrified for the time, but probably I ran too much. Sorry. So, in conclusion, this methodology, this virtual dome, this methodology that we have implemented, overcoming the RTI limits in some field context, is applicable to object at risk, or an object of all the size, and also an object difficult to detach with the traditional HRTI method. It's possible use a different kind of 3D survey, 3D model as basis provided by photogrammetry, as in our case, but also from laser scanning, for example. Allow the management of the lighting, so different kind of light, the power of the light, and also the number of the light, and the ability to repeat the RTI analysis over time with other, obviously with other data. And obviously this kind of work depends totally from the resolution of the mesh that we used as basis. So thank you for your attention. So thank you very much for this very interesting talk. Our next presentation will be held online by Laura Carpentiero and Doria Dauria. And the title is Operative Tools for BIM in Archaeology Libraries of Archaeological Parametric IFC Objects.
Good afternoon.
You can start whenever you're ready.
Yes. Yeah, thank you.
Just
thank
a
you,
moment. Yeah, okay.
Okay, do you see our presentation?
Yes.
Okay.
Okay.
Okay, good afternoon, everybody. I'm Dora Davran, here is Laura Carpentiero.
Hi, good afternoon.
And before beginning our presentation, we would like to thank organizers for accepting our proposal. Laura will begin. Thank you.
Yeah, thank you, Dora. Well, our contribution will focus on the application of BIM, acronym for Building Information Modeling, to archaeological evidence. We will present the initial stage of a research project whose aim is definition of operational solution concerning both use and free access for the creation of BIM models. These models, employed for the archaeological evidence preserved in elevation, can be exported in IFC interchange format. The creation of 3D model for cultural heritage has now become a common practice for the study and enhancement of work and the context. Today, the progress of technologies applied to relief and management of 3D data allows to obtain high-resolution virtual replicants in a short and at low-cost times. Within our contribution, we present the application of the BIM working methodology to the management of archaeological contexts. We think that the BIM represents today one of the most innovative technologies that allow to manage not only 3D model as it's in reality, but also, above all, to connect a large amount of information of different nature to the model. This information, working together, allow to develop research, analysis, and new survey because they are a real complete data platform. BIM was born as an innovative method for designing works and infrastructure. Today, largely widespread in professional firms, it has become a common practice for engineers and architects. With BIM design, which takes place through dedicated software, it is possible to create the 3D model of the BIM to be built by using, for each part of it, the so-called parametric objects. Parametric objects are three-dimensional models of structural, architectural, and engineered system elements that are part of the building or of the work to be built. They are defined as parametric because they have a large amount of information inside. This kind of information concerns the geometrical shape, for example, the morphology or the material technique with which they were built. All the information inserted inside the parametric object can be queried and form the basis for subsequent scientific analysis. Through a BIM, it is possible to create a real management system for an asset, a public work or a building, because it provides a platform for monitoring all their phases of life and a tool to control the management and the maintenance activities. On the last few years, especially in Italy, BIM applications have shifted to cultural heritage and have been adapted to historical buildings. This creates the basis to develop analytic scan-to-be process, stressing on the need to obtain high-resolution and geometrically reliable surveys for historical buildings. HBIM, heritage or historic BIM, represent a consolidated reality within the scientific debate that is focused, above all, on the detailed modeling of particular complex elements part of the historical architecture, trying to create the BIM models as close as possible to existing reality. In the last 10 years, BIM made its way through the international archaeological debate, raising curiosity, questions, and new challenges. The greatest potential to the use of BIM methodology in archaeological field lies to change to obtain a three-dimensional reality-based model of the asset. Furthermore, the asset itself gets enriched with a large amount of information that make it's a real database. Many Italian and foreign teams have used BIM to generate a three-dimensional model of archaeological site. Here in this slide, are present some of most relevant Italian experience of BIM applied to archaeology through different methods. For BIM or HBIM, the major difficulty is recreating the variety of evidence present within an archaeological site. As said before, a BIM model is based on the interaction on the individual parametric objects. They create the model itself and allow the representation of the relief of the archaeological context. The work we present here proposes the creation of parametric BIM objects that can best represent the complexity of the archaeological reality. For object modeling, we choose to work using Autodesk Revit software. Revit is organized in order to have a hierarchical subdivision of parametric object. The routine is closer than it might seem to the archaeological classifying process, because the unseen evidence subdivided likewise by archaeologists in typology and building technique. The subdivision is organized by discipline and analytical categories. For the discipline, we can identify three main topics: architecture, structure, and system. As to analytical categories, we have three: family, type, and distance. Each parametric object is identified by categories it belongs to. To each family of objects, numerous various subtypes are recreated based on the variation of the object parameters. For example, in the Revit classification process, a wall object will belong to walls family. Then, regarding the type, there could many different types of this family based on its geometrical shape changes, on its construction technique, etc.
In order to implement on a scientific basis the BIM methodology and make easier and faster the modeling of archaeological structures in a software created for modern architecture, a model of semantic library has been created. This model is very useful because the BIM archaeological objects it contains can be reproduced and possibly modified for other projects. The site of Pompeii has been chosen to be the reference context for the creation of this library. Indeed, its extraordinary state of conservation and wide variety of architectural types it offers constitute an essential point of reference for researchers concerning Roman architecture of the Republican and Upper Imperial Age. Later, in a second phase of research, the variety of types identified at Pompeii will be developed further and completed by using data coming from another site destructed by Vesuvian eruption in 79 AD, that is Herculaneum. There, indeed, different destructing dynamics permitted the preservation of evidences that are no more recordable in Pompeii. The richness of records coming from Vesuvian sites has to be considered like a documentation of great value for the creation of libraries supporting information systems for research projects concerning both Vesuvian towns and other sites of Roman Italy. Therefore, Pompeii and Herculaneum constitute an ideal case study to test the potentialities of BIM as a platform for managing records coming from an archaeological context. Records included in documents of different nature like texts, photographs, drawings, 3D reconstructions, and that concern, for example, archival researches, stratigraphic analysis of emergent structures, excavation investigations, or degradation analysis. The Vesuvian context is therefore a valid field of experimentation to evaluate how to transform a BIM information system into a tool that can effectively support archaeological research, especially in the phases of data organization and interpretation. These reasons led to the development of research projects which aim is to adapt potentialities of BIM to the archaeological context through the analysis of evidences discovered in Vesuvian sites. This goal will be achieved in two ways. On one hand, by perfecting the modeling phases through a case study chosen in the domestic architecture of Pompeii. On the other hand, by creating a semantic library model exportable and including a range of parametric objects so wide and varied that it can correspond to the set of elements that would be part of the BIM model. Here we will talk about the creation of the semantic library that in the first phase of research concerned the evidences coming from Pompeian domestic context. At the origin of the creation of the semantic library model, there is a repertoire of architectonic and structural elements, as well as of hydraulic and thermal systems elements, of which a Pompeian house could be made of. This repertoire has been developed by both a bibliographic and a field survey, the aim being to gather together all the possible variants of the elements. To identify these variants, the entire set of their features has been taken into account, as the variation of one of them can be regarded as a discriminating factor for the type identification. Therefore, for each parametric object's family, the architectonic function, the morphology, and the composition of each element have been analyzed. For example, in the case of the wall family that makes part of structural objects, the different functions of the element inside the building have at first been identified. Then, its shape in plan has been considered, and finally, its composition, identifying materials and building techniques employed for its construction. These latter, the building techniques, have been indicated using the traditional nomenclature of Pompeianist studies. However, to get an easier identification of building techniques and of libraries types, it has been considered worthwhile to guarantee an unambiguous identification of data by linking them to standard systems like Art and Architecture Thesaurus or Thesaurus Factor. Based on the Pompeian archaeological evidence, in addition to the library of archaeological parametric objects, we created the library of building techniques specific to the Pompeian context to be applied to individual objects. Each element modeled in BIM is accompanied by its own construction technique, which is made browsable in the model by reading the internal stratigraphy of the elements. Each building technique is organized in material tabs that group together the description of the technique, the pattern used for the texturing of the elements, and the graphic appearance, both line and fill style, that the material assumes within the DVG tables that can be extracted from the model. In order to obtain an excellent graphic rendering of the parametric objects modeled in BIM, orthophotos obtained from photogrammetric surveys were used as a texture for the external facings of the walls. Correlation of data to the semantic libraries objects is possible thanks to Abacus. These are tabular structures that, in the scope of this project, have been enriched of a series of specific items, transforming them into a useful tool for archaeological analysis. This operation allows the adaptation of BIM to the archaeologist's needs and its transformation in an information system suitable to the management of data coming from archaeological investigations. In the case of a wall, for example, it is possible to fill the abacus with records concerning different topics. Have been taken into account the position of the wall inside the building, its function, the stratigraphic relationships with other elements, its constituent and morphological features, and the presence of coating and its features. It is also possible to include data about elements' building history, its discovery, the investigations it had undergone, and photographic or about graphic and photographic documents and the deterioration monitoring. Inside each field, it is possible to upload textual data or external links to several files or types, including ones for images and 3D reconstructions. Data fields in the abacus are...
Excuse me, I'm sorry to interrupt you, but you have to speed up a little bit and come to the end. Your time is nearly over.
Oh, yeah. It's already over? Okay. So all these data are summarized in a property sheet that you can overview when you take over the structure, and for the conclusion, we will say that despite coming from an ArcheoFOSS software, the archaeological parametric objects can be exported without alterations or variations in the IFC interchange format. The IFC interchange format allows the BIM object to keep all the geometric and graphic characteristics and all the specific information, such as all the values in the property sheet, identified as the real attributes of the parametric object. The exported IFC files can be imported within all the software working in the BIM environment and are available on all modern operating systems. Thank you, and sorry for the wait.
Yes, thank you very much for your talk. So, just going to change. No. No. Where is it? We put it here, or didn't we? Yeah. Okay. So I would invite our next speaker to come up here. Federica Rinaldi, Alessandro Lugari, Francesca Sposito, and Ascanio D'Andrea. And they will give a talk about between archaeology and conservation, digital tools for digital bridges between disciplines, the risk map of the in situ mosaic and marble surfaces of the Parco Archeologico del Colosseo. Quite a long title.
Yeah. Good afternoon. Thank you very much for accepting our report. Here there are with me Ascanio D'Andrea and Francesca Sposito. Online is Alessandro Lugari. From 2018, the Parco Archeologico del Colosseo is engaged in the project Risk Map of the in situ mosaic and marble surfaces of the Parco Archeologico del Colosseo. The archaeological area of the Palatine Hill, the Domus Aurea, and the Roman Forum indeed includes then more than 200 floor paviments. The list includes coccio-pesto floors used in the service rooms, but also and especially black and white tessellated mosaics and opus sectile marble floors for the representative rooms. Some of these floors can be seen inside the houses and palaces on the Palatine Hill. For example, the House of the Griffons, the House of Livia, the House of Augusto. So the civil buildings, such as Basilica Emilia and the Roman Forum and the Curia Julia, and the places of worship, such as the Church of Santa Maria Antigua. Particularly numerous, however, are the open-air surfaces, and among these are the sectilia pavimenta, those floors constructed by the combination of colored marble pieces. These are the most fragile floors because they are subjected to the thermic stress of high summer temperatures and the winter frost, and to the trampling of the 20,000 tourists who every day visit and walk in this extraordinary compendium of history and architecture, not always perceiving that they are walking inside a representative space, a corridor, a portico, inhabited in ancient times by ordinary Roman citizens or emperors. Most of these mosaics were catalogued and studied in the 60s by Maria Luisa Morricone Martini, and in recent years have been digitized by the University of Padua in the project TESS. In order to maintain this cultural heritage in situ and tell its story, the Parco Archeologico del Colosseo has been carrying out a monitoring and maintenance program since 2018. The first results were announced on March 2019 in Curia Julia within the framework of an international workshop.
Appropriate and dedicated monitoring and prevention measures against the risk of decay or loss have been designed for this particular category of materials, taking into account 3 types of extreme events, in particular: 1. Biological attacks by weed vegetation, 2. Climate change, and 3. The social context. For example, the tourist pressure that ranks among the primary cases of wear and tear of pavement levels. A multidisciplinary team of archaeologists, architects, restorers, and computer scientists was created and set up to tackle and manage this complex work in the best possible way, which first tested a multi-level sheet. 1. Information level on the context and type of covering. 2. Conservation level dedicated to the history of conservation. 3. Deterioration level with a specific vocabulary of factors such as structural damage, material decay, disintegration, humidity, alteration of biological origin, and so on. The combination of these levels provides the severity index and the urgency of the intervention. Once this initial stress test phase was completed, which also served to identify and codify the treatment of the gaps and the aesthetic and the final presentation of the floors after restoration, it was decided to proceed with the data digitalization and management inside a comprehensive WebGIS environment. Inside the WebGIS platform, daily filled with running activities and new images, an historical archaeological section was prepared for each building together with a dedicated floor unit form, divided in 2. No. Okay. The archaeological part, including a description of the floor, the decorative type, dating, bibliography where existing, and so on. And the conservation part, where the state of the art is described, and the type of exposure to degradation, the presence or absence of covering and protection, both stable and seasonal. The fieldwork has made it possible to move from extraordinary maintenance to periodic routine maintenance that involves scheduled monitoring for each flora unit according to its criticality, reducing the risk of damage and turning it into a value. Observation data, monitoring, intervention card. So, the monitoring made it possible to draw up a direct intervention plan on the pavements, which included a status report followed by cleaning operation, blocking mobile elements, restoring and preserving the border of the preserved fragments, and where necessary, applying a system to prevent the regrowth of infesting vegetation, and a periodic biocide treatment on the surfaces. Seasonal coverings with delta-lite sheets were also arranged for some of them when temperatures, both in summer and winter, reach alert levels. Finally, a treatment of the lacune was studied and tested, aimed at both restoring the original design with a chromatic alternation of the stone pebbles placed to fill the lacune, and at isolating them from weed roots, thus better preserving the mosaic or marble floors.
Yes, we continue just with a little overview of the web platform in very synthesis. So we can have these images shows the logical architecture behind the web platform. It is mainly based on 2 servers, and it's important to highlight that it's one managed from the Park Archaeological of the Institute of the Park Archaeological of Crusade, and the other one, the public one, is directly from the Ministry of Culture in Italy. The first one is a private server under VPN and is directly used for daily activities, to connect to the data, to protect data, and to manage this. The other one is for public information and sharing all the data that we are storing along these years. The web application works as a back office repository and management system for data manipulation and storage against the normal Postgres.js database, where spatial data and attribute data are daily recorded by users using tablets connecting to VPN directly on field during all the data activities. The interaction with the GIS section based on open layers is delegated to GeoServer web services running on the same server. In order to manipulate spatial data, a secure connection to the geodatabase is established directly through QGIS. Public server based on Apache web server can connect to GeoServer's web services, and it's mainly used to allow public users to interact with the selection of this data and extract it from the main database. You can read on the slide the public URL to reach the website. That is a public website, and it's based on leaflet libraries with several add-ons getting from open source libraries that are available on the website. The database schema, going a little bit deeply inside the architecture, the geodatabase and its relation can be summarized as these main entities that are highlighted in the slide. Buildings and floors, pavements are the two main entities, as you can imagine. Several data are related to these entities in terms of archaeological information and conservation data. Daily activity related to monitoring, to intervention, are stored dynamically in specific tables related to these main entities. So as you can imagine, it's a very simple relation path, but it's strictly connected to these main daily activities that are implementing the data all along these years. The web application reflects what we have seen about the data schema. So its main features can be summarized as a section for data management. It means inserting, updating, uploading, deleting, etc. Section dedicated to secure data storage and indexing. That is an important feature because the data is growing over here by here. The WebGIS section for spatial data interaction and visualization, and a custom session for data analysis that is very important and useful that we are going to implement with other custom graphs. This graph is made from the Google Graph libraries, directly using JavaScript customization of these libraries. And graphs are dynamically connected to the database, so are updatedly dynamically depending on what happens to the data. The information system has been designed on the real needs of professionals, and is proving to be a valid tool for the optimization and integration of conservation and archaeological data with operational activities, with a view to the medium and long-term action and program. The improvement achieved with this kind of digital tool must be seen mostly towards its dynamic approach to data collecting on the field, focus on user needs in order to connect, relate, and inform conservation practices to archaeological information on the ancient floors. That is all the part that Federica shows you about the archives and the historical information about the pavements. This kind of connecting approach was able to trigger the correct awareness on heritage values and significance in order to create the right balance between conservation and enhancement needs. If the WebGIS constitutes the back office of our daily work, accessible to employees through passwords, in order to share and favor the access to this heritage to all visitors, both in situ and online, at the end of the first 3 days phase of the project, an interactive web map has been published online in May 2022, in order to share with public users selected data related to the ancient floors of the Parco. The web map that is available on the URL that you have seen before allows at this stage, so I repeat, at this stage we are going to implement this, to get descriptive text and a gallery of images of the ancient floors, and it is planned in text feeder to improve data sharing through APIs and web map services. For example, here, as you can see, clicking on the maps, you can receive a list of images, selected images that show not only the pavements floors itself, but also the conservation work that are running on these very important floors. And you can interact with geolocation if you are inside the Park Archaeological, because the geolocation is restricted inside the area of the park and not outside, but you can obviously interact with other features that are on the map. It is it is based in Italian and English. We are going to implement probably also in other languages, and there exists a little help tutorial based on an open source library. I don't remember exactly the name, but it's an open source one, and that allows the user. Consider the user could be tourists, could be professional, could be everywhere. So yeah, and so it's useful to them to have an help online to interact with the maps. And clicking on each polygon displays the floor file associated with the gallery of images. Mostly, for example, these incredible floors of House of Vestal Virgins, Forts of Juturna, Basilica Emilia, Curia Julia, Aurea Agripina, and the Palatine. The map will also be updated with data belonging to the so-called super places. It means the super is a special ticket for the area that allows people to go inside places where are normally closed, right? So we are going to provide also this data in order to provide this information also to who doesn't have this kind of ticket. And the goal is undoubtedly to offer an exhaustive panorama of decorated floor surfaces to convey the value of these precious indicators of luxury or service in ancient residence, and to reduce the risk of indiscriminate and misunderstood trampling. In fact, the map, if well used, lends itself not only as an interactive guide to deepen the knowledge of covering techniques, but also as a tool to build itineraries on a chronological or thematic basis. And this is planned to be done with this release of APIs that can allow us to create, for example, apps or other kinds of approaches, collecting this data and distributing to the public. Okay, these are other images. So thank you very much for your attention.
So our next speaker will be Juliane Watson, which talks to IDA Field developing software for the documentation of archaeological field work. Yes.
Good afternoon. First of all, I want to thank everybody that has been speaking English today. I really appreciate being able to understand everybody. Even though my Italian is non-existent, I can say buongiorno, but that's pretty much it. Hopefully next year when I see all of you again, that'll be better. So yeah, I'll be talking about IDA Field today, or Field Desktop, which is the system for documenting archaeological fieldwork of the German Archaeological Institute, or in German, Deutsches Archäologisches Institut, so DAI will be the short form that I'll be using. We conduct a variety of field research types all over the world, each with its own unique documentation requirements, so excavations, surveys, and building recordings. These resulting, of course, the differences in documentation also result in the software being used and the data created. In addition, the DAI's international work has to comply with guidelines of the respective heritage organizations or agencies in the host countries. IDA Field was developed from the very beginning with the goal of being able to meet these very different requirements. I'll be talking about the way from an in-house application to an open source product, and tell you briefly about the functionalities and features and the components. Of course, there's not a lot of time today, so I do encourage you to look it up afterwards and, of course, read the proceedings. For the development history, previously the DAI used a whole range of individual development project-specific systems for digital documentation of the field research. Maintaining all these different software solutions and individual systems was very resource intense, especially for IT department, of course, and there was no uniform data model. Information stored in these systems could not easily be compared to one another and was only published in the context of classic excavation reports, so in print form. The first version of IDI Field was developed since summer of 2006, so it's been quite a while in close cooperation with the Pergamon project. I think most of you will know that, by the IT department of the DAI and the Cologne Digital Archaeology Laboratory. Back then, FileMaker was chosen as the technological basis for the systems, as this application was sufficiently functional back then to be able to map the chosen object relational database data model. The idea then was a modular structure for adding project-specific needs as this, and then be able to add little parts of the data model as it was needed for different projects. In practice, however, these adjustments turned out to be very time-consuming, as changes made during one project phase had to then be copied back into the so-called master clone of the project and then be brought back and dispersed to everybody back in the field. The use of proprietary software also proposed, of course, a problem. For example, software changes that were not backwards compatible, then forced for us version jumps sometimes, and a lot of user interface work had to be put into it, for example, to just rechange one button or one translation or whatever. Additionally, desktop and server licenses for numerous excavation computers represented a considerable financial expense. And finally, of course, the use of proprietary software contradicts the open source, the open source idea to which the DIIT is committed. However, since FileMaker IDI Field was already being used by more than 35 projects at the DII, it was decided at the end of 2009 to address all the problems that had been identified and to develop a new database solution based on common web technologies. For this purpose, the DI cooperated with the Brandenburg University of Technology, which is Cottbus-Senftenberg, which had developed their own information system, also an application for documenting archaeological field research, which was called CSAR, if anybody's interested. And the scope of the combined project of the DAI and the University of Technology in Brandenburg was quite ambitious. There's a lot of features. I think you can kind of grasp how large the original idea was by this image. We will, of course, include all the references in the proceedings. So if you want to, it's a very long list. You're very welcome to check it out. But the project, unfortunately, was pursued until 2016, but it didn't produce any workable software. It produced a lot of theoretical framework that we could then use to keep working. So in 2016, it was decided at the DAI to start a new project and develop the application from scratch in-house. And I give you the specifications here that were originally decided on. But I think it is more interesting to talk about what it can do at this point and not what was originally designed. But this is for you to compare to what's going on later. Of course, as briefly summarized, you can imagine how much talk there was and how much crunching of the initial requirements. So this is, of course, very, very summarized. From the very beginning, however, the application was to be based entirely on open source technologies and to be usable under Windows, macOS, and Linux, because we have kind of everything going on at the DI in different countries. And therefore, we decided to rely on web technologies. The application is written in TypeScript and uses established open source frameworks such as Angular, or we've already heard of Leaflet. One of many advantages of this approach is that the functionality and layout of the application only has to be implemented once, more or less, and they are then available identically with, of course, minor adjustments to the other operating systems. By using the Electron framework, the application can be delivered as an installable desktop application. The web application is executed within pretty much a shipped with delivered Chromium browser, and thus appears to the user as if it was a desktop application. The approach also allows the application to be installed very easily. It's just one component that the user has to install, not multiple libraries or dependencies. It kind of just comes in one package. To enable us to robustly support offline work with later syncing between researchers, which is one of the paradigms in the initial development, so offline first, because that's where field work happens. The the JavaScript database PouchDB is used with a browser variant of the NoSQL database Apache CouchDB. The central feature of both CouchDB and PouchDB is the ability to replicate. So this data of one database can be transferred to another database. The replication can also be automated continuously, which is then synchronization, which is the core functionality that we are using for Field Desktop. So therefore, Field Desktop can be used offline, online, alone, or joint. There's multiple scenarios which we have played through. There's a lot of documentation on it as well. So I will not go into detail here. Another reason to use PouchDB was the fact that a NoSQL database fits perfectly within the plan that we had to give the user the ability to change their own data model as they need, with having kind of a fixed common data structure for enabling some comparability. At the same time, of course, we wanted to give the user that idea of being able to add something that they really needed, because that was a really big problem with the first FileMaker IDA field, that people were just not able to do one small thing that they needed to do. So by using PouchDB, documents can be modeled and stored as a JSON object with arbitrary fields. The structure of these JSON objects is stored within the project configuration, which is also another document in the database. In IDA field, each entity is a resource classified. Is that right? Should I go back? No, I think I went. No, that's fine. So in IDA field, each entity is a resource classified by specific categories, so stratigraphic unit, find, image, and the resources are described by a set of fields and linked with each other via relations, so hierarchical relationships, temporal or spatial relations. Which categories are available within the selection of a project and which fields can be filled out is dependent on the category, and the category is then defined by the project configuration. The configuration is composed of 3 parts of different levels of configuration or domains, each fulfilling a specific role between the poles of comparability and adaptability. The core configuration defines the framework within which all IDA field projects operate. Here the main categories, so for example, find, as well as their possible linkings via relations among each other, are determined. Furthermore, the most important fields are directly referenced in the application code. So for example, identifier, that is the IDA field internal ID, and also the geometry. The library then contains a number of subcategories, for example, potteries, a subcategory of find, and the fields for further description. The fields were chosen by evaluating projects created within IDA Field 1 and also from the Open Infra project. It was checked which fields were actually used the most, and so we kind of tried to figure out what people actually used from all this variety they had to choose from. Of course, the use of the library is not mandatory, but should motivate users to reuse existing categories and documentation fields, so not always starting from scratch, but instead having a set to choose from. It is also planned to gradually extend the library in the future by using the configuration data of other projects and kind of supporting users with that idea. In addition, project-specific subcategories and fields can be created to meet unique requirements of a project. So data entered on this basis cannot be compared to other projects, but that is just not always necessary. Those of other projects cannot always be compared, but sometimes you just have one specific field that you need, for example, for a roads project, you don't need it for a medieval excavation. IDA field currently consists of 3 different software components. So the desktop application field desktop for entering data, the server application field hub for optionally providing the data online for synchronization, and the web platform IDA field web for publishing the data. Field desktop is the main component of the IDA field project, and most of the development capacity has gone into that. So the main functionalities of the application include a comprehensive resource management with a hierarchical view, as well as basic search capabilities, so full text, as well as an extended search with a field-specific search, the integration of geodata into the application, and the joint display of geodata with the respective resource data. There's an image management, so images can be imported and linked, and they can also be used as background images. There's a type management, so scientific types, for example, for pottery, can be stored hierarchically in catalogs and linked to finds. The configuration editor for easy editing the project configuration, as I've talked about. It also includes, for example, value list management. There's a multi-language ability. So with the upcoming version 3.1, data can be entered in different languages and also in, though not besides English, German, Italian, which might be interesting for you. There's also going to be a Ukrainian version. A simple matrix view, which is based on the Harris matrix and is automatically generated from the project's relation data. So this is not fully functional yet, full disclosure. This mainly looks like the first step of what we saw this morning, but maybe our colleagues can help us out to fix this and fix these problems for us. But this is what it looks like at the moment. Yeah, there's import and export and CSV, GeoJSON. I need to hurry up a little bit, so I'm skipping some of it. And of course, really important background backup files can be created. There's a Field Hub is a simple server solution to provide a permanent synchronization target for all projects. It is written in Elixir and currently deployed using Docker. Field Hub uses a CouchDB instance, but also allows synchronization of image files. Images can also be synchronized via Field Desktop, but yeah, it's just a slightly different project. Yeah. The IDA Field Web is a publication platform. I will not maybe talk too much about it. It is written in Elixir for the backend and React for the front end. All projects can therefore be shared with other researchers. And as you see here, there's a background map which shows you all the projects, and there's a little bit of the core functionalities already employed. So you can, for example, search for all finds of pottery, combining all the different projects. I know. Maybe I just go for, yeah, I've just skipped, unfortunately. So there was it's a very interesting approach that we took for developing. I would have liked to talk a little bit more about that. There was extensive testing. There is a lot of unit tests and end-to-end tests. And we are trying to stick to clean code principles. We're reusing code wherever possible, and there's a lot of refactoring involved. Yeah, what I do want to talk about, though, since the development of the version 2, IDA Field has relied exclusively on open source library and has been published on GitHub. So the link is here. And yeah, we have a lot of projects that are using it already, and I can recommend to try it out. It is a fully functioning open source project. It is decoupled now from the DII. So not only that's why we also renamed it from IDA Field to just Field. So it's also linguistically decoupled, and there's a lot of functionalities, which is why I didn't get through all of it. So yeah, sorry for that. And please contact us if you have questions, which is the yellow part on the bottom. Sorry.
So thank you very much, Juliane. Now we proceed to our last speaker for this panel, Eleonora Jacopini, which give a talk of Punto Zero, a web app for management, use, and collect the archaeological data inside the public archives, the case of Ancona. Switch.
Good afternoon. Thank you to Commission for accept my contribution. And I would like to introduce you today at Punto Zero, a web app for the management, use, and collection of the archaeological data inside the public archives, the case of Ancona. Punto Zero is a web application developed for the integrated management of archaeological data contained within the archives of superintendencies of archaeology and fine arts and landscape of Ancona, as a support tool to complement the normal protection and activities of the institution. This application allowed the digitalization and normalized cataloging of data in very simple and automated way. For example, it's possible to manage the historical archives, the administrative one, the dossier sector, the excavation diaries, the drawing archive, the photographic archive, and relating to every single archaeological site of Ancona. Data that are normally contained in all the archives of the Italian superintendencies. In accordance with the public purpose of data belonging to the superintendencies, the archiving forms of archaeological sites have been structured on the basis of Sidecar 3.0 model of the Italian Central Institute of Catalogue and Documentation, ECCD, to allow dialogue to the immediate transfer of data in XML format to the SIGEC web platform. This tool is designed to complete other reading exist, to give a different reading of the data entered in the system, with a purpose ranging from protection to research, as well as digital cataloging of data. In fact, this system not only supports data archiving according to the ECCD specifications, but also provide tools to allow the very quick verification of the overlap of public work with the knowledge archaeological heritage. These functionalities are relevant to preventive archaeology and provide to the administrators a consultation tool based on the geographical representation of archaeological evidence, facilitating the delivery of further prescriptions. The administration system is connected to a cartographic platform, which allowed the visualization of data as point or browsing the plans of the different archaeological contexts. The web app is equipped with a multi-datation and quota management system, which allowed association of chronology, depth from the ground level of the evidence and the type of the element, for example, wall, floor, channel. By compiling the full set of data, the floor plans will automatically be rendered in the different texture according to their chronology and typology. The web app has been tested on the site of Ancona by archive more than 12,000 relating 208 sites. The Ancona case. Despite the historical importance of Ancona in the context of the archaeology of the Mid-Adriatic area and of the Piceno district in particular, the tradition of studies and research is inadequate, especially from archaeological point of view. This partly depends on some lacunae in the documentation, but also partly on the lack of a systematic knowledge of the already available information, stratifying the archives and the information collected by the archaeologists of the superintendencies. In a nutshell, the systemization and critical collection of archive information represent an urgent need that this project intends to address. Above all, more than 20 years after the publication of the Forma Urbis by Stefania Sebastiani. The project was promoted by the University of Bologna and the Superintendencies of Ancona. At the first, there was an examination of all documentation regarding the urban context kept in the archive of the superintendencies. The letter is divided into various topographically ordered parts, including the historical archives, the administrative one, the dossier sector, the excavation diaries, the drawing archives, and the photographic archives. Every folder was analyzed, scanned, and archived in general folders that contain all the information regarding the different contexts. For the computerization of all analyzed data, we use the Punto Zero web app. It's connected to a web GIS that acts as a cartographic platform for view and browsing the online archaeological map. Specifically, for the development of the .0 web app, the client-side interface was constructed with a dashboard created by Bootstrap 5 framework, developed by HTML, CSS, and JavaScript programming languages. While, from the server point of view, the programming language uses PHP, thanks to which it's possible to update dynamically the web app data contained in a PostgreSQL database. The choice of PostgreSQL as against the classic MySQL is because of the WebGIS cartographic platform for the implementation of the online archaeological map. In fact, this database, its PostGIS extension, allowed one to manage geographic objects and to ask spatial questions about them. The web app provides different levels to access of the data, which are modulated according to their utilization. The range for simple tourists used to scientific research to becoming an update and effective tool for carrying out the task of protection and promotion by competent superintendencies. The data can be used internally and for other institutions or for freelancers who need to access directly online the data contained in the archive to draw up urban plans or preliminary assessment of archaeological interest connected with the construction of public works. The web app has a public part available to all users and a reserved administration area, accessible only to managers who have the authorization to input and modify archaeological data on the platform. The administrative part is made up of several sections: archaeological site, administrative archive, drawings, documentation, and photographic archives, a bibliography, research, user management, and assistance. In the section archaeological site, it's possible to consult the insert site, modify them, delete them, or insert new ones. The sidecar are made up of different information fields, deriving both from the documents prepared by ECCD and implemented specifically to meet particular cartographic and search needs. The first part consists of a series of generic information regarding the location of the site, its georeferencing and briefing description, intended for tourist and analytic use, as well as a more detailed one for researcher and professional. The documentation area lists all the records linked to the given site from the drawings archives, the photographic archives, and the administrative one. Therefore, it's possible, for example, to see how many drawings there are in the archive for each context, to have its description, the year it was made, the name of the person who's made it, and the archival reference number. It's also possible to consult directly the scanned version of document in the raster type file. Further section permit one to archive the toponomic data relating to changes in place names over time, as they are referred to in the various documents, to check previous investigations conducted on the specific site, such as non-invasive survey, explorative assessment, or excavation, with the written list of materials recovered. Finally, the generic section consists of two important areas. The first concerning the chronology and the other the quotas. These two sections are closely connected to GIS platform, since, depending on the chronological choice that will be made on the section, the archaeological map of the context will automatically take the color relating to the various phases for each digitalized element, and also the texture will adapt to the type of the classification chosen. As regards the chronology, for each site, it's possible to have a multiple entry in which to indicate the generic dating, the specific one, the century, the intended use. In this way, for the multi-layered context frequent in urban environments, the chronological sequence and the changes that a specific building has undergone over time are immediately evident, with extensions, the definition of the space, and variation exploitation of particular urban areas. In the same way, the every context has the possibility of having a multiple insertion of the quotas, specifying that the datum refers to, for example, a wall crest, a floor, a working surface, etc. As you can see in the slide, in GIS, there are only 5 fields. ED data is for chronology, ED sito is for the site, desk is for description of the single element, because the plans are drawing for the single elements of archaeological plan. Typo is the type of the elements, is wall, pavements, etc. And cons is if the elements exist or non exist. The data relating to the floors is automatically used by the system to create the digital terrain model of the city. The greater the number of quotas inserted in the web app, the more the system will be able to refine the creation of the ancient topographical surface relating to the different chronological phases. Another characteristic that be implemented within the site control board is related to necropolar context. In fact, in the field of the archaeological site typology, if the necropolis option is selected, a further section will appear in the general tab, which makes it possible to archive the data of each individual tomb relating to that context, with indication of the tomb number, of the sex and age of the interred person, the presence of grave goods, and the type of ritual funeral. This function was necessary for the archiving of data concerning, for example, the important necropolis of Villeray, which include more than 400 burials of different chronology and types, or for that, the Piazza Stamira. The .0 app has therefore been programmed for an integrated management of archaeological data, considering its complexity as an object of protection, enrichment, study, urban planning, but also an element of enjoyment by a aware audience, which through this more intuitive tool can be understand the ancient urban landscape and its transformation over time, because the city is an organism in continuous evolution. The versatility of the system permits easy application to other urban contexts, in that the logic underlying the software structure is not bound to a specific context, but to share data analysis methodology in the archaeological field, and particularly in landscape archaeology. Now we currently making the software adaptable to various needs, not bound a specific case, and we are available in open source mode with MIT license. Thank you for attention.
So, thanks all of you for your really interesting presentations. I'm just going to switch. Back for the discussion, and there will be on later. Okay, perfect.
We already have one question from Filippo Sala for Laura Carpentiero and Dora Dauria. Have you also experienced the loss of data contained in IFC parametric objects after importing them into other open source software like Blender?
Yeah, thank you. Thank you for this question. So I will try to reply in English, but also I just give more detail in Italian. I just replace in Italian, please, or no?
I don't know if Filippo Sala speaks Italian. I guess it's okay.
Yeah. Oh, is the problem? If you is the problem, I can try in English.
For me it's not.
Just for more detail. So I don't know, in English or in Italian? What do you prefer?
If you prefer to do it in Italian, I guess you can do it in Italian.
Try in English.
Try in English, yeah, okay. So So thank you for this question, and this is a very big question for the EFC format, interchange format, because during our research we tried to export some kind of typology of EFC format. I'll try to export parametric object create in BIM environment, in Revit environment, in EFC for some kind of EFC format. But this method, this workflow, sometimes create a real default for the series of data insert into EFC format. We hope to test to export some typology of EFC format in another software, free software, for example, in Blender. But this is another step, the second step of our research.
Okay, thank you very much. Probably there are a lot of questions in the room. Yeah. I give you just a second to think about. No, come here. I just give you a second to think about it and make a quick comment. As I said in my introduction, I think, and we have seen today, there are really a lot of solutions and a lot of development regarding new software solutions to document field data, archaeological field data. And there are a lot of solutions which try to adapt existing analog workflows. And on the other hand, there are really innovative solutions which try to go beyond the analog and try to find a way to really use the digital. If I would have to put up a scale, maybe I would probably put either field on the more conservative side. We try to adapt analog workflows first, and something like the virtual RTI application is a more innovative approach. And I think to really change the way we work and change our methodology is a hard thing to do. Revolution is really hard. And there is a saying, if you would have asked people before the invention of cars what they want, they would have said faster horses. We, for example, we have asked our researchers what they want, and they wanted an analog workflow in the digital world, but with some bells and whistles and a little bit of extra functionality. And I think we went the way of evolution and not revolution with IDA Field. We have chosen web technology so that later on we will be able to maybe accommodate some more revolutionary workflows or change of workflows into the digital work. But at the moment, for example, we are still quite on the side of the classical single context recording, which our archaeologists are used to in the field. So, and now I talked enough time, and you can ask your question.
It was a very important point, I think, from my point of view. I have a sort of selfish question as a funcionario, an officer of the superintendenza of a very small office in Liguria. And the question was both for Eleonora Jacopini and Federica Rinaldi and Ascanio D'Andrea. I think Eleonora kind of replied at the end, but I didn't quite get it. So you said you are going to release the software under an MIT license. Is that okay? Maybe and seeing the EDI field source code release, the other question, of course, having to manage smaller sites, but with the same kind of conservation problems. The question is also for the Parco del Colosseo. Are we going to be able to reuse your complex software platform also in other parts of Italy, in other sites? Okay, so this kind of this, but I mean, there's another kind of worms about software maintenance and server maintenance, but I think this is maybe too technical. But let's say first step towards sharing of platforms is very important. Thank you.
I'm not sure if our online listeners got it, but the answer has been a yes. It will be.
Yes, answer. It's I agree with what is said about the question reusable software, etc. Mostly, this kind of approaches. For example, the approach for the Archaeological soil is a 3 years project that is running. We are learning by our job. So the first thing that we are going to do probably is to sharing the data model and the approaches because it's a very important project between conservation and archaeology. So you just understand well that it's the right approach that you can apply to your own site, and after you can. We are using open source software, so software are changing all over the time, but it's important for us to share the approach and the data model we are going to use in the next video.
Thank you for the question. And then I wait that put online the Ancona project, and then be available the program on online MIT license for free use.
Stefano anticipated the question I had for the Colosseo project, but since Stefano was not here on the first communication, I have a similar one for the first for Carpentero and Dauria. I mean, they used Autodesk Revit as a historical or Archeo BIM solution. What about other kinds of software solution? I mean, we had an effort from Filippo Diara and Rinaldo in ArcheoFOSS 2020 about using a FOSS solution for historical BIM. And another question is, if this library they've made of the building techniques of Pompeii, is it available for general public to use and to refer to, also to have some confrontations and etc. So to what extent their work can be reused by the community? Thank you.
Yeah, thank you for this question. You have to see, you will use the Autodesk Revit. No, I would use it just this suite for the modeling in order to obtain the BIM model. But in the future, we will try to use a different typology of software. For example, ACA software. And maybe some kinds of different typology of software. We use Revit because Revit is a common suite for the manager, to create and manage a BIM object. And the second question, please, on the library. On the parametric library, yeah.
The library of building techniques in Pompeii, is it public? Can we see it?
Yeah.
Yes, it will be one of the aims of our project is to give to all the scientific community this library in a way that everyone can use it and eventually reach it.
Yeah, the goal is to create a complete library for the evidence to Pompeii, some Vesuvian context. But now it's limited to archaeological evidence of domestic archaeological evidence. But in the future, we hope to complete this product, this library.
Thank you very much. Juliane, you had a question?
Question and what question? It's more a comment. I think part of it is that software reusability is really difficult. Like I think we're now moving on slowly from creating a database and publishing it online or making some kind of web app, but the maintenance is really the problem, and I think we really haven't found a solution for that because, like, yeah, for us it's the DAI. They probably still exist in 100 years, which it gives us a really really lucky opportunity that if the head office decides to manage the software to the end of our lifetimes, that's great. But for most projects, they have 3 years funding. There's a product, and then what? So I mean, it's we can publish data models, we can publish libraries, we can publish parts in other open source software like QGIS, for example, is a popular solution. But I think it's really, really difficult for scientific output because that's what software is in the end too. It's scientific output. And then, of course, attached to that, the databases that have been created. So I think these are two different levels in which we kind of have to think about sustainability and formats. That's what I wanted to say. And for what you said, I would agree that we're taking a more like single context sheet approach. On the other hand, I think to create innovation, we need the data first. And I think that's what we're trying to solve a little bit, to give researchers a really kind of clear way to data publishing. So it's like you take your data in the field and then you have a direct pipeline to publish it. And therefore, other people can take that data and reuse it, especially if there's a common data model. So I think it's quite classic because we have to, like, in a way, people don't let us to be innovative right away. But I think with all the data being created and publicly available, I think that's a real opportunity to make something great out of it. That's what I wanted to say. Thank you.
Yes, thank you very much. I may add to that. We learned a lot, as we have seen from previous projects. We got this Open Infra project, which unfortunately did not produce any workable code because it was too theoretically. There had been a lot of ideas. They wanted to do nearly everything. They wanted to have a 3D GIS, nearly everything you can imagine within this software, but they never produced really a workable software solution. So with IDA Field, we took a different approach. We just said, okay, we're going to develop a minimal working project. People can enter their data, and if they're happy, there will be more data, and then later on we get a comparability by consents, because our idea is to create a kind of marketplace within our institution, within the Germanico, to share your data models, to reuse your data models, even your categories. And now we are going to take a more open source product approach. So we are opening our software. We want, not just because we want to give something to the community. We have a self-interest, of course. We want to get people to use the product and to help us develop it further and to add to the data model and to reuse the data model and help us improve the product. So I don't want to deprive you of your well-earned coffee break. So I would think if there are no further questions, we are going to the coffee break now. Yeah.
We can take 5 minutes more than what's reported to the program for the coffee break. So we have a little bit time in the evening, so we can be a little bit more comfortable during the coffee break. So we'll meet at 5, possibly. 5. It's okay. Thank you.
Okay. Good afternoon and welcome to the third panel of the day, entitled Interoperability, Ethics, Policies and Technologies for Programmatic and Open Access to Archaeological Online Datasets. So interoperability today plays a key role in facilitating an organized and effective data exchange between information systems. So the interoperability is the ability of platform app software to communicate and process data without any involvement of the final end user. So in other words, interoperability allows different information systems to talk and comprehend information passed to each other. Before discussing the technological and the technical issues, I would like to shift the focus on the three main keywords of the title. So ethics, policies, and technologies. So this is very important because if the three concepts are not very well integrated, any interoperability can work properly. So ethics, the ethical issues, to me, the most important is the awareness of the importance to guarantee full access to data sets and the digital assets, especially when the data collection is funded by public money. And this is important also because this theme is connected with the theme of the policy, because today almost every project has its own policy to access data. In the future, we should aim to speak about shared policy. So between the project. This is a very pivotal aspect because when the three concepts doesn't go together, the interoperability doesn't work properly. Or these three important concepts will deserve a 3-day conference maybe, but I don't want to steal more minutes to this important presentation from here in Rome and from San Francisco, as we will see, and from Mainz. So now I will give the floor to the colleague Mirella Serlorenzi and Ascanio D'Andrea for the first presentation, SITAR, Sistema Informativo Territoriale Archeologico di Roma, API and Open Data Services for a New Archaeological Data Sharing Policies. Grazie.
Buonasera a tutti. Good afternoon, everyone. It is always a pleasure to illustrate the cultural and technological advancement of the SITAR system, a veteran of ArcheoFOSS events of the last decade. With this speech today, we not intend to retrace the history of the project, well known, but we would like to present the open data services released over the last 2 years. As you can see in the picture, SITAR is now able to address a wide range of user communities, offering differentiate tools to capture the data stored in the system over 12 years of activity. Since 2019, the WebGIS interface allows downloading all spatial data in these main open formats, as we will see in details later. But since March 2022, SITAR is taken a step further. The Superintendenza of Roma, making an avant-garde cultural choice, has in fact opened to public consultation and acquisition of the complete documentation of the excavation up to 2016. This means that any user, a scholar, a tourist, a technician, can download with an open license and without permission of any kind scientific reports, graphic, cartographic and photographic documentation of any excavation carried out on the territory of Rome. This is a real revolution, which can trigger a virtuous process of sharing information. But the need to establish institutional synergies with the other public institutions and projects that produce and or implement dataset in the cultural heritage sector has required a significant effort even in terms of interoperability. Thanks to the latest implementation, CITER today can provide a series of specific APIs to make REST call both to the Elasticsearch engine and to the REST API component. CITER is able to receive data from external sources and to configure and provide services in support of other infrastructure and or project based in the same standards of technological interoperability. As Ricardo will explain better, these services are already used by the former Rome project, an application of Soprintendenza currently being released, also fed by the CITER database through to specially developed APIs. I now give the floor to my colleague who will explain more technically the structure of our platform.
Thank you. Okay, so before describing the API, we should introduce the logical architecture of CITER. So the first module of the architecture is the WebGIS, the front-end application. This front-end is exposed by the Zul proxy module as a single-page application and interacts with the core of the architecture through REST API exposed by microservices of the CITER ecosystem. The Zul proxy is like a doorman because it's the first of the microservices that is contacted for every request coming from users. It has 4 main tasks: to sort the requests to the most suitable service, to display the front-end and static resources required by the web application, to mask the microservices from the outside by acting as a proxy and solving the related coarse problem, to protect data through authentication and filter requests based on the user's role. Another important module is the Elasticsearch, a powerful search server which allows advanced full-text searches for all types of data: textual, numerical, geospatial, but structured and unstructured. The data are stored in a PostgreSQL with a spatial extension PostGIS, while the physical documents are managed by a file service and the logstash service of the ELCAP suite. The cartographic session is based on a GeoServer instance, which is associated with a caching service for the maps. But at the center of the speech of today is the REST API module, developed in a Spring Boot and exposed via Tomcat web server, which has the task of exposing all the API necessary for the proper functioning on the WebGIS application. As we will see, it exposes all input and output APIs from the database in JSON format. So thanks to the approach of the recent years, CITER can now encompass the widest range of standards suitable for our data domain, be they for GIS environments or linked to interoperability between the system. So in general, when possible, we try to remain neutral, and we have chosen REST as the architectural style to expand our data. In short, all CITER services offer the negotiation of contents and their representation, so the formats, enabling other systems to query our services by choosing the most congenial protocol for the conversation. In our website, you can find out more information about our services that are of three types. So there's the direct downloads of all the geospatial data with attributes data, the geoservices, so VFS and VMS coming from our geoserver instance, and finally the API. So in this website, in this page of our website, you can have all the parameters to call our API that are of two different types. So one is for calling the Elasticsearch engine, and the other the API REST. So the Elasticsearch has a three-level call. The call is of three types. So you can search directly within our sheet of the excavation. This is the first, sorry, this first here, this first URL here. So here you are going to go, if you are going to search within the sheet, you can search also in the metadata of the document attached to every excavation, or at the later stage, you can search also within the documents, because all the physical documents are scanned with an OCR system. Through a specific index, you can search also within the document. The other API allow to call specific the single excavation through the ID of the every entity, or the single archaeological part, so the archaeological finds in a strict sense. So here, for example, you can see one of these, the API that is calling this HOI 55776. So this is an excavation whose CITAR code is here, so 500078, and as you can see, you have the system return back all the information, so the geometry on the attribute stored in our Postgres database. So in this case, you are calling one specific excavation. But at the same time, you can also customize your API, also because I will, as I will explain later, we have a mapping of all our data model, so you can also customize the API. So in this way, you are calling the Elasticsearch with a specific filter on the OE, so the origin of the information. This is the main entity of our system, and you are searching with a query that is in the field description should be present the word funerario. So and there's also a set a limit of 15 results. So in this case, as you can see, the response has exactly fit the query. So we have 15 results, and here in the description field, as you can see, there's the word funerario. So it's going in very capillary way in this sense. But this API is not only theoretical, but it's already in use, because we have a very strict collaboration with another important institutional project, that is the Forma Rome project, carried out by the Comune di Roma and the Soprintendenza Capitolina di Roma. So this is not a new system, but it's a system based on AIE that try to collect all the information coming from very different databases of other projects, but they have any data inside their database. One of the archive that can provide information in this case is CITAR, so it's our system. So this mapping has been possible because, as I already told before, we in 2016 we made a mapping of all the data model that is available in our website, and so available for everyone. So thanks to this important work, now we can map our data model also depending on the request that we received. So in this case, for example, the Sovrintendenza asked to CITAR a specific mapping in order to run GeoSearch data request and full text search within our engine. Here is a short example of this mapping. So this is an example. For example, if you look for Domus Tiberiana in their project, this is the WebGIS, is not in production yet. In the last month will be public, but it's in pre-prod at the moment. So if you find Domus Tiberiana, as you can see here, CITAR can accept the request and can provide the information. This is an example because the Domus Tiberiana, as you can see, the description field of the former Roma project contains the description that it's exactly the same of that one of the CITAR. So this is because they are calling exactly our database. At the same time, in Forma Rome, it's possible also to run a geosearch. So if you draw a polygon on a map, the system can extract all the origin information that CITAR provides. So also in this case, as you can see here, the CITAR is the first archive that is replying to this request. So to conclude, the CITAR open data policies are a different level. So on one side, we have the direct download and geoservices that guarantees transparency of our data, allow for a shared knowledge because everyone can use and reuse the data coming from archaeological excavation carried out by the Superintendenza for proper for studies, for research, for work, for job, for everything. At the same time, it's useful for management too, because you can build your own application by using data coming from CITAR. On the other side, the REST API services, so to allow a very advanced protocol for public platforms, so to avoid to replicate everything everywhere the same application that works in the same time, in the same way, but at the same time you can exploit the CITAR data to build dynamic apps that can recall our data. More in general, all our data are part of the semantic web, because with the linked open data can be recalled in various ways. So this is a very short overview on our system. Thank you for your attention.
Thank you very much. CITAR is a veteran ArcheoFOSS, so it's really each time a pleasure to hear news from you. Well, we go now from one veteran to a new entry that we are very happy to welcome for the first time in ArcheoFOSS. So I'm welcoming now Eric Kansa with some updates and, as he said, lesson learned from this very well-known project that every one of us have studied, open context. So if Eric is online.
I am.
Thank you, Eric, because it's, I believe, 8 o'clock in the morning there to you. So thank you for being here.
I'm trying to figure out how to do my screen sharing here. Let's see, just make sure that. Oh, I'm so sorry. Let's see.
Your screen is already okay.
Okay, can you see?
Not anymore.
Okay. I'm sorry, I'm not familiar with this application. There, that's the one I want. Okay. Buonasera, everybody. Or morning for me. I'm sorry I'm not there with you in person, but hopefully there will be future opportunities to meet and collaborate more directly. And I'm speaking to you from unceded land of the indigenous Wacheen people. And I want to get back to this point periodically in this talk, because with our own work with open context, we need to continuously put lots of thought and care into grappling with the consequences of issues like colonialism and how that impacts the ethics and practicalities of working with open data in archaeology, especially in the context of a place like North America, which has such a history of colonialism. Just a little bit of background about open context. We launched in late 2006, and since then we've published around 2 million records of data from around 175 different projects and collections working worldwide. And we're a free and open access publisher of open data. All the data have explicit Creative Commons licenses on them to encourage reuse, and the data do get reused. So there are several peer-reviewed publications resulting from the data we've published in topics ranging from zooarchaeological evidence of the spread of early farming in Southwest Asia to Europe, and we've also looked at other publications have documented modeling climate change impacts on coastal archaeological sites in North America. And others have published about issues and challenges in teaching with archaeological data. So some of the publications are about the sort of application of open data for pedagogy in archaeology. And we do aim to integrate with other systems, and we like to participate in linked open data. And we use linked open data methods to reference data, controlled vocabularies, ontologies, published and curated by other organizations. And for long-term data preservation, we rely on the services of our digital repository partners. And for us, that's especially the University of California's California Digital Library. So this idea of thinking about APIs and everything, for us, we wouldn't be able to exist without actually integrating with other systems, because for some very fundamental issues like data archiving, we do that with integrating with digital repositories. And for all of these efforts, we've earned some recognition from the archaeological community, professional societies, digital libraries, and also from the Obama administration for promoting openness and data sharing in the sciences. There are a number of challenges with this work, and some are more conceptual and some are more technological. I already sort of mentioned a little bit about some of the ethical issues. But what's really important about this is that we have very limited resources and limited capacity, and our attention is always divided. And this is a big problem in navigating all of these. This is one of the reasons why, as I'll get into later in this talk, we're actually very interested in doing more and more reuse of code that is curated and developed by other projects and shared across other projects. And specifically, I'll be talking about some of our work to try to integrate with ArcheoFOSS, which is an open source project, open source software application for cultural heritage data management that is mainly sponsored by the Getty Conservation Institute. And if we could reuse more code, in our case ArcheoFOSS, to address some of the technical challenges, then we can devote more time and thinking to addressing ethical, methodological, and theoretical concerns in archaeological data sharing. And so basically, we're trying to identify strategies that can help us really expand our capacity, and so that our attention is going to be less divided and less focused on dealing with maintaining our own code. Now, some of the complexity is sort of described here in this entity relation diagram. And for us, software is an important issue. There's inherent complexity with software in managing archaeological data, and that's because a lot of archaeological data is also really complicated. This entity relation diagram is for a data set that's in the Archaeology data service, and it describes Anglo-Saxon graves from one data set. And it's very complicated, and as we all know, and other data sets will have their own, but sometimes very different kinds of conceptual data models and schemas and structures to model their own data. So this complexity makes it hard, makes data reuse hard in archaeology, and it also makes research based on the syntheses of multiple data sets hard to accomplish. So the approach that we've done with open context, and this has been the approach that we've been continuing since 2006, basically, is that we use a common software platform to make this diverse and complex information easier to use and understand. And when we publish data, we do this through an ETL process, meaning ETL meaning extract, transform, and load. And we import diversely organized data into a common data store, and that data store is basically a graph in the back end. and that accommodates some of that can accommodate the diversity of the information that we publish. And during this import process, we do a lot of editing, and so a lot of the work that we expend when we publish data is about things like checking on identifiers to make sure that the identifiers are working okay, to try to maintain referential integrity, so that if there's a pointer to, say, between a zooarchaeological data set or an objects data set towards archaeological context, that those archaeological contexts are actually described someplace. And in this process, we also add some common metadata and annotations to common standards, and this is where the linked data comes in. And for us, there are basically two main flavors of this for linked data. Some of the linked data mainly serves interoperability needs, where we would reference project-specific attributes and controlled vocabularies, concepts to concepts that are more widely shared. So in the case of zooarchaeology, which is what you see on the right slide, on the left hand there, the map there is developed because several zooarchaeological data sets are related to the Uberon ontology, which describes anatomical elements, and GBIF, the Global Biodiversity Information Facility, which is used to as a sort of a glue scaffolding for representing biological taxa. And by doing that, then these multiple data sets from several different projects across Europe and Southwest Asia can be interoperable to a greater degree. And on the right side, other linked data kinds of approaches are more about establishing sort of narrative context of data. And in this case, you see a map of North America with each one of those areas represents an area where there are many archaeological sites. And these archaeological sites are cross-referenced with data that we've sort of extracted through entity identification from the Federal Register, which is a U.S. government database of publications about U.S. government regulatory decisions. So a lot of regulatory decisions about land use and whatnot are relating to archaeological sites and the management of those archaeological sites, and those are published by the U.S. Federal Register. But also JSTOR, which is a journal repository, obviously, and TDAR, which is a major digital repository in the United States. So these kinds of cross-referencing between different information sources are another important aspect of linked data. Very briefly, interoperability is not an all or nothing kind of a thing. So we sort of see it almost as a layer cake of very general levels of interoperability at the very bottom, very more specific, and where the semantics are more closely, tightly defined towards the top. And that's sort of our general approach, is that some applications need just care about more general interoperability. Some applications care about more domain-specific interoperability. And we try to make sure that we're providing data that meets those needs at various levels. Very briefly, these are just a couple examples of some individuals who've done some work using our APIs and data for their own kind of visualization kinds of projects. So one is Stuart Eve, who is doing this with Heritage Jam. That's an augmented reality visualization of some of the ZOARC data that we've published. And then another one is Mohammed Abdul Hadid, who's been doing this with trying to explore different kinds of data visualizations for looking at, in this case, artistic motifs on a data set from Poggio Civitate in Italy. Now, there's a lot of challenges. So we work at very different kinds of scales. So I've already shown you some of the sort of big macro scales with zooarchaeological data. This is cattle metapodial bones from Europe and Southwest Asia, but also more micro scales. This is Poggio Civitate, which is about 20 minutes south of Siena in Italy. It's an Etruscan site. And we're publishing data from this site, and you can see that representing spatial distributions of, in this case, Gorgon architectural elements, Gorgon decorated architectural elements on the site plan there. And what's important about all of this is that these are important kinds of applications, not just for research, but also for teaching. These are two spatial distributions from Poggio Civitate. On the left, you see textile implements, rocchetti, which are bobbins. On the left and on the right, you see spindle whorls, a different kind of implement used in textile production. And there's a pretty clearly different kinds of spatial patternings here, which may reflect something about the spatial patternings of textile production at this Etruscan site. And revealing this kind of information has been very useful. The excavations have been happening here for about 50 years, more than 50 years at Poggio Civitate. And being able to mobilize the data in this kind of way and present it in a manner that students can actually interact with has been really powerful for pedagogical reasons. And which is great, but unfortunately, it's also very expensive to develop and hard to maintain. These kinds of things. And so this is how I feel. I'm getting older now, and it's always pushing a boulder up the hill all the time. We've gone through about 5 major refactorings of open context since 2006. And obviously, and seeing all the other presentations and wonderful projects in this conference, we're obviously not the only people with very similar kinds of search query, visualization, and data curation kinds of needs. And bespoke one-off solutions are not ideal. So if we're trying to promote openness and data sharing and collaboration, we need to do that ourselves. We need to learn our own lessons about all of that. So this is one of the reasons where ArcheoFOSS comes in, and ArcheoFOSS really meets our key requirements. It has a graph-style approach for organizing very diverse information. It's capable of managing the diversity of the information that we routinely encounter with open context. But it has a lot more deployments, and it has, especially by organizations in the public sector that are some major organizations. Historic England is one of them in the UK, and it has a lot more investment than open context in terms of software engineering. There are a lot more people working on ArcheoFOSS. Has more features, better testing, continuous bug fixes, other sorts of improvements, and we really want to benefit from that investment. So rather than reinventing the wheel, as they say. And not only does this, because it has so many adoptions, simplify our own adoption, but a lot of the components that are in ArcheoFOSS are actually very familiar to us, that we already use them in open context, and particularly Django, Python. And so this is something that's widely used and maintained by the open source community, and that also makes it very attractive for us. So our own next steps with this is that we're trying to make open context right now more modular, and we're doing some experiments with data modeling. A lot of the archaeological projects that use ArcheoFOSS often base their own data modeling around the SciDoc CRM, and we've done less of that with open context. We've done it just somewhat with open context, but there's a lot more that we can learn from the data modeling efforts and other projects that we'd like to try to implement, and so that we see this as an interesting opportunity to improve the semantics of the data that we curate with open context. And just another experiment here. This gets back to some of the ethics and sort of notion of decolonizing. We've been testing a data set documenting early mosques that was created by Hagit Noel, and we've published with open context, and it's a multilingual Arabic, Hebrew, and English data set. And we've been working with that to test some of the internationalization features of ArcheoFOSS. And it's been very valuable for us to gain experience with ArcheoFOSS, understand its internals more, but it's also been valuable for us to contribute to the ArcheoFOSS project by helping to debug and test some of their internationalization features. So, just to conclude, we are working on this to obviously enable us to focus more on the ethics, governance, reuse kinds of questions, the method and theory kinds of questions of archaeological data rather than maintaining software. We see that this is working with larger platforms that are better maintained and sustained can help us. And we hope to see this as an example that we can work with other systems also to really build out and improve the kinds of collaborations we do with open context. So thank you so much for your time and attention. And I'm very sorry again that I'm not there with you in person.
Thank you, Eric. If you can stand there until the discussion after the end of the panel. Thank you. Then meet you later. Thank you.
Thank you.
So the next speaker, if it's there, should be Florian Thierry and Peter Thierry, who'll talk about linked data, OGAM, I guess, how to publish and interlink various OGAM data. Please correct me if I'm wrong in spelling the OGAM script. The floor is yours,
right.
Florian.
Okay, so hopefully you can see my slides. Yeah.
Yes.
Okay. So yeah, thank you, and yeah, thank you to give me the opportunity to speak about OGAM and linked open data. 2 years ago, I had also a talk with a friend of mine, with Sophie, about that topic, and in the last 2 years, some things developed and so on. So I will just show you some new aspects of the whole thing. And I think it could be a very nice connection to the talk of Eric before, because it's also about a bit more about linked open data, and also about a different kind of techniques and ideas how to create sustainability. So yeah, I will talk today about linked open OGAM and how to publish and interlink various OGAM data. My name is Florian Thierry. I'm a research software engineer at the Department of Scientific IT at the RGZM in Mainz. And yeah, for this OGAM project, I got a fellowship from the Open Science Fellows Program from Wikimedia Germany in 2020. So in the COVID phase, but yeah, I will just show you some results and some new things on that. Yeah, and you will see a lot of pictures in this talk, because me and my dad, we had a trip some weeks ago in Ireland to visit the OGAM stones in the field, and I will just show you some pictures and some technical aspects and semantic modeling behind that in this slides. So yeah, what's OGAM? OGAM is basically some kind of a script, early medieval script from the 4th to the 6th century AD of some kind of primitive Irish inspired from Latin somehow. And yeah, mostly distribution. It's distributed in Ireland, but also in Wales, England, and all in the Isle of Man. And mostly it's written on stones, but it also appears in other objects as well. But the stones are right now also in the field in Ireland everywhere. So this OGAM inscriptions contains some of names and relations, and these inscriptions feature kindship or tribal relations, and could be markers of clan territories, cenotaphs, or just try to present some important people somehow in the field. Also, the archaeologists in Ireland really don't know what they are really about. And there are some formula words. The most popular are maki, which can be translated in English to son, or mukoi, which could be translated to tribe. So maybe X is the son of Y, or X belongs to tribe Y, or something like that. And there are also some nomenclature words and names. For instance, kuna, which could be translated to dog or hound, or katu, which could be translated to battle, or something like Luke or Ag, which could be some kind of god somehow. And these OGAM inscriptions form a network in the end, so some kind of a graph, and that's the thing why we are in the domain of linked open data and linking things. So, for instance, if we have the stone with the number CIIC 200, it's written on that some kind of Maki whatever, Maki Mokoi whatever. So something, it could be that it's a son of Dal, son of Georges Fergus, son of the tribe of Tocha, and so on. So you maybe have a lot of relationships between people, tribes, and so wherever on the stones. So our aim in the end is to have linked open data, and we want to provide and integrate own data in community hubs as linked open data, just to share it with others. And we think, and I think, linked open data is the future. Eric said something before about that. So just in short, linked open data is very simple. Just the linked open data principles just say that everything in the world just have an URI and an identifier, a unique identifier, which could be resolved in the internet. You can just get some data, and it's linked everywhere, and to build a huge knowledge graph, or the so-called linked open data cloud. But the question is, if you want to look at all Ohm stones from Ireland, where can you find them? And there are a lot of publications, books like the CIIC by McAllister. There are some online databases like the SIP database from the 1990s. There are some modern online and open databases like the 3D Ohm project, which already scans some Ohm stones and just published the 3D data and Epidoc XML files and so on. Also, the WebGIS from the Heritage Management in Ireland just shares something, but there's not really an official resource for linked Ohm. So, our project started. And it started nearly in 2019, where some research squirrels, so some friend of mine and me, just started to do something with that kind of own data. It was Sophie and Timo. In 2020, this project was, as said before, funded by the Wikimedia Germany Foundation and the Open Science Fellows Program. And normally I wanted to visit in this studies Ireland and the Ohm stones, but there was the COVID time and so on. So everything moved 2 years, and a couple of weeks ago I have done this kind of trip to the Ohm stones with my father, with my dad Peter, and you will see the results and also the modeling results in the next couple of slides. In the next slides, I will just show you how the open data workflow works in some couple of steps. So, and the hybrid Ohm LD workflow is based on the idea of open science, open software, open data, and the FAIR principles to create reusability and a modular IT infrastructure with community standards and commonly used interfaces. So in the first step, the origin data will be digitized and transformed just into a CSV file to do everything else in some kind of a structured format. Then in step 2, the data modeling schemes, so in this case, ontologies and Wikidata mapping schemes, are created to transform the data into RDF or quick statements for Wikidata, using Python scripts to allow also some iterations and to do it automatically. In step 3, the resulting data is then ready to import into an RDF4J triple store and Wikidata. So the RDF data goes into a triple store. Right now it's an RDF4J triple store, but it could be any triple store. But there's only one Wikidata. And on the same side, the data is stored and also published together with the scripts on GitHub with a direct connection to Zenodo. So every version of the data and of the scripts get directly in the UI and its metadata is described within CFF file. So yeah, I think hopefully everything is open and is citable. And so the resulting data is then ready to import into an RDF4J triple store. And Wikidata, that was the same thing. But you can then extract the data with some programs, research software to do some further analysis with open source software. And yeah, the big question is how to access this kind of data. So if the data is already in a triple store, you can just access this kind of triple store with a Sparkle endpoint. That's the cool thing about that. If the data is in Wikidata, you can just access the data by the Wikidata Sparkle query interface or several interfaces that Wikidata provides. Or you can use just a Sparkle endpoint in other research software. For instance, if there is an possibility just to integrate Sparkle endpoints into R if you want to do some statistics, like here some density maps or whatever statistics. Or you can use for QGIS the Sparkling Unicorn QGIS plugin, which is also work of the research school engineers of Timo Homburg and myself, just to integrate Sparkle endpoints and Sparkle queries in QGIS to do some geospatial things. And you can also use a reference viewer, which I wrote. It's just a small, lightweight JavaScript framework to find similar catalog numbers, or just a simple lookup tool to visualize find spots on a map somehow. So what are the next steps? We want to integrate OM data into OpenStreetMap because they are missing. We want to integrate OM data especially from the Dingle Peninsula, but that was the area where our trip was about. We want to update our linked open data that is already was created 2020 and the Wikidata items, and add more collections from museums and books. And it's we'll just show you some pictures on the next slides from the trip. There are some OM stones in the wild, like this one. It's on Dunmore Head, so the most western point of Ireland, which now have also an item in OpenStreetMap in Wikidata, and it's also available at the before mentioned 3D project, OM in 3D project with a 3D model. Same here with the famous OM stone with a hole in it in front of a ruin of a church. One more, which is lying on a church. Also a ruin. It was not easy to find it, and it was also not mapped in OpenStreetMap, so now it's also available there. And then we have also two more stones as an example on a graveyard, which were also not mapped on OpenStreetMap before, but we have also some nice 3D views and data models to download at the OM 3D website. Also this one, which is a bit hidden in the graveyard, as you can see. And there are a lot of OM stones in museums, in local museums, or also in the in the university at the UCC in Cork, at the Stone Corridor. There are 28 stones which you can just see, just without pay anything. That's a cool thing. And there are also two OM stones in the Trinity College in the Book of Kells exhibition. So that's a cool thing, and they are also right now in OpenStreetMap. And if you have that data into OpenStreetMap, you have a lot of more APIs and web services to get in this data, like histosm.org or the Overpass Turbo API, whatever. A lot more possibilities. So what are the remaining challenges? One of them is something that Eric before also mentioned. So problems in IT sustainability and hosting of resources for, in this case, non-institutional funded project is even a bit more complicated than if it was funded, because this is a project just in a free time somehow. And but I think we have a lot of opportunities, so data can be maintained by archaeologists or citizens scientists on GitHub or on Wikidata. And Wikidata edits are connected by bidirectional links between OM LLD and Wikidata. So yeah, just the big question at the end, how to solve that thing. So in our own case, we try to use the so-called squirrel power and the research squirrel engineers network to create a community of enthusiasts and looking forward. So if you want to join us and you're interested in these own things, just contact us. So that's it. And if you could just go to om.link, you can check out all the things and all the links. And the slides are also available on Zenodo. That's it. Thank you.
Thank you very much, Florian, for this insight and for the perfect timing as well. So now we go to the last presentation of the day. So I call here on the floor Marco Montanari, that together with Giulia Bogdani will present Towards Platypus version 5, interconnecting the archaeological research. Thank you.
Thank you. So, a lot of interesting things on sustainability, both from Eric and also from
it's a common problem.
Florian. Yes. So we'll talk about that, but we're not providing a solution, but seeking for one.
Yeah.
So it's a perfect place. Funziona online? Puoi chiedere se funziona. Grazie. So I'm going through a brief introduction on what Platypus up to version 4 is, in order to better focus together on what Platypus version 5 could be if we're going this way, or if you're choosing for another way, discussing together. Well, Platypus is a web-based relational database managing system, specifically designed to address the collection and analysis of archaeological field data. The initial stages, the very first version, dates back to 2006. It was designed to manage field data collected by the University of Bologna in an excavation in the Marche region at Suasa. And the main letters, BDUS, stood originally for Banca Dati dell'Unità Stratigrafica, database of stratigraphic units. Well, since then, many things have changed. Actually, Platypus is maintained by the Laboratorio di Archeologia Digitale here, located here at Sapienza, and its code is available on GitHub with a GNU Affero General Public License version. I will find links also on the slides. Well, it is a piece of software that you can install on your machines, but it is also a cloud-based and maintained installation. That the hosted version actually gives home to about 30 both Italian and international research projects, ranging from archaeological field data to broadly managing of cultural or heritage data in a very broad sense. This is a list of the actually maintained databases, so that's quite different one from another. Well, to foster collaboration and to foster also younger contributions, we are maintaining on our servers. But these are actually institutional servers, because we are on the GAR network of Italian research infrastructure. But we are also maintaining an, let's call it, educational version. I mean, younger people can create easily an online database with following their schema and maintaining that through time. And this kind of educational version is eligible to be pushed back to the mainstream and become an institutional project. This is just some testing playground, let's say, just to try with how it works. When also having investing sometimes to publish documentation on how to deal with Bradipus, how to install it, how to maintain, and how to document and publish your data over the internet. Also, the documentation is maintained on GitHub, so if you spot any mistypes, so please report or fork it. Well, it's a very traditional software stack because version 4, released 2 years ago, is based on a PHP, Apache, MySQL, PostgreSQL, or SQLite. You can have whatever database engine you like. And it uses JSON for project configuration. Well, basic concept, just to give you an idea, the idea behind Bradipus is that you don't have to use a fixed schema. So you can define your own, and all you have to do is to describe your schema into JSON. I mean, this is also a strong idea, an important idea to us, because it introduces some data literacy to archaeologists. So they are forced somehow to reflect on their research and to describe the data they are collecting. This is not something that happens all the time. Well, after all, basically, Bradipus 4, it's kind of thin layer of configuration files describing schema and data written in JSONs, and they describe database schema, tables, etc., relations, etc., access policy, data validation policies, graphical user interface that you need to interact with your data. So everything can be built from scratch. Well, the functionality it offers out of the box, I mean, you just describe your data and you've got working software out of the box, is basic create, read, update, and delete operations, different kind of search option, bulk data import and export in different formats, Excel, JSON, HTML table, CSV, whatever. Save and share complex queries, which is, since this is a multi-user database, many people are working together. Some queries are difficult to build, so you can save them and share with colleagues. Find and place, central vocabulary manager, etc., etc. Another thing, which is not core functionality, but this is a geographical visualization interface. It's called GeoFace, that gives you the possibility to view and edit on a map geographical data related to each of the features. So these are optional, of course, but you can add basic geometries, points, lines, polygons, whatever, and connect to each record of each table or of your database and view them on an integrated web map. Since it was originally built for archaeology, there are also some engines, focused on the easy management of stratigraphic data. So there is an inner engine that builds for you automatically directed graphs of Harris matrix, etc. And the data can be entered in a very easy way. So you just define relationship once, and you find that everywhere, and the matrix is built automatically. Well, of course, also some very complicated kind of graphs. Well, we rely here on GraphVis, as I said this morning, and D3.js, which is the base idea that it's porting of GraphVis on the web. Well, we're talking about APIs. Of course, there is a very simple integrated API into Bradipus. This was needed at first to pull data outside. This is meant for other data managers, metadata harvesters, long-term preservation, third-party solutions. You can back up your data as text or whatsoever into somewhere else in the cloud. Push data to web applications with a couple of experiments done with this. Well, these are not experiments, these are production applications, but you can use data on desktop applications like QGIS, etc. Mobile, progressive, data analysis software, R Studio, or whatsoever, also machine learning algorithms if you have some that needs data to be fed with, and basically anything else that can be built with structured data. So this is an outgoing door opened into the database that lets you export data on request on real time. Well, this is what actually in very fastly Bradipus does, and actually, but we're planning here, we're trying to focus out what can be the major rewrite of this project, because as any project software, we need always to think to the future. So I'll leave the floor to Marco to show you.
Okay, now you hear me. Okay, now I hear myself, so it's good. So, hello everyone. So what is Bradipus 5? The idea is to have a total rewrite of Bradipus, looking at a new software stack and a new architecture. Looking towards keeping all the elements that we had in mind before. So easy installability on premises and easy deployment, but looking also at microservices and composing the system made of several elements. The stack will be in Node.js, specifically Nest.js with JavaScript in TypeScript, and for both front end and back end. So it will be uniform language, so easier to maintain, and it's based on a new philosophy and a new idea of integration and changing the approach and changing the way we ask the research questions through this new stack. Obviously, there will be full backwards support, backwards compatibility with all the pre-existing software projects, but also there will be the possibility to reuse the whole block, the whole platform for API-centric projects and API-centric systems. And specifically, the Open API specification is under heavy development. We're defining just a thin layer of the API right now, just to have clear idea of what components and what parts we need to define and we need to connect from backend to front end, as I said, with the idea of also microservices. Why is it needed? Why is it a necessity to look forward into Bradipus 5? Bradipus, as Julian said, has been around since 2007 and has had several rewrites. We're now at 5, so at least four major versions have happened in the past. So its life depends on the evolution of code and of the needs that changed over time. And the web development systems in the last 15 years have changed a lot. We've seen them, those changes. All of us have seen those changes, and Bradipus 4 is perfectly working. But the idea behind Bradipus 5 will be to look forward in the next 15 years, maybe more, looking at the possibility to integrate other functionalities, other tools in not into a Bradipus 5 application, but in a Bradipus 5 ecosystem, which is the major change of perspective on this project. Who is behind Bradipus? It's Laboratorio, the Laboratorio di Archeologia Digitale, Open History Map, which is our association in Bologna. The license will remain AGPL, so everybody can contribute and use and reuse the software in any form and in any format. And the aim is to increase and enhance the community of collaborators and contributors. Also looking at the possibility to reuse the software for a completely different approach, because in the end it's a as Julian said, it's a thin layer of configuration files, and underneath it's an automated system. And in this case, it will be more API oriented. So there are already use cases that come to mind that can reuse this application in very simple ways to rely on this for front-end applications and other elements. By the way, one of the elements that we were discussing as one of the features of the new system that was there but could be enhanced somehow is something to share data structures, so that you don't have to reinvent the wheel, and that would be an amazing accomplishment. So let's discuss, because sharing data structure is the main topic of many of our projects that we discussed today. So there could be space for a larger project collection, data structure collection environment. So yeah, this is the idea behind the new Bradipus 5 project.
So to sum up, yet another bespoke project, but actually we are thinking for the next years for many thousands of records of archaeological data, and this is something that we can plan together. Yes, of course. So be it another software or another platform, or share something, but I mean, this is something that recurrent in these days. So this is material for common discussion. Thank you.
Thank you.
Ah, sì. Questa è la verità. Discussione. So we can open the discussion. We have some 10 minutes or 15 minutes, and then we can have a rest before dinner, the well-deserved dinner for those who are here. So any questions for the talks that we have heard in this panel? I don't see any from the web. Come on, Julian.
Thank you. First of all, thank you all. That was very inspiring. I think what I'm wondering is, we've heard from Eric and we've heard from you guys, so there has been 4 or maybe 5 refactorings, and I feel like looking at our history from what I feel, there's also been pretty much 4 because I left out a step when I was talking about the history. So I was wondering, do you think there's like a natural cyclic thing for software that just kind of, it just gets outdated? And I'm sure there's been research on the information technology side of things. So that was not my question. My question is, how can we kind of prepare for that? Like, you're proposing the idea of like a thin data layer, but what does it look like? So I'm sure that's standards in the end, like what the end result data has to look like. Can you maybe shed some light on that? Like what that's actually containing? Sorry.
This is possibly one of the most complex questions for software development, but I think that it's not the matter of creating a thin layer of configuration, but for example, in the new version of Bradipus, we were discussing of APIs that had to be offered to the end users, and we are defining them with as open API schemas, which means that we're, let's say, getting one step above the problem of how the software is made, because we're looking at how we expect the user to interact with the system before looking at how to implement it. Okay, we made a general decision that would be TypeScript and Next.js, but whatever, it can be Django, it can be Python, and this is the main element. We decided to move towards, let's define the API first, because then we will see what happens. Because the last slide that was slightly overlooked, but it's important. When it will be ready? We don't know yet. It's still very much a work in progress. But until that moment, when we will block the API and say, okay, these are the endpoints that we will offer, and so we can start working on the front end basically without having a backend, or vice versa. We can start working on the backend without having anything on the front end. But it's always like this. Having standards and relying on those standards helps us keep the decisions as far away possible. Keep the technology decision as far away as possible, so we can delay them until they're absolutely necessary. Meaning, okay, now we have to code. What language do we use? Python, JavaScript, whatever is in fashion in that moment. Rust. No, please no, please no, please no. They have a very good alternative to Electron, which I wanted to talk to you about because it's very lightweight. But no, Rust, no. But again, it's just a matter of delaying the decision, because this enables us, and again, delaying the decision and having something in the middle that avoids creating enormous blocks. And I'm one of the most prominent examples of doing exactly the opposite, because I start on a project and I start writing the code, and then, well, I have the API, then I start modifying the API and things happen. But if you want to look in a long-term distance, the only way is to define this layer, and then again, I said we want to implement it in JavaScript. Maybe we don't do that. We create the whole API as configurations for obviously Nginx as virtual host for single routes to go to specific endpoints, to go to specific microservices. Who knows? But defining this layer in the middle is the thing that keeps the thing running. It's the same thing that did OGC with the major APIs. We have WFS, whatever the implementation is, because WFS is a standard. And so this is the approach that we had when we defined we started defining the API in the middle. So, you're welcome.
It is the same from the archaeological point of view. No matter to have a beautiful server to deal with, you need to get conscious on the data structure that you are working with. What are you collecting? What are you documenting? And what are you saying? So if you are able to describe your schema, then your work as an archaeologist and IT specialist is done. The same on the technological part. If you define a standard description of what the software does, the software is not that important after all. You can change pieces or you can change it all. It costs nothing to get a good IT developer, give him the API and get a piece of software built.
Maybe I could add something if I...
Yes, of course.
Yeah. Yes. So, in the perspective of a research software developer, I think it's right what have been said. So, the old thing that is data is like wine and software is like fish and something like this. So, in between that, there are the most important thing, which is called standards. Somehow we have to model everything, in some kind of a community standard. And I think we have to live with it, that we have to not really reinvent the wheel with the research software and software things. But I think, software and technologies will develop in the future. And we just, have to have one anchor somehow, and this should be data and a standard in data, not the software, because it's not possible to, yeah, in my perspective.
I kind of anticipated what you were saying, because my question was about exactly the cost of development. I mean, I don't know if it's the right adjective, but it was humbling to learn that Open Context, one of the most inspiring projects and one of the longest standing projects, is kind of moving from its own development to using another platform. So in a way, I wonder if all these other smaller projects make sense as their own bespoke solutions. So the question is, and I'm thinking about CITAR, I'm thinking about Braripus, can you give us a rough idea, and of course the EDI project, so those that have gone through many rewrites and long development, can you give us a rough idea of the scale of funding that was needed to last all these years? Because you said it costs nothing to pay a software developer, but actually
when you had everything set, yes.
Okay, but salaries for software developers are not that small. I mean, I think they're higher than those for archaeologists, at least. So I mean, it would be interesting to have this kind of a view. This morning we were speaking about the cost of maintenance, the cost of keeping the server running. That is an entirely different problem if we think about it, but also the development. I mean, keeping your software up to date with newer versions, because the old version is not kept up to date anymore, and it's not a desktop program where you can say, well, whatever, I don't care about updating. But if you are developing a web-based service, not updating to latest versions means that you're not getting security updates, and your software could crumble in pieces anytime. So if you could, give us a rough idea of the scale of funding that was involved in all these years. Thank you.
Do you want me to address that? Some of that?
Scusate se rispondo in italiano, poi Ascanio o Riccardo traducono. E abbiamo fatto una stima non precisissima perché poi trovare tutti i costi nel corso dei 15 anni è molto complesso. Però abbiamo presentato i costi nell'ultimo convegno SITAR e ora vado a spanne, ma mi pare che siamo sui 3 milioni e 8. Quindi in 15 anni significa che noi abbiamo avuto di media un finanziamento di 200.000 euro l'anno, qualcosa di più. E tanto è breve, finisco, ma considerate che questi denari per l'80% sono stati sempre impiegati per il data entry, quindi la parte della progettazione è una quota parte molto ridotta e lì diciamo che siamo sui 30-40.000 euro l'anno.
So CITAR has a quite long history, so almost 15 years. So it has not been very easy to try to find all the administrative documents about expenses. But in total, in 15 years, are 3 almost 4 million euros, but the 80% has been dedicated to data entry, and as can you say, the 5% for the coding and develops of the software.
Just to give a...
Yeah.
Sorry.
No, I had a question for Eric, if I may.
Mhm.
Well, how important for you metadating from people that are depositing data to your repositories, and how does it cost? Not, I don't mean in terms of money, but in terms of human, let's say, labor to metadata the information that is being deposited in open context. I mean, that's the crucial part of making different things speak together.
Yeah, absolutely. I think that the majority of our efforts is spent on essentially data cleaning and the ETL process. So for us, it's, you know, we have code expense in maintaining and developing code, and that's one of the reasons why we're trying to reduce that expense. And we have expenses associated with publishing data in that ETL workflow, and a lot of that is going to be cleanup and standards annotations and whatnot. And depending, the expense is sort of scaled with the sort of scale and complexity of a data set. So if a project is coming to us, say an excavation project that's been working for several years, that has several different specialists, each specialist may be developing their own data set independently. Usually they use something like Excel to build their own data. Sometimes some people have relational databases. That is an expensive and difficult process because oftentimes it's difficult to reconcile the identifiers between one data set and another data set, especially context identifiers that make, which are so crucial to making a cohesive data publication for a project. We may spend anywhere between, you know, our own staffing costs associated with this are, sometimes it would cost us maybe a month or two of our own time to be able to process a data set that would be coming from, say, a 15-year project with 15 individuals with different specialists. So that it is an expensive process in some ways, but it's a lot cheaper than the excavation work itself, which is so much more expensive to build the data in the first place. So, you know, and the other thing about that is that it's an expense that needs to happen, but at least once you make that investment, it's a sort of a down payment on making future reuse easier to happen, because you've already put in a lot of work reconciling these different small component data sets, bringing them together into something more cohesive. That's a lot easier for other people to use in the future. So I think in terms of long-term costs, it's a good way to go about it, but there is more upfront expenses initially.
Any other questions or considerations? Well, thank you then. Julian? Okay, Julian. Yeah.
Yeah, just a quick note for our project. I can't really put a number on it just because it has been such a long process and it's been proprietary software. One person essentially modeling the database input forms in FileMaker, which is not really programming, but then it was DFG and third-party funding for different parts of projects. So I could do some research, and I think I will, because I think it is an interesting question, but I honestly couldn't put a number on it. At the moment, we have one person, which is Thomas, so that's the second session lead from earlier, and he is not exclusively, but probably dedicating, correct me if I'm wrong, 60 to 80% of his time to field. Maybe that helps. I don't know. So I mean the maintenance side of things, but then there's also, of course, server capacity and all those things. And my question was actually for Florian, if he's still there, which was the stones. Like you talked about that you're putting their location in. That you're putting the location in. And I was just wondering, for the ones that are like in the university or in museums, like are you also recording the original position? And if so, how do you do that in terms of data modeling?
At the moment, just if they are in a museum, and I just try to, so in Wikidata it's possible just to say where the coordinate belongs to, and the same is for OpenStreetMap. So I try to reference or give the right reference where the stone is, if it is the original find spot or the museum or whatever. And so I think that's the answer. I tried to model it. So in my own ontology, it's possible because it's it's integrated in the ontology, and it's also possible in Wikidata, and it's also possible in OpenStreetMap. So it's I think.
Thank you.
That's the main thing.
Any other questions? Okay, but finally, we shouldn't think of IT costs as something different from the research costs. I mean, when we dig something, we should also think of how to document it. And money spent for development, for buying software, it's part of the research. So it's all the same. So shouldn't divide the two things. So, well, for those of you who are staying to Rome, we'll meet at dinner afterwards. For the others, we'll meet tomorrow at 9 o'clock, both online and here. So thank you, everybody, for your participation. Good evening.
Thank you, and greetings from Germany to Rome.
Oh, thank you, Florian.
Thank you from California, too.
Thank you, Eric. Goodbye.
Bye.